Hey, this is Andrew Brown over here on freeCodeCamp bringing you another free cloud certification. And this time, it's the HashiCorp Terraform Associate version 3. And the way we're going to achieve certification is through lecture content, hands-on labs, and as always, I provide you a free practice exam. And so at the end of the day, you're going to get that certification and you can put it on your resume, on your LinkedIn to demonstrate that DevOps skills and try to go get that cloud or DevOps role you've been looking for or trying to upgrade to. So if you like the materials here, a great way to support more content like this is to look at the paid additional materials. It will also help you increase the odds on your exam, and it also really does help out and support the production of more of this kind of content. And if you are not familiar with me, I produce a lot of different kinds of cloud certification courses like AWS, Azure, Kubernetes, you name it, I've taught it. And so you're in really good hands, and we'll see you in class soon. Ciao. Hey everybody, it's Andrew Brown, and welcome to the start of our journey. And we're asking the most important question first, which is what is Terraform? And I just want to tell you that I'm on screen now, but I'm going to vanish here shortly and stay out of the way so that you can see the full content. But I just wanted you to know that I'm here with you the entire way, okay? So the Terraform Associate certification is a specialty certification in Terraform. Terraform is a technology produced by HashiCorp, and it's specifically for infrastructure as a code. And it's a declarative infrastructure as a code, and it's a cloud agnostic infrastructure as a code. We will dive into all of this in great detail in the introduction section. And just notice that I put an asterisk there on declarative because there is something special about Terraform that we will discover. If you are considering the Terraform Associate, then you most likely are looking for a DevOps role. You want to automate infrastructure or writing scripts. You want to work with multiple cloud providers, or you enjoy designing, iterating on end-to-end infrastructure lifecycle. So if this sounds like anything that you are interested in, then you would probably want to take this certification. I want to tell you that Terraform is one of the most in-demand skills for DevOps roles today. And it's becoming quickly the industry standard just because it is so flexible and works with all providers and goes beyond a lot of these other tools. And the Terraform Associate exam itself isn't that difficult, but I would say that the concept of learning Terraform is a bit tricky because, it's not something that you can just go do the lecture content and do the lab content. I had to do a mix of it. So in this course, you'll see me do lecture, lab, because I'm trying to solidify the knowledge as soon as we do that. This is not the format that I use for my other courses. It's just because with Terraform, it requires patience. It is a cyclical learning process to understand. So just stick with it. And by the end of it, you will be really good with Terraform, and so that's that there. So let's talk about our multi-cloud roadmap. I'm going to get out of the way so we have a little bit more room. And so, what I would recommend is that you start with an associate certification. So just getting my pen tool out here, if I can get it here. Here we have the Google's ACE, the Cloud Engineer, or maybe some level of AWS associate certification. I personally think the SysOps is the best pairing for Terraform, or the Azure Administrator if you're going for Azure. And quite possibly learning more than two would be very beneficial. But of course, whatever your primary provider you're using is where you're going to benefit with Terraform. And you really should learn this stuff before you do Terraform. It is super hard to learn both Cloud and Terraform at the same time. You should have that foundation before you tackle onto Terraform. And so there's a lot of different paths for multi-cloud. And just to kind of give you an idea of all the different ways you can go, you can go from associate to either Vault and to the Vault Professional if you're looking at a security background. But it's very common for people to get the Terraform and then go for Vault afterwards. But it's up to you to which path you want to take. How long do you have to study to pass this exam? Well, it's a spectrum based on where your background is. So let's take a look at beginners first. So a beginner to me would be someone that's never written IaC. They have not previously focused on automating infrastructure. They may not hold an associate level certification. So you're adding those additional hours or trying to make up the difference. You could be looking at 30 hours or more. If you're already experienced with writing IaC, but maybe just not Terraform, maybe you know Azure Bicep or CloudFormation, you already work in DevOps, you already comfortable writing scripts, and you hold associate level certification knowledge of a major cloud provider, then you're looking at something like 12 hours. But if you're looking for a general study guide somewhere in between, I would recommend between 1 to 2 hours a day for 14 days, and you'll be in a really good place by then. What does it take to pass this exam? Well, there is lecture content, and I have a lot of it. The thing is that the exam itself is very practical. It's not like AWS's exams where it's very theory-based at a conceptual level. This one is very much how do we use this technology? And so the lecture content is there to really support the lab content, and you really, really need to do the lab content because that's the nature of this exam. And to make this a lot easier, I do recommend taking some practice exams. We have a free practice exam, and we also have many more practice exams. If you take all these practice exams and you've done the labs prior to that, you're going to be in really good shape to pass. In terms of the content outline, I can't remember how many domains. Well, we'll see how many there are, but we have one. So understand infrastructure as code, so IaC Concepts. Understand the purpose of Terraform. Understand Terraform Basics. The use of Terraform outside core workflows. Interact with Terraform modules. Use the core Terraform workflow. Implement and maintain state. Read, generate, and modify configuration. And understand Terraform Cloud capabilities. So yeah, 9 domains. Something that's different about the HashiCorp certifications is they do not provide distribution of domains. What do I mean by that? Well, they're not weighted, right? So it's not like we know that like 8 is going to have a particular weighting that's higher, but we can look at the exam guide outline to see generally how many questions we probably would. So we could kind of infer our own weighting, but they do not provide it. So I would just say it's not known, but we'll take our best guess when we look at the full exam guide outline. Where do you take this exam? Well, you can take it in an in-person test center or online from the convenience of your own home. I do believe that the test center that HashiCorp is using is PSI or PSI Online. And understand that this is a proctored exam, so someone is supervising you, watching you, monitoring you as you take the exam, so that that there's no funny business happening, there's no cheating, and to ensure that that you gain that knowledge in a reputable way. So just understand that. In terms of the grading, you need to get about 70% to pass or around that. It uses scaled scoring. Is it possible for you to fail if you got exactly 70%? It might be. So always aim to get higher than 70%. And so I always say aim for a target of 10 to 15 above what the score is. If you're getting that on your practice exams, then you're going to be in good shape. In terms of the response types, they don't tell you exactly how many questions there are, but I've always observed there's 57 questions. And so, based on that calculation, I feel that you have 17 questions you can get wrong. There are no penalties for wrong questions, so always answer your questions. Do not leave any blank. The format of the questions is multiple choice and multiple answer. And then sometimes you get a fill in the blank, so type a one-word answer. Most likely it's going to be a command, right? So, or a flag for a command. So you definitely have to know the technical components of Terraform, okay? The duration of the exam is 1 hour. So that means you get about a minute to answer per questions. The questions are very short format, so it's not like you have to read a ton of text to figure out what's going on. The exam time is 60 minutes. The seat time is actually 90 minutes. So when we say seat time, we're referring to the amount of time you should allocate for the exam. So that means that would include things like time to review the instructions, show the online proctored your workspace to make sure there's nothing going funny on with your environment, read and accept the NDA, complete the exam, provide feedback at the end. And I'm going to tell you, you really do want to get for your exam much sooner than you think, because it is a very stressful process and things tend to always go wrong when when you don't show up early enough. Okay, so just make sure you do that. If you do pass this exam, it's going to be valid for 24 months, so that's 2 years before recertification. And the last thing I just want to talk about is, well, maybe not the last thing. I got 2 more slides here for you, but this course is going to be designed around the 1.6.0 specification of Terraform. And even when I'm making this course as of today, 1.60 is an alpha. This will be in the future, so 1.60 will be out. But I like to try to give you more knowledge in the future, even if it's not an exam, just so that you are prepared and this course does not go stale sooner. Terraform is always incrementing in versions. So, when you study, you always want to go back 3 minor versions. Since I'm showing 1.60, it doesn't make a whole lot of sense. But if you were, let's say you're on 1.54, you'd want to make sure you know Terraform for a range of versions going a few versions back. And so, I will be showing you things that may be deprecated, but are still, but might still be in use based on the version that people are using. So just understand that. And again, these certifications are, or the Terraform certification is heavily dependent on your practical knowledge. So if you are taking the time to apply the knowledge, this version differencing is not going to make a big difference. Okay. So just make sure, you put the time in with the labs. Now, this is the 3rd version of the certification. And so I just kind of want to tell you that not a whole lot has changed between version 002 and 003. One of the big differences is they changed the badge design. Why? I don't know. Is it better? Who cares? But it is a different looking badge. One thing is that there were superficial name changes to the outlines of the domain. So basically all the domains are the same. They just kind of did some tweaks there. They did kind of cut some content out in the first 2 domains, because those ones were just more general concept knowledge, and so they slimmed those down. I'm leaving that content in this course because I think it's very valuable to know more rounded knowledge there. So you're going to be over prepared for those first 2 domains. There used to be this thing called Provisioners. It's still in Terraform, but the thing is that it's just no longer needed to know in the exam. So this is about doing remote execution and knowing all the Provisioners. And so, local execute and remote execute are things you need to learn, and definitely something that you will use on the job. But knowing how to provision and use a lot of provisioners is no longer a focus there. There's this thing called null resource that we learned about, and now they have a new thing called Terraform data. So that is a evolution of Terraform data. So we'll still learn about null resource, but we'll also learn Terraform data where it makes more sense to use. Terraform taint has been replaced with just a flag called replace on the Terraform plan. And we have a few more others like that. So refresh has a flag. And the thing is that when I made this exam the first time, they were already talking about doing this. So this exam is already, my previous one is up to date with the current version of 003, if that's surprising here. Terraform Workspace is no longer part of the exam. I will still cover Terraform Workspace, if we come across it, because I still think, again, it's practical knowledge that you should know. Connecting to Terraform Cloud now uses its own cloud block instead of remote block. I believe that we can still use remote block here, and I will definitely test that in the labs in this course. So, it's good to know both of them, but the focus will be using cloud block. We have the lock file. So the lock.htcl files are new. They weren't new when I made the previous exam, so they were already in there. So again, I already had this content here, but I'm just pointing out that that's something that they're focusing on within the certification here. You need to know how to mark data as being sensitive. Again, that's something I had in the older exam. But one major thing is Terraform Cloud has a new UI, and it looks like there's a lot more functionality. So in terms of the old exam or course that I produced in this one, I'm definitely going to have to reshoot all of Terraform Cloud and go deeper into it. There's obviously a few different functionalities that have been added, like the Terraform Cloud block, the Terraform data block. But for the most part, There's not a whole lot that has changed, so the majority of this will be very similar to the last one, but I'm just touching up and improving lab content where we can, and hopefully adding a lot more additional content to expand the Terraform knowledge that I wasn't able to do the first time around. So hopefully that gives you a good idea of what you're getting yourself into. But yeah, we will proceed forward to looking at the exam guide. Hey, it's Andrew Brown, and welcome back as we are taking a look at the exam guide for the HashiCorp Terraform Associate certification. I want to tell you, throughout this course, I'm going to show you where I get things. So I will be going to Google, I will be typing in where things are. It's not because I don't know where things are. I'm doing that for your benefit so that you build up the skill to know how to find things just the way that I would go find things. And I'll be very transparent about that. So for this one, all I did was go into Google and type in Terraform exam guide, and so I found it here. This is also the place where you can register for the exam. So if you click this, it should load up certain metrics. It'll make a pop-up. You have to authenticate it. I'm not showing that here right now, but when you are ready to register for the exam, you can go ahead and do that. You'll notice they also have this button here called Prepare for the Exam. They have their own study guide here. It's very text-based heavy. I do believe that somewhere in here there is a way to launch tutorials, and this will launch sandbox environments, I think through Instruct, at least the last time I checked. Those are great if you don't have an environment set up. What I want to do with you is I want you to set everything up in your own environment. Because I want you to have those real world skills so you can use this stuff adjacent to this course. I've gone through all this material here. I'm trying to cover things that aren't in here and try to make sure that we are doing things without guardrails, without the bullying bumpers, because I want you to get that real world experience, okay? But I do want to point out that this is here and you can use it, and it's okay. So let's scroll down and take a look at our exam guide here. And so here they say we have some prerequisites. So they say basic terminal skills. That makes sense. We're going to be doing a lot of stuff in terminal. Basic understanding of on-premise and cloud architecture. I think what they really mean is, do you know how to use AWS? Do you know how to use Azure, GCP? What is your major cloud provider? Or stuff like that. Now I keep talking or focusing on AWS, Azure, GCP, but understand that Terraform can be used for anything as long as there is a provider for it. It can provision on almost anything, okay? And that's why they're being very generic in their description. This says the product version tested is Terraform 1.0 and higher. So it shows you that this is still, even though it's the 003, it's still really the 002 exam with some minor tweaks. But just understand in this course, we're going to go well beyond this because I'm just future-proofing you and making sure you have real-world skills. Let's scroll on down here, and let's just read this about renewing your certification. So if you hold an unexpired Terraform Associate 002 certification, you can take the new one starting 18 months after your previous exam. If you hold an unexpired one, you can take the new exam starting 18 months after your previous exam. If you hold an expired one, you're eligible to recertify at any time. I really like this because what happens for me with certifications, not a problem for you, but a problem for me is that I will sit a certification and then 9 months later, the new one comes out and I can't sit the new one and tell you about it. So it looks like we've gotten a bit of flexibility there. And again, I'm on video here. I will get out of the way. It's just that we're in these earlier videos and I want to just hang out here with you, okay? Going down below, we can confirm it's the 1 hour duration. This is $70. It might vary based on your location and other stuff. I just don't want to tell you that it's $70. I want you to go through the process and find out yourself, but that's probably what it's going to cost you. There is no free retake included. Some certifications like CompTIA, you are or the Kubernetes ones from Linux Foundation, you basically get a retake. So you're basically paying for two, and they call it a free retake, which it really isn't free, but I think this is okay. I think it's fine that there's no retake. It's in English, expires in 2 years. We covered that before. Let's take a look at the exam objectives. So the first one is understand infrastructure as a code and concepts. They used to have a bunch of junk in here. And honestly, I didn't even know what they were talking about when they said that. I remember I had to comb through the study guide and try to watch articles and stuff like that. But I think they realized that it was junk. that they were trying to impart too much conceptual stuff, and they cut back this one here. Same thing with 2. It doesn't show us the comparison of the old one. At some point on this website, they showed the comparative between 002 and 003. But all I'm saying is that they cut back here. I have a bit more content on this in the course. It's not going to hurt you to watch it. It's just going to help you understand it, but you're not going to be tested 100% on this stuff. The other thing I want to note is that for each point that is here, each subdomain or point, or whatever you want to call it, they're going to ask you a question on. This is very different way of designing an exam. Other exams like AWS, they will list a bunch of stuff, but they say it might not be on the exam, or it might have stuff that's outside of it. So you just have to broadly study, and you will over study for the content, because you just don't know what you're going to get on the exam. For HashiCorp exams, they're very fair. If you know each of these points, you can expect to see them generally on the exam, and that's how you're going to know that you are ready if you know all these things. In this course, we're going to go beyond that, because again, I want you to have those real world skills, but just feel confidence in knowing every single point here. Going down here, understand Terraform Basics, install and version Terraform Providers. So that is what we will be doing a lot of in this, because we're going to at least touch more than one provider. In this course, I'm not going to go in great detail on the cloud infrastructure part of it, because you're already supposed to know it. And I'm going to leave that for other things, doing future projects for specific for specific cloud providers. We're focused here on Terraform in this course, not the underlying providers, but we do use multiple ones here. Describe plugin-based architecture, write Terraform configuration using multiple providers, describe how Terraform finds and fetches providers. So you can see there is a lot of stuff about providers, not to be confused with provisioners. I said earlier that provisioners is no longer covered in this certification course, but again, the material's here so that you can learn it for real-world practice. Use Terraform outside of core workflows. I think this used to be like use Terraform CLI outside of core workflows, so they made a small tweak there. So it says describe when to use Terraform import to import existing infrastructure into your Terraform state. Terraform import is super, super powerful. Going over to other providers, for a long time, AWS did not have an import option. So the idea is that by having this import, we can bring an infrastructure that was not necessarily there before. We have Terraform State to view our Terraform state. Something that you're going to find unique to Terraform is state management. It's something that's super important, and it's probably the hardest concept in Terraform, because when you use something like CloudFormation or Azure Bicep, the state is managed by services on those providers. There isn't a managed service on those providers, and so you have to decide where you want to put your state. And one example would be Terraform Cloud, and that's one that we do use in this course here. Describe when to enable verbose logging and what the outcome is. So you have to know how to debug things here, which is great. Interact with Terraform modules, so contrast and use different module source options, including public Terraform module registry, interact with modules inputs and outputs, describe variable scope and module child modules, set module versions. Modules is a way of creating reusable code. We are going to use public libraries as well as make our own modules. Making modules is not as hard as you would imagine, but they can get very complex. So, we're not going to go super advanced into modules, but we are going to make sure we can write our own and use public ones. Use the Terraform workflow. So this is something we're going to have to know a lot about, which is just the general lifecycle workflow of working with infrastructure as code. So we have init, validate, plan, apply, destroy, format. Plan and apply are the ones we're going to be using a lot of. There is a lot of trickery with the init, so that's something else that we'll do there as well. Implement and maintain state. So maintaining state, working with state, super, super important. So we'll look at how it works with local state, state locking, handling backend cloud integrations, authentication methods. They're talking about managed providers like Terraform Cloud. The difference between remote state backend options, managed resource drift, and Terraform State. Terraform is super good at drift and fixing drift. It's so good at remediation compared to other IaC tools, and that's why it is such a popular tool to use. describe backend block and cloud integration and configuration, understand secret management and state files. Then we have regenerate, modify configuration, so demonstrate the use of variables and outputs, describe secure secret injection best practices, understand the use of collection and structural types, create and differentiate resource and data configuration, use resource addressing and resource parameters to connect resources together, use HCL and Terraform functions to write configuration, describe built-in dependency management. And the last one here is understand Terraform Cloud capabilities. So explain how Terraform Cloud helps to manage infrastructure, describe how Terraform Cloud enables collaboration governance. I'm going to just tell you right now, we're going to probably do more Terraform Cloud than we need to. It's just because when I made this course the first time, I just lightly did Terraform Cloud, just enough to pass the exam. I have the time to do a little bit more there, and I would like to do that for your own benefit. And so we will expand on that a bit more. But you can see this is mostly about Terraform, the technology, not necessarily Terraform Cloud, the service. If you're confused about Terraform and Terraform Cloud, again, we'll explain that in this course and make sure it's very clear what the difference is. One other thing I wanted to note is that they do have some sample questions here. So you can go through here and you can just see that the questions are very straightforward. And they're just like this. They're very simple, but you do have to know what you're looking at. And see, like here, they're showing code. So you can see you have to choose code, and you might get a code block. So it is very focused on the practical component of it. It's less about the conceptual, okay? But yeah, hopefully that gives you an idea of what we're getting into, and we'll see you in the next one, okay? Ciao. Hey, this is Andrew Brown from ExamPro, and what I want to do is walk you through a few of our practice exam questions just to give you an idea of what it will be like on the real exam and where we might have had to make some adjustments to help your study. So what you'd have to do to access this practice exam is you'd have to be signed up and logged in to the ExamPro platform, make your way over to the HashiCorp Terraform course, accept the free tier or pay for full access. But once you go there, you'll scroll all the way down to the bottom, and you should see 3 or 4 practice exams at the time of writing this. We're still writing the questions, so that's why they're not shown in the video here. But what I want you to do is to go to the first practice exam and notice that there are 57 questions. You get an hour on the exam here, and we have a breakdown based on domain. Now, the percentage is not something that Terraform or HashiCorp provides, so we just had to break it down based on the coverage of questions that we saw in the exam guide outline, and so that should be accurate enough. And that's kind of what it felt like on the exam, so I don't think that's going to be a problem. If we click into here, we're just going to look at some of the questions and I'll talk around them. So the first one here is we have how do you create a workspace, and it's showing us a bunch of CLI commands. And so on the exam, you do need to know CLI commands and the difference of them. And the questions can be as simple as this, where you're just choosing the option, and some are obvious distractors, like there is no one called Terraform Workspace branch, okay? So just understand that you not just need to know the conceptual ideas behind Terraform, but also it in practice, okay? Another one here would be the Terraform registry can search based on the following search terms. We have an option to choose multiple questions, and so this is something that you will see on the exam where you're choosing multiples of something. I didn't get a lot on my exam, but I cannot say for certain like how many questions would show up like this. But they're not really that hard to figure out. Okay, and this question is about the public Terraform registry website, and that is just a public-facing website. If we go to registry.terraform.io here, it's this website here. So it's not just the tooling of Terraform itself, but it's the ecosystem around it. It's the Terraform Cloud, the Terraform registry, things like that. Another type of question you will see, and I think it's over here, is what they will do is they'll ask you to fill in the blank. Now, we don't have that support in our platform just as of yet, but the idea is they'll say like, okay, we'll ask you a question, or we'll even give you maybe they'll have like underscores and they'll say, fill in this thing, and you'll literally have to type the answer in. But the answer is going to be like a one-word answer. So on the exam, I literally had a question which was like, where is the API stored? And it was actually terraform.tfstate, but I could not recall the name of it, which is kind of embarrassing. But that is the level of fill-ins that you'll have to do. And you're very likely to see some code on the exam too. So if I just click through here really quickly, you may see a code block. Okay, and you might have to decipher it. So that's the difficulty of the exam. I would not say this is a hard exam, but you just have to understand the scope of those kind of questions and make sure that you have well-rounded study in both practical and conceptual concepts of Terraform. So hopefully that helps you out, okay? Hey everybody there, it's Andrew Brown, and I just wanted to tell you about the content that you're going through because honestly, between the 002 and 003, there was not much to update. And so, the key difference is the versions of Terraform and the versions of the providers that you're using. And for the most part, everything worked out perfectly fine. I thought that I'd have to reshoot all of the lab content. But it turns out, nope, barely nothing has changed. What has changed, and I want to point this out early on, is that when you are specifying a version for the provider, just go use at least version 5.0. You can use an older version if you want to follow along, but I think it's better to be more up to date if you can. The version that we were using prior in the follow-alongs was version 3. Again, there are no major changes that will break anything, so at least there shouldn't be, but I ran through these labs. My cloud support engineer ran through these labs, so we're pretty confident you're going to be in good shape. Otherwise, if they weren't, I would go re-record them, but I just wanted to point out those two things there. So hopefully, that makes sense and you're going to be in good shape, okay? Now, I did say that we're scoping things around Terraform 1.6.0. And again, there's not much to call out for that. The biggest thing that I think that 1.6.0 might bring would be testing. And even if I looked into it and it just wasn't where I thought it was going to be, so I did not include it, at least at this time, in this course. And again, this is me going above and beyond because I'm trying to just future-proof the contents of this course and future-proof stuff that I believe that is coming to Terraform. But yeah, you should be in good shape. And if there are any changes on ExamPro, we're very proactive of having those differences there. So if you do run into anything that's giving you any kind of issue, they're going to be on the main learning platform there, okay? If for whatever reason there's minor updates or things that are found out. But yeah, you'll be in good shape and have fun on your journey learning Terraform. Ciao. Hey, this is Andrew Brown from ExamPro, and we are looking at what is infrastructure as code. And before we talk about that, we need to talk about the problem with manual configuration. So manually configuring your cloud infrastructure allows you to easily start using new cloud service offerings to quickly prototype architectures. However, it comes with a few downsides. So it's easy to misconfigure a service through human error. It's hard to manage the expected state of the configuration for compliance. It's hard to transfer configuration knowledge to other team members. And so this is why infrastructure code is going to really help us out. So infrastructure as code, commonly abbreviated to IaC, and you'll see that a lot in this course, allows you to write a configuration script to automate creating, updating, or destroying cloud infrastructure. Notice I gave great emphasis on automate or automation because that is really key to infrastructure as code. IaC can also be thought of as a blueprint of your infrastructure. IaC allows you to easily share, version, or inventory your cloud infrastructure. And just to kind of give you a visualization, imagine you write a script and that's going to provision and launch a bunch of cloud services that are all interconnected, okay? All right, so we're taking a look at popular IaC tools. And so, of course, this course is about Terraform, but by understanding all the options out there, we can understand why we're using Terraform. And one thing that is very important to understand is the difference between declarative and imperative IaC tools. Those are the broad categories that we see for IaC. So let's start with declarative. So the idea here is what you see is what you get. Everything's explicit. It's more verbose, but there's zero chance of misconfiguration. And this all relies on the fact that they use a scripting language such as JSON, YAML, XML. In the case of Terraform, they have their own language called HCL. But the way these languages are structured is that they're very verbose, and there's not a lot of programming logic involved. So for Azure, we have ARM templates and Azure blueprints. For AWS, we have CloudFormation. For Google, we have Cloud Deployment Manager. And there is, of course, Terraform, which has many cloud service providers such as AWS, Azure, GCP, Kubernetes, and a lot more. But these are all in the declarative category. On the right-hand side, we have imperative. So You say what you want and the rest is filled in. Everything here is implicit. It's less verbose, but you could end up with misconfiguration. And when I say that, it's that like if you were to define, let's say, a virtual machine, you might not have to provide every single option that you would normally do, and that it would fill in the rest. But if you weren't aware of what it was doing, that's where you could end up with misconfiguration. Though I would say that imperative tools generally try to always have their defaults as best practices, so you're not usually in a bad position, but you might end up with something you don't expect. Imperative can do more than declarative, so there's just some very hard limitations with declarative languages. So there's just cases where you want to do imperative. And the idea here is imperative languages use programming language like Python, Ruby, JavaScript, Golang, whatever it is, there's likely an SDK for it. And so it's just a lot more programmer friendly. A lot of developers like imperative tools. So AWS has their own called Cloud Development Kit, CDK, and it technically only supports AWS. And I say technically because HashiCorp has a very cool library that allows you to generate out Terraform HCL files, which allows you to work with anything. But when we're just talking about CDK on its own, it's just for AWS. Then you have Plumi. It supports AWS, Azure, GCP, and Kubernetes. So it can do a lot. So why would you choose with your team to use declarative over imperative? Well, it just really depends on your team, right? So like if they're all administrators and they're used to using JSON YAML and they're not great with programming languages, that is one reason why you might want to use declarative over imperative. The other thing is just, you prefer to know exactly every single thing that was defined, right? You don't want anything left up to a chance, and so that is another reason why you might want to use declarative. But both are great options. It just really depends on your team's knowledge and what your goals are, okay? So we just looked at imperative and declarative, but I just want to clarify that Terraform, even though it's a declarative language, it has imperative-like features. So I've coined the phrase declarative plus, and so Terraform kind of gives you the best of both worlds. So you have declarative and imperative, and then the three types. So our YAML, JSON, XML. We have Terraform Language, which actually utilizes HCL underneath. And then you have programming languages on the right-hand side, like Ruby, Python, JavaScript, what have you, right? So when we're looking at YAML or JSON, these are very limited languages or scripting languages where you don't really have any kind of complex data types. You probably don't have a whole lot of robust functions, but in some cases you can extend that base behavior. So in the case of CloudFormation, which uses YAML or JSON files, they have a concept called macros. So you can extend it a bit, but again, it's very inflexible. And so a lot of people are led to go and use CDK. So Terraform is great because it kind of has a lot of stuff you'd see in programming languages like for loops, dynamic blocks, locals. It also has complex data structures and a lot of functions around using those data structures. And so it allows you to stay in that declarative world, but having the stuff that you generally need when you're in the imperative world. When you're in the imperative side, the idea is that the language is what you're utilizing, so you can do anything that the programming language allows you to do. But I just wanted to kind of show you that Terraform sits in the middle, okay? Hey, it's Andrew Brown from ExamPro, and we are looking at infrastructure lifecycle. So what is infrastructure lifecycle? It's the idea of having clearly defined and distinct work phases which are used by DevOps engineers to plan, design, build, test, deliver, maintain, and retire cloud infrastructure. When we're talking about like SDLC, so software development lifecycle, there's usually a really great visual that I can show for you. But for infrastructure lifecycle, especially cloud infrastructure lifecycle, there isn't something that is well defined, which is weird by the definition, but I think that nobody's agreed upon one yet, or nobody's made the graphic yet. So I just don't have anything to show you for that, but I just want you to get familiar with the term infrastructure lifecycle because you're likely to hear it again. But one particular infrastructure lifecycle that is pretty common is ones that talk about day 0, day 1, and day 2. So the idea here is this is a simplified way to describe phases of infrastructure lifecycle. So when we say we are on day 0, we are planning and designing our infrastructure. On day 1, we are developing and iterating it. So we might be, deploying or provisioning it and actually testing it in the cloud. And then day 2 is actually when we go live with real production users and maintain it. And the idea of mentioning day 0, 1, and 2 is to say, well, when does IaC start? And the idea is it starts on day 0, okay? The days do not literally mean a 24-hour day. It's just a broad way of defining where in the infrastructure project we would be, okay? So after defining what infrastructure lifecycle is, what advantage or what advancement are we going to have when we add IaC to our infrastructure lifecycle? Well, the first thing we're going to get is reliability. So IaC makes changes impotent, consistent, repeatable, and predictable. I'm going to give extra attention here to impotent because it is a very strange English word, but no matter how many times you run your IaC, you will always end up with the same state that is expected. That is a very important concept of IaC. Whereas if you use configuration management, there's no guarantee of that. That's why you'd use Terraform over something like Ansible, okay? You have manageability, so enable mutation via code, revise with minimal changes, and then you have sensibility, so avoid financial and reputational losses to even loss of life when considering government and military dependencies on infrastructure. So there you go. Okay, so idempotent is a very important concept to infrastructure as code, and so we're going to give it a little bit more attention. I wouldn't stress out about the pronunciation. There's more than one way to pronounce it in English, and I've probably even said it wrong in the previous slide, so just be forgiving on that part, okay? But the idea is that let's stage a scenario between a non-idempotent example and an idempotent example. So when I deploy my IaC config file, it will provision and launch 2 virtual machines. That is what I'm expecting, okay? And that is what I get. But what happens when I go and I update this infrastructure as code file saying maybe I want to increase the size of the VMs or some of the configuration, and I deploy that again when it's non-idempotent? What will end up happening is I will end up with 2 additional virtual machines with the new configuration, and the old ones will be there. And so this is something you might not want because you just want to have a file that says exactly the state that you expect, okay? So when we have something that is idempotent, the idea is we will go and we will define our 2 virtual machines, and we will get our 2 virtual machines, but we go and we update that file and we deploy again. And what happens this time is it just ends up modifying the original virtual machines, or if it really can't and it has to, it might delete them and recreate them. But the idea is that we end up in a state of exactly what we want. So in the first case, we expected 2, but we ended up with 4. But with the idempotent case, we expected 2, and we always end up with 2. So hopefully that makes that very clear, okay? Hey, this is Andrew Brown from ExamPro, and what I want to do here is concretely define the difference between provisioning, deployment, and orchestration. Now, in practice, sometimes these have overlapping responsibilities, so you might say provisioning when you really mean deployment or vice versa. It's not a big deal. We all get kind of mixed up about it, but I did want to just take the time to make sure that we understand what these things are supposed to mean, okay? So the first on our list here is provisioning. So to prepare a server with systems, data, and software, and to make it ready for network operation. If you're using a configuration management tool, you are most likely provisioning because that's what these tools do. So Puppet, Ansible, Chef, Bash scripts, PowerShell, or Cloud Init, so you can provision a server. When you launch a cloud service and configure it, you are provisioning it, okay? Then you have deployment. So deployment is the act of delivering a version of your application to run a provisioned server. Deployment could be performed via AWS Code Pipeline, Harness, which is a third-party deployment tool, Jenkins, GitHub Actions, Circle CI. There's a lot more other providers out there. Then you have orchestration. So orchestration is the act of coordinating multiple systems or services. Orchestration is a common term when working with microservices, containers, and Kubernetes. So orchestration could be done with Kubernetes, Salt, or Fabric. So if you're working with containers, generally, like you use the word orchestration, especially with Kubernetes, because you're working with thousands of microservices, okay? So, hopefully that helps you know the difference between those 3. Again, it's not a big deal if you don't perfectly know them. But there you go. Hey, this is Andrew Brown from ExamPro, and we are taking a look at configuration drift. So this is when provisioned infrastructure has an unexpected configuration change due to team members manually adjusting configuration options, malicious actors, so maybe they are trying to cause downtime or breach data, or side effects from APIs, SDKs, or CLIs. So you've written some code that uses a CLI in a bash script, and it does something you did not expect to happen. So here an example could be, imagine you have a server like a database, and a junior developer turns off delete on termination for your production database. This could be a problem where, let's say there's an accidental deletion of the database. This feature would protect the database from deletion, but if it's turned off, you don't have that, right? So configuration drift going unnoticed could be a loss or breach of cloud services and residing data, or result in interruption of services or unexpected downtime. So there's a lot of downsides to neglecting or not noticing configuration drift. So what can we do about this? So how to detect? So there's three things: detect, we can fix it, and then prevent it. Okay, so to detect configuration drift, if you have a compliance tool, it can detect misconfiguration. So AWS Config can do that. Azure Policies can do that. GCP Security Health Analytics can do that. Some of these are constrained to security things, not just configuration in general, but there are tools there for all the cloud service providers. There is built-in support for drift detection for AWS CloudFormation. It's called CloudFormation drift detection. Other providers don't necessarily have that. If you're using Terraform, which is all this course is about, you have the Terraform State files, which says what the state of things should be. So that's how you could detect configuration drift. How to correct configuration drift? Well, compliance tools can remediate. So again, AWS Config, you can create a custom Lambda to say, hey, when this happens, then do this. So set the configuration back into place. With Terraform, you can use the refresh and plan commands, which we'll look at in detail in this course. Or you could manually correct it. So if the option was changed, you could do that. Not recommended to do that. Another thing would be tearing down and setting up the infrastructure again, because that would bring it back into its original state. That could be a risky thing to do, depending on how you have things set up, or it could be fine, right? Then there's prevention. So this is the important thing, and kind of why we're talking about configuration drift, which is all about immutable infrastructure. So always create and destroy, never reuse. So that might be blue-green deployment strategies. Servers are never modified. They are just always deployed with a new version. The way you would do that would be baking AMI images or containers via AWS Image Builder or HashiCorp Packer, or a build server like GCP Cloud Run, or code build like AWS. But the idea is that you're not modifying after they're deployed. You'd have that image already ready to go. Another thing you could use is GitOps. So you would version control your IaC, like within GitHub or something like that, and you would peer review every single change via a pull request to the infrastructure. So hopefully that gives you an idea of things we can do to tackle configuration drift, okay? We were just talking about immutable infrastructure, but I just want to give it a bit more attention here. So the idea is we are going to first develop our infrastructure as a code file, Terraform, CloudFormation, what have you, and then we're going to go ahead and deploy that. So we'll end up with our own virtual machine, and then that virtual machine needs to be configured, so you need to install packages and things like that. That's where Cloud Init would come into play, Ansible, Puppet, Chef, Salt, whatever configuration management tool you want to use. The problem here is that there's no guarantee that that configuration is going to stay in place. So that's where immutable infrastructure comes into play. So we develop our infrastructure as a code file, Terraform, CloudFormation, and then we're going to go ahead and do our configuration by building a virtual machine or building a container. So we can use something like Packer. And then the idea is, once we are happy with our configuration, what we're going to do is bake that image and put it in an image repository, and then that image is going to be referenced when we do our deploy. And so that's going to make sure that our infrastructure is always immutable, okay? Hey, this is Andrew Brown from ExamPro, and we are taking a look at the concept or methodology of GitOps. So this is when you take infrastructure as code and you use a Git repository to introduce a formal process to review and accept changes to infrastructure code. And once that code is accepted, it automatically triggers a deploy and changes that infrastructure. So here's my illustration through it. So the idea is you would have a Terraform file, and you would place that in something like GitHub. You would apply your commits, and when you're ready, you'd make a pull request. You would merge that pull request into the main branch, or whichever branch is set up for production, and that could trigger something like GitHub Actions. And GitHub Actions would then trigger a Terraform plan and accept it, or maybe you have to manually intervene to say, okay, I accept these changes, but then it would roll out those changes. Now, Terraform does have their own, and it's pretty darn similar, but I thought mine was a bit easier to read. But the idea is you have your Git repository, you have your pull request. This is pulling from Terraform Cloud because you can have files and state managed there. So that is another means to do it, but that's generally how it works, okay? So we were just looking at immutable infrastructure, but what I want to do is just kind of cement in your head things that you should be asking yourself as a DevOps engineer so that you kind of lean towards that immutable kind of way of thinking. And so this is mostly going to be applicable for virtual machines, but let's just ask some questions of things we should be thinking about. So what's going to happen if we deploy our virtual machine and there is a physical failure of the hardware by the provider? So this can sometimes happen on AWS where they have 2 status checks that have to complete before a virtual machine is ready. Sometimes they fail, and so your infrastructure is not ready. It's degraded or damaged, right? Then you have application failure. So you have this post installation script, maybe to install your application, and there's either a bug, so introduced by developer, or maybe there's just a dependency and it's changed, and so it's breaking your app. What happens when you need to deploy in a hurry? What happens in worst case scenarios where you have accidental deletion, compromised by a malicious actor, need to change regions, maybe there's a region outage. And so the thing is that when you look at these things, what happens when multiples of these happen at the same time? Because that's the problem where, it's like, okay, I have something wrong with my application code, but I also have, now we also have a region down. And so you don't want to be dealing with more than one problem at the same time. And so that's where you're going to have an issue of agility in terms of deployment. Another thing that is overlooked is there's no guarantee of one-to-one if you are configuring your code after deployment. Because if you were to deploy a virtual machine and installed all the dependencies, and then you were to deploy a virtual machine literally a minute later, one of those dependencies could have a minor revision. And so that would be deployed with that one minor revision. So they would look very similar, but they aren't one-to-one. So by introducing golden images, which is an immutable infrastructure idea, you get a guarantee of one-to-one with your fleet. You have increased assurance of consistency, security. You can speed up your deployments. The reason why you'd have an improvement of security is because at that stage you could perform kind of security checks and things like that there on that image before you roll it out. So I don't know. I would just say that I would recommend that you go with the immutable infrastructure or baking your images when you can if you're using VMs, okay? Hey, this is Andrew Brown from ExamPro, and we're going to take a look here at what is HashiCorp. So HashiCorp is who creates Terraform, and they are a company specializing in managed open source tools used to support the deployment and development of large-scale service-oriented software installations. And they have their own cloud platform called the HashiCorp Cloud Platform, HCP, and it's a unified platform to access HashiCorp various products. So the main thing is that it's cloud agnostic, so HashiCorp makes it really easy to build cross-cloud, and they have support for all the 3 main providers, so AWS, GCP, Azure. I'm sure they have more support like Kubernetes and things like that. They're highly suited for multi-cloud workloads or cross-cloud workloads. And they have a lot of products that will help you out there. So let's go through them quickly. So first we have Boundary. This is secure remote access to systems based on trusted identity. This is Consul. This is a full-featured service mesh for secure service segmentation across any cloud or runtime environment. You have Nomad. This is scheduling and deployment of tasks across worker nodes in a cluster. You have Packer, which is a tool for building virtual machine images that will be later deployed, or they will place them in an image repository. Then you have Terraform, which is infrastructure as code code software, which enables provisioning and adapting virtual infrastructure across all major providers. Then you have Terraform Cloud, and this is just a place to store and manage your IaC state files and things like that with a team or just in the cloud by yourself. We have Vagrant, so building and maintenance of reproducible software development environments via virtualization technology. We have Vault, so secrets management, identity-based access, encrypting application data, auditing of secrets for application systems and users. And lastly, we have Waypoint, a modern workflow to build, deploy, and release across multiple platforms. So there you go. Hey, this is Andrew Brown from ExamPro, and we are looking at what is Terraform. So Terraform is an open source and cloud agnostic infrastructure as a code tool, and Terraform uses declarative configuration files. And the configuration files are written in the HashiCorp configuration language, HCL, and so that's what you can see on the right-hand side. We'll generally call it the Terraform language, which we'll talk about later. But notable features of Terraform are installable modules, plan and predict changes, dependency graphing, state management, and provisioning infrastructure in familiar languages. That's something you could do via AWS CDK. So I wouldn't say it's core to Terraform, but that's what they listed on their websites. That's why I put in there. And Terraform Registry, which has over 1,000 plus providers. Okay, so there we go. So we were just looking at Terraform, but what is Terraform Cloud? Well, it's a software as a service offering for remote state storage, version control integrations, flexible workflows, and allows you to collaborate on infrastructure changes within a single unified web portal. And this is all accessible via terraform.io. And the first thing you'll have to do is create yourself an account on Terraform.io, but it's free to start with. And they actually have a very generous free tier that allows for team collaboration for the first 5 users of your organization. That's not part of the Teams plan, that's part of the free plan. And in the majority of cases, you really should be using Terraform Cloud as your remote backend, even if you are an individual, just because, you know, it makes the experience so much better. The only case that you might not want to use Terraform Cloud is if you have a very large company that's trying to meet particular regulatory requirements. And it's not that Terraform Cloud does not meet them, but sometimes there's just a long procurement process. So in the meantime, you'd have to use something like Standard Remote Backend or Atlantis, or maybe you need to investigate Terraform Enterprise. I do want to note that Terraform Cloud and Terraform Enterprise is the underlying software known as Terraform Platform. It's not something you're going to ever have direct access to, but just to clarify that terminology, okay? So what I want to do is just set you up with understanding the Terraform lifecycle. This is not necessarily described in the documentation anywhere, but it's something that is inherently known when you're working with Terraform. And it's definitely not inclusive of every single command that can be ran, but the ones that you're going to encounter most often. So at the start, you're going to be writing or updating your Terraform configuration file, okay? And from there, the first thing you'll want to do is initialize your projects, or if you need to pull the latest providers and modules, you're going to use Terraform Init to do that as well. From there, you're going to use plan. So plan allows you to speculate what will change or generate a saved execution plan that you could use later on. When you run plan, validate happens automatically, but you could also run this separately and ensures types and values are valid, ensures the required attributes are present within your configuration file. From there, if everything is good, you're going to execute your execution plan by running Terraform apply. You can also, from this point, use Terraform apply to destroy infrastructure. So if you have things set up, there's actually a flag for it, or you can use the alias, the Terraform destroy command. And then, you know, as you work, you're just going to keep updating your code, and that is the Terraform lifecycle. So, you know, hopefully this gives you kind of a snapshot of what the workflow will be. And I mean, we'll be covering it tons of times over in this course, okay? Hey, this is Andrew Brown from ExamPro, and we are taking a look at change automation. But to understand that, we need to first talk about change management. So this is a standard approach to apply change and resolving conflicts brought about by change. In the context of IaC, change management is the procedure that will be followed when resources are modified and applied via configuration scripts. So what is change automation then? It is a way of automatically creating a consistent, systematic, and predictable way of managing change requests via control and policies. Notice, and I should have probably emphasized this, is change requests, saying I'm going to change these resources. Terraform uses change automation in the form of execution plans and resource graphs, which we'll look at detail those two things in upcoming slides, and apply, review complex change sets. So a change set is a collection of commits that represents changes made to a versioning repository, and for IaC, it uses change sets so you can see what has changed by who over time. So when I say versioning repository, that doesn't necessarily mean Git. And if you're using GitOps, I suppose you could consider your change sets being committed to that. But something like CloudFormation, when you apply a change, you actually have to accept a change set. And so the version repository is part of AWS. And so Terraform, you just kind of accept it in place. It's not necessarily on your local machine, but it gets reflected in your state file, okay? So change automation allows you to know exactly what Terraform will change and in what order, avoiding many possible human errors. A change automation is essential to any IaC tool. They all have it, okay? So there we go. Hey, this is Andrew Brown from ExamPro, and we are taking a look at execution plans. So this is a manual review of what will add, change, or destroy before you apply changes. And so let's say you type in Terraform apply. It's not just going to go ahead and do that. It's going to have you type in yes or accept the value. But what you can do is see the resources or configuration settings that will be added, changed, or destroyed, and it will summarize them at the bottom. And then you'll have to type something like yes in order to accept the changes, okay? Something else I want to show you is that you can actually visualize your execution plans by using the Terraform graph command, and Terraform will output a graphviz file. You'll have to have graphviz installed, but graphviz is an open source tool for drawing graphs specified in the .language scripts, having the file name extension of GV. So I believe this is cross-platform, it's open source, but once it's installed in your machine, you can run Terraform graph, and here, this is Linux, so we're using a pipe to say, okay, pass it over to graphviz, which is dot, and that is going to then create an SVG file. You can just open that in your browser, and the idea is you're going to get this graph, which kind of shows you the relationship of the resources here, but we'll talk about these relationships in the next slide here, which is resource graph, okay? Let's take a look here at the resource graph. So Terraform builds a dependency graph from the Terraform configurations and walks this graph to generate plans, refresh state, and more. When you use Terraform graph, this is a visual representation or presentation of the dependency graph. If you're wondering what a dependency graph is, in mathematics, it's a directed graph representing dependencies of several objects towards each other. So it's pretty much like nodes with relationships between other nodes. So that is one that I generated out from Terraform. And so there's a few different types here. We have a resource node that represents a single resource. A resource meta node represents a group of resources but does not represent any action on its own. And provider configuration node, so represents the time to fully configure a provider. Will you need to know this for the exam? Probably not. Do you need to know this in great detail? Probably not, because there's a lot to the resource graph. But the idea here is just kind of like Terraform saying, just so you know, we're using a graph database, and graph databases are very well suited for this kind of stuff. And that's why Terraform is very good at figuring out conflicts and things like that, okay? Hey, this is Andrew Brown from ExamPro, and we're taking a look at Terraform use cases. And the idea here is not necessarily because this is going to show up in the exam, but the idea is to give you a business use case or to highlight the features as to why you'd want to be using Terraform. And the first one here is that it has exotic providers. So Terraform supports a variety of providers outside of GCP, AWS, and Azure, and sometimes is the only provider. Terraform is open source and extendable, so any API could be used to create IaC tooling of any kind of cloud platform or technology, so you can make your own provider. There's some interesting ones that they have, like Heroku or even Spotify playlists. I have my own platform called Teacher Seat, and I want to have IaC for my platform, and so this is what I'm going to be using Terraform for. For multi-tier applications, Terraform by default makes it easy to divide large and complex applications into isolate configuration script modules. You'll notice in this course that when you have a bunch of Terraform files, they're all treated as one. So that makes it really easy to split up your projects or your infrastructure. So it has a complexity advantage over cloud native IaC tools for its flexibility while retaining simplicity over imperative tools. Then we have disposable environments. This is not unique to Terraform. It's any kind of IaC tool, but easily stand up an environment for a software demo or a temporary developer environment. Resource schedulers. So Terraform is not just defined to infrastructure of cloud resources, but can be used to set dynamic schedules for Docker containers, Hadoop, Spark, and other software tools. You can provision your own scheduling grid. And the last one here is multi-cloud deployment. Terraform is cloud agnostic and allows a single configuration to be used to manage multiple providers and to even handle cross-cloud dependencies. And that is a big deal and is a very unique offering to Terraform, okay? Let's take a look here at Terraform Core and Terraform plugins. So Terraform is logically split into two main parts. Terraform Core, which uses remote procedure calls, RPC, to communicate with Terraform plugins, and Terraform plugins, so expose an implementation for a specific service or provisioner. Something that's interesting to know is just Terraform Core is written in Go. You probably won't ever encounter it, but it's just a fact, okay? And so here's the graphic that Terraform uses to kind of like explain Terraform Core versus Terraform plugins and how they all relate. And so here's the Terraform Core, and here are the plugins. Notice we have providers here, which we'll cover, provisioners, and this is the group for plugins overall. But yeah, that's about it. Will it show up in the exam? Probably not, but it's good to understand from a top level view the split between these two things, okay? If you are new to Terraform, I just wanted you to be aware of an additional resource that you can use beyond this course, which is called Terraform Up and Running. So it's a book, and it has a deep dive into the internal workings of Terraform. And this is really great if you want to go beyond this course, beyond certification, beyond the basics, because what it will do is teach you about testing with Terraform Cloud, zero downtime deployment, common Terraform gotchas, and compositions of production-grade Terraform code. There's a lot more to it, and this book in particular is written by Jim, who's the co-founder of Gruntwork, and we do have a whole section just on Gruntwork. And the thing is, I just wanted you to know about this resource. You definitely don't need it to pass the certification or to have a good understanding or working of Terraform, but at some point, if you want more, I just want to point you to that resource, okay? There's one other resource I want you to check out for Terraform, and this one is free and just online, and it's the Terraform Best Practices. So it's an open book, it's a Git book, so it's essentially a wiki, and it basically covers the best practices that are being used in the industry. And so this is stuff that is separate from the Terraform documentation. It's just good practices, if you're going to be using Terraform professionally within the industry. So I just wanted to make you aware of this resource and to go check it out, okay? Hey, this is Andrew Brown from ExamPro, and we are taking a look at Terraform Provisioners. So Provisioners install software, edit files, and provision machines created with Terraform, and Terraform allows you to work with two different provisioners. We have Cloud Init and Packer. So Cloud Init is an industry standard for cross-platform cloud instance initialization. When you launch a VM on a cloud service provider, you'll provide either a YAML or bash script. And so for the case of AWS, what you'll have is this box called user data. And so you can either put your YAML or bash script in there. It's the same if you're using Google or Azure. They both have this box. It might just not be called user data, but that is using Cloud Init underneath. Then you have Packer. This is an automated image builder service. You provide a configuration file to create and provision the machine image, and the image is then delivered to a repository for use. If you've ever heard of EC2 Image Builder, it's a very similar service, except that one's just for AWS. I suppose for Google, you could use Google Cloud Run. And even on AWS, you could use code build, but Packer is great because it's cloud agnostic. So you're going to just build the image and then you can deliver it to any provider. Provisioners should be used as a last resort for more common situations. There are better alternatives. This is a warning that Hashnode puts out in their Terraform Provisioner section. And so I wasn't really sure why they were saying this. So I reached out to Anton. And Anton, if you don't know him, he's an AWS community hero, just like myself. And so he specializes in Terraform. Like, he wrote so many modules for the Terraform AWS, so he knows it pretty well. And he says here, the main reason is that provisioners will do something that won't be reflected in the Terraform state. And the better alternative for that one is to use cloud provider features like cloud init scripts. I think this comes back to immutability when we were looking at the fact that we want to lean towards doing an approach with Packer, right? We want to bake our machines or virtual machines and then deploy, because that's going to be probably the better alternative. So if we wanted to use Cloud Init, the idea is we'd have to provide a Cloud Init YAML file, which is a very particular format. You can find them on the Cloud Init website. And the idea here is we have these run commands. So that's just like bash commands here to start and stop Apache. We can install our packages here, do an update, do an upgrade. We'll have to pass along our SSH key here. That's a very important component to that. Once we have that file configured, we can reference it as a template file over here, call it user data, and then we're going to pass it on to this section here for user data, so that when we launch up this VM, and this one in particular is for AWS, that's going to pass it to that user data, okay? Now, you might be asking, well, where's all these other provisioners? Because there's a lot of other tools out there. So Terraform used to directly support third-party provisioning tools in the Terraform language, but they were deprecated because it was considered to be poor practice, suggesting better alternatives, as we were just talking about. So you might be asking, where is Chef? Where is Puppet? Where is Salt? And the thing is that you can technically still use Chef and Puppet through Cloud Init, because Cloud Init actually supports some DSLs in there. I've never used this before myself, but it doesn't look too complicated. But the idea is that there's just not direct support. So you're not going to use it directly in the language. You can use it through Cloud Init if you really need it. One thing I didn't see mentioned anywhere was Ansible. And this one's a little bit confusing because there's a lot of videos online about Terraform and Ansible working very well together, and they're complementary technologies. So Ansible is a little bit different than these other ones because it does more than just configuration management. So maybe that's the reason there. But anyway, the point is that there's no direct support for these anymore. You got to use Cloud Init, and generally, if you can, use Packer instead when you're working with virtual machines, okay? Hey, this is Andrew Brown from ExamPro, and we are taking a look at local exec, which allows you to execute local commands after a resource is provisioned. So the machine that is executing Terraform, so what's doing the Terraform apply, is where the command will execute. And a local environment could be your local machine, so your laptop or workstation, a build server like GCP Cloud Build, AWS Code Build, or Jenkins, or Terraform Cloud Run environment. So that is a single-use Linux virtual machine. So just an example, and there's a lot of cases where you might want to automate, but the idea here is after you provision a VM, you need to supply the public IP to a third-party security service to add the VM IP address, and you could accomplish this by using locally installed third-party CLIs on your build server. And so there is a bit of an overlapping responsibility between Terraform outputs versus local exec, because the idea is that by getting data out after something is provisioned or something like that, you can do something pragmatic. But the idea here is Terraform outputs allow you to output results after running Terraform apply. Local exec allows you to run any arbitrary commands on your local machine, commonly used to trigger configuration management like Ansible, Chef, or Puppet. Okay. Let's take a look at some example code for a local exec. So here we have a bunch of examples on the right-hand side, And so I just kind of want to walk through some of the commands that we can use. But before we do that, let's take a quicker look here at the code. So notice we have a resource like AWS instance and web, and then we are specifying a provisioner being a local exec, and then we have a command that is being executed under there, okay? So hopefully that makes it pretty clear, but let's just kind of work through the options we have available to us. So the first is we have a command, and this is required, and this is the command you want to execute. So notice that we are doing an echo there, so it's whatever is possible there. And I think by default it's using bash, okay? So if you're using Linux, that's what it would be using. We could also set a working directory. We don't see an example there on the right-hand side, but if you wanted to say where the command will be executed, that's something you could do. So maybe you want it over here. Another thing is the interpreter. So this is the entry point for the command. I think by default, again, it would probably use bash if you're on a Linux machine, but you could say use bash, Ruby, AWS CLI, PowerShell, whatever you want, okay? If you needed to pass environment variables in, maybe you need a key and secret. So the example here is, we are printing out those keys and then putting them into a credentials YAML file. So that could be an example there, okay? Hey, this is Andrew Brown from ExamPro, and we are taking a look at remote exec. So this allows you to execute commands on a target resource after a resource is provisioned. So the idea is you have a local machine executing Terraform. And so the idea is that when remote exec happens, it has a script and it's sending that off to the target. So in this case, it could be a provisioned virtual machine. And this is where the command is going to run. So a remote execute is useful for provisioning a virtual machine with a simple set of commands. For more complex tasks, it's recommended to use Cloud init, and strongly recommended in all cases to bake golden images via Packer or EC2 image builder if you want to use something more complex like Ansible or something. Let's take a look at an example of a remote exec script. So here we have a couple, and just to quickly go through it, the idea is you define your resource. So here it's just a virtual machine on AWS, and we are provisioning, our provisioner is going to be remote exec. And so we're able to put these inline commands and say, okay, let's run puppet apply, and then we'll use Consul join, which is the CLI for HashiCorp Consul. So there are 3 different modes for a remote exec. The first is inline list of command strings, which is what we are seeing over here. And then the other option is we can provide a script or scripts. So the idea is that you would, you just specify those locations and it would run it. What's interesting here is that it doesn't say, because we saw with local exec that we could use an interpreter. And so it's my assumption that it's just going to use bash, or it's going to use a script that is executable, right? Where you have a shebang in the top there. And so that's something, I might test out. It's not something that's going to be on the exam, but maybe we'll just test out that theory because it's not in the documentation as of the time I'm recording this. Let's take a look at the file provisioner, and this is used to copy files or directories from our local machine to the newly created resource. So here we have some on the right as an example. So again, we have a virtual machine that we're deploying to AWS. We've set the provisioner as file, and we are specifying a source file and a destination. So source is going to be the file that's on your local machine, or whoever is considered the local. That you might also want to provide content directly. So in this example here, you see that we're literally just giving it a string. And then there's the destination where you want that file to be. I don't have it shown in the code example here, but there's a high chance that you would have to provide a connection block so that you could say, okay, I need to use SSH or WinRM to gain access to that machine, okay? So we just mentioned that there's a connection block. So it tells the provisioner or resource how to establish a connection. So here is a big example on the right-hand side. So this is using the example for a provisioner file. And here we are specifying our connection block. And this one in particular is for SSH, as you can see. And there's a bunch of different parameters like the user, the password, the host. You could also use a bastion host. I'm not showing it here, but if you're using SSH, you could specify a bunch of keys in order to do that, because maybe you need to go through a bastion first. For Windows remote management, you also have that option down below, okay? Hey, this is Andrew Brown from ExamPro, and we are taking a look at null resources. So this is a placeholder for resources that have no specific association to a provider. It's a bit confusing, but it makes sense once you run into some use cases for it. So here is a big example where we have an AWS instance, and we're defining a cluster, and so we need a null resource here because we want to run this trigger. And that's generally why you're going to be using null resources, is to trigger a resource. So triggers is a map of values which should cause this set of provisioners to rerun. So values are meant to be interpolated references to variables or attributes of other resources. And triggers are interesting because I think we also see them in Terraform Cloud. Not sure if this is the same kind of functionality, but yeah, that's null resources, okay? All right, let's take a look at Terraform data. So this is very, very similar to null resource, but the key difference here is that it does not require or the configuration of provider, because when you install null resource, it actually installs a provider called null. And so now it's just with this Terraform data, you can do something very similar like this with null resource and literally replace it with Terraform data. And for more or less, it will do the same thing. Now, it's not one-to-one because some of those parameters are a little bit different. So instead of triggers, we have triggers replace, but more or less, you can almost replace it and get the exact same result. I would recommend it over using null. I was trying to figure out if there was a case where you'd want to use null resource, but I really could not determine that. It did not seem like there was anything additional. So yeah, there you go. It's as simple as that. Hey, this is Andrew Brown from ExamPro, and we are taking a look at Terraform Providers. So providers are Terraform plugins that allow you to interact with cloud service providers like AWS, Azure, GCP, software as a service providers, so GitHub, Angolia, Stripe, or other APIs such as Kubernetes or Postgres servers. There's a lot there. There's like over 1,000 providers. So providers are required for your Terraform configuration file to work. So you have to have at least one provider. Providers can come in 3 different tiers. We have the official one, so published by the company that owns the provider technology or service. Verified, so actively maintained, up to date, and compatible with both Terraform provider. Community, so published by a community member, but no guarantee of maintenance, up to date, or compatibility. Providers are distributed separately from Terraform, and the plugin must be downloaded before use. So if we do Terraform init, this will download the necessary provider plugins listed in the Terraform configuration file. So there you go. Hey, this is Andrew Brown from ExamPro, and we are taking a look at the Terraform registry. So this is a website portal to browse, download, or publish available providers and modules. And just remember, providers and modules are plugins within Terraform, both of them, okay? So to get to this website, we go to registry.terraform.io, and everything published to the Terraform registry is public facing. So let's just distinguish between providers and modules, and I feel that I should have given providers a little bit more attention in its own slide, but I'll give it a clear distinction between providers and modules here. So a provider is a plugin that is a mapping to a cloud service provider's API. So if you wanted to call individual API actions, that is what the provider is providing to you. When we're talking about modules, a module actually relies on a provider plugin, but a module is a group of configuration files that provide common configuration functionality. This is going to help you enforce best practices, reduce amount of code, reduce time to develop scripts. So the way to think about it is, imagine that you have to do something in your CSP like AWS, and there's just common things that would go along with it. So let's say you're launching a load balancer, auto-scaling group with EC2 instances. That's a bunch of services that are just very common. You'd have to configure it together. So there could be a module that allows you to do all that with writing very little amount of code, and it will choose best practices when doing that, okay? Let's take a look here at providers and modules within Terraform Registry really quickly. So here is the AWS one here. And so I just want to point out that this official one is by HashiCorp. It's not by AWS, but it does mean that it has proper support. So you know it's going to have pretty much one-to-one mapping to the AWS API. And so it has really, really good documentation. Now, I complain about Terraform not having great documentation for learning, like their language, but for the actual documentation of doing things practically, they're really, really good. And here's just an example where we see app mesh, and they just give you full examples for basically everything. It's really great. And if you need a code sample to get going, like to actually install it within your configuration file, it's right there over here. So you can just go ahead and grab that. For Terraform modules, it looks pretty similar. So the idea is you get your module code on the right-hand side here. You want to check out the examples. It's going to be dependent on who is developing these modules. This one is made by Anton. So he has lots and lots of really great examples. And then you can see a list of dependent modules here under sub-modules. So it's not too complicated. So there you go. So we're taking a look at Terraform Registry, which is a public registry, but let's talk about private registry. How would we do that? Well, that's where we use Terraform Cloud. It allows you to publish private modules for your organization within the Terraform Cloud private registry. When creating a module, you need to connect to a version control system of VCS and choose a repository. So here you can see we can be using something like GitHub, GitLab, Bitbucket, or Azure DevOps. And of course, we're going to cover Terraform Cloud a lot more further on in the course, and it definitely does more than just act as a private registry, but I figured this is the best place to put it against the Terraform registry, okay? Let's take a look at how we would get a list of the current providers you are using. So all you'd have to do is type in Terraform Providers and you'd get a full list. This command is useful if you have a very complex architecture where you're using a lot of files and modules within Terraform. I wanted to just show this command just because I saw it on the exam, and so it's just an easy point if you happen to get that question, okay? So we know we can set multiple providers in our Terraform configuration file, but there are some variations here that you should know. So one thing is that if you need to have an alternate provider, you can use this thing called alias. So if you just notice here, there's the alias. This is useful if, let's say, you want to have resources within different regions of AWS. It's a very common use case. When you want to reference what resource should use what provider, you're going to have that little provider attribute, and then you're just going to do what the name is of the provider followed by the alias. You can also set an alias provider for a parent module. So notice here in the required providers, we have this attribute here, and we're using this configuration alias. And then if you need to set an alias provider for a child module, but more or less you just need to remember these two up here, okay, for setting an alias. Hey, this is Andrew Brown from ExamPro, and we're giving closer attention to modules. So a Terraform module is a group of configuration files that provide common configuration functionality to enforce best practices, reduce the amount of code, and reduce the time to develop scripts. I definitely had a lot of confusion understanding the difference between a provider and a module initially. But the clear thing is that a provider is just an API mapping to the service, okay? So on the example here on the left, we have AWS as a provider, and the example is to show you if you had to create a VPC, you'd have to specify many networking resources, and just notice that I have the 3 ellipses there to suggest there is a lot more that you'd have to configure, but by using a module, and there's one called the AWS VPC module, it basically has this short domain-specific language that allows you to quickly provision a VPC. So the easy way to remember modules is imagine clicking a wizard that creates many cloud resources, like in AWS they have the VPC wizard. That's basically the idea behind modules. Just to kind of give a better contrast to the value that modules have, we'll look at the Azure provider. So imagine you had to provision an Azure virtual machine. This is how much code you'd have to write. So it's going to vary based on providers. So AWS does not require this much work. It's very short. GCP requires a little bit more work, and for some reason Azure requires a lot. So this is a case where you'd want to use a module, and so there's a module called Compute and Network module, and it reduces the code to amount of this. Still a bit long, but that's just what it is, okay? All right, let's talk about the fine line. And this is understanding the gray areas of responsibility between Terraform infrastructure as code and third-party configuration management tools like Ansible. So there are cases where when you get outside of AWS, Azure, GCP, you might see providers like for Postgres database, and you might say, okay, well, what part of Terraform should be automating it? And so that's a little bit more complicated question because Terraform does more than one thing. So Terraform has providers, modules, and provisioners. And then on outside of that, if we're not even using Terraform, we have third-party configuration management tools that we can use, like Ansible. And the thing is that you could have Ansible do everything, but that does not mean that you should have it do everything. And with Terraform, at more or less most of these levels, you can have them do everything, but that doesn't mean that they should, right? So the idea is to try to figure out what should be where and how to define that. So let's talk about creating a database. So if we created a database, that is like setting up a new service. So that is going to be under the providers. And so you'd use the Postgres Terraform provider to set up a database. Now you have users. And so users are an entity. They're not just like loose data. So there's something that you can add, remove, add permissions to, and we would treat them as entities. And so it wouldn't necessarily be under the providers, but that's a great place to put it under modules. Okay. Then you have your data. So where would the data go? Well, data is not necessarily an entity. It's just a bunch of data. So I would say that that is for provisioners that can run random scripts. And then when we want to do things like backup tables to data warehouses or truncate data daily tables, things that are repetitive tasks, that is what we're going to use Ansible for, or a third-party configuration management tool outside of Terraform. You wouldn't have Terraform do that stuff at all. So when you have a task done one time to set up the database, like seeding data, it's going to go in provisioners. When you have repeatable tasks for ongoing maintenance, it's going to be out as a third-party provider. And if you have something that is like identified as an identity, like as a resource that you want to manage, like asset management, which are these things. These are going to be over here in providers and modules. And I do want to point out that a provisioner can be using Ansible, but you'd still want to use Ansible or a third-party configuration management tool isolate or separate to do these kind of things. You do not want Terraform running these, okay? Hey, this is Andrew Brown from ExamPro, and we are looking at HashiCorp configuration files, also known as Terraform files, which contain the configuration information about providers and resources. This is basically core to Terraform, and that's what we're doing. So Terraform files end in the extension of .tf or tf.json, and we'll talk about the JSON case a little bit later, but Terraform files are written in the Terraform language. And so here is kind of an abstract way of looking at the language. I know it's confusing here, but don't worry, we're going to reiterate on it to make more sense. But Terraform language consists of only a few basic elements. You have blocks, and so these are containers for other content, and they represent an object. So I'll have a block type, which can have 0 or more labels and a body. You have a block label. It's a name of a block. You have arguments, which is what you assign a value to a name. So notice like we have assignments. So we have identifier to an expression, okay? They will appear within blocks. So here it is within a block, as you can see. Expressions represent a value either literally or by referencing and combining other values. They appear as values for arguments or within other expressions. You might come across HashiCorp configuration language, so HCL, and this is the low-level language for both the Terraform language and alternative JSON syntax. I don't know if we'll be getting into it in this course, or if there's even an easy way to distinguish it, because it's basically Terraform language. But just if you see HCL, just think Terraform language. It's the easiest way to think about it, okay? Let's take a look here at the alternate JSON syntax. So Terraform supports alternate syntax that is JSON compatible. Terraform expects JSON syntax files to be named .tf.json. So we mentioned that earlier. And so this is generally what it would look like, okay? The syntax is useful when generating portions of a configuration programmatically, since existing JSON libraries can be used to prepare the generated configuration files. And that's pretty much it. Would you want to work on this? It's up to you. Yeah, so that's the reason for this alternate syntax. All right, right, let's take a look at Terraform settings. So the Terraform configuration block type, Terraform, curly braces, you'll see this within your configuration file, is used to configure some behaviors of Terraform itself. So here is what it looks like, and what's very common is you're going to see those required providers. So there are different things that we can put in here. So we can put the required version. So this expects us to match to a particular version of Terraform. Required providers. This is the providers that will be pulled during the Terraform init. We can also do experiments here. So these are experimental language features that the community can try and provide feedback on. And then we have provider metadata. So this is module-specific information for providers, okay? Hey, this is Andrew Brown from ExamPro, and we are taking a look at the HashiCorp configuration language, also known as HCL. I'm going to tell you, I was really confused at the start working with Terraform because sometimes they'd mention things like HashiCorp configuration files, HashiCorp configuration language, Terraform language, and I could not discern, what the difference was. But so this is the idea here, is to give you that clarity. Okay, so HCL is an open source toolkit for creating structured configuration languages that are both human and machine friendly for use with command line tools. And it's an open source project, so you can find it at github.com/HashiCorp HCL. So the idea is that they have this baseline language that you can extend for your own use case. So Terraform is using it, and so it uses it uses the language itself, but then it goes ahead and extends it by adding additional functionality for its specific use case. And this HCL based language is not just for Terraform. It's used for Packer templates, vault policies, boundary controllers and workers, Consul configuration, waypoint application configuration, Nomad job specification, and this one isn't a HashiCorp product, but this is an open source project called Shipyard, and you can use it for Shipyard blueprints. Surprisingly, Sentinel, which is a HashiCorp policy as code service, does not use HCL, but it has its own ACL custom language. But the idea is that, we're looking at mostly the use case is for HashiCorp services. But if you wanted to extend this language for your own use case, you totally could. And so I think that's really cool. But hopefully that kind of distinguishes between HCL and Terraform language, okay? Hey, this is Andrew Brown from ExamPro, and we are taking a look at input variables, so also known as Terraform variables or just variables, are parameters for Terraform modules. That is the way we get data in to our configuration scripts, is via input variables. So you can declare variables in either the root module or child modules, and the way you define them is via this variables block there at the top. And just to kind of go over the possible fields for that block, we have the default option. So the default option, which is here, is going to be the default variable if you do not set it. For type, this is an argument that specifies the value types that are accepted for the variable. So in this case up here, we can see string, and this one is a list. For description, this specifies the input variable's documentation. We don't see an example there. I believe that it is optional, but it's always great to put a description in when you can. There is a validation block, so a block to define validation rules, usually in addition to type constraints. So we don't see that here on the right-hand side, but the idea is that, this just makes sure that there's less of a human error entering the wrong information. You can also have sensitive. This limits Terraform UI output when the variable is used in the configuration. And we will cover sensitive a lot more in this course outside of just this one slide, okay? Let's take a look here at variable definition files, and these allow you to set the values for multiple variables at once. So variable definition files are named with the .tfvars extension, or if you want to use the alternative syntax, it's the tfvars.json file. By default, if you have a file called terraform.tfvars within your project directory, this will be automatically loaded, so it's pretty common to make that file. To create a definition file, it just uses the Terraform language. So you would just assign values here. You wouldn't make variable blocks, but you just define these identifiers and give them values, okay? Another way of loading input variables is via environment variables, and this is very common way of loading them if you have your own CI/CD process for Terraform. So if you're using Terraform Cloud or you're using some kind of build server, that's going to be the primary way you're going to get variables into those build servers. Probably won't be doing this much locally, but the way it works is that Terraform will watch for any environment variable starting with TF underscore var underscore followed by the name. This is very important to remember because it definitely will show up on the exam. So let's say we wanted to set a variable for an image ID. So we do TF underscore var and then image ID. Probably most cases when you follow the name, it's going to be lowercase underscore. I don't think you'd probably want to uppercase that stuff, and you just set the value, okay? So there's a lot of ways for us to load input variables. We just saw two. So we saw Terraform TF vars and environment variables, but there's a lot more caveats to this. So let's just run through them. So we already covered Terraform.tf vars. The idea here is that if you create this file and it's in your project, it will automatically be loaded when running Terraform apply. You can name other TF var files. So I just call them these additional TF var files, but they won't be loaded by default. You'll have to use a command line to load them. This is useful if you have like a dev and prod environment and you want to swap those out. Now, if you want to have files that auto load, then you can just put the .auto here and give it any name you want. This would be useful if, let's say, you had a very large Terraform TFVars file and you wanted to break it up to make it more human readable. You could do that. Then you have the -var file flag when you're doing Terraform apply or plan, and this is actually how you load up these additional variable files. If you need to override a single value, you can use -var. So here I'm overriding the EC2 type to be T2 medium. And then lastly here we have environment variables. We covered this. This is where it starts with TF underscore var underscore followed by the name, and this is going to be very common when you are using code build servers or runtimes to run this in a CI/CD automated way. Now there's a precedence to which these get loaded, meaning that that certain configurations of or input of variables will override other ones. So as we go down this list, these ones will override the previous ones. So at the top, you have environment variables. If you have a Terraform TFVars file, that will override the environment variables. If you have the JSON one, that will override that one. If you have auto files, that will override the default TFVars file. And then on the last list, you have -var, and -var file will override the rest. So there you go. In terms of the exam, they're not going to ask you the precedence here, but you're going to need to know what var file are, environment variables are, and this default one, okay? All right, let's take a look here at output values, which are computed values after a Terraform apply is performed. Output values allow you to obtain information after resource provisioning, such as a public IP address, output a file of values for programmatic integration, cross-reference stacks via outputs in a state file via Terraform remote state. And so here's an example of an outputs block. So notice that there's a block and you specify some stuff there. You can optionally provide a description. It's not necessary, but generally with outputs, I would recommend putting that in there. You can also mark it as sensitive, so it does not show in your terminal. This is important if you're doing like logging stuff. You don't want to compromise those values there, but understand that output values, even though they might not be outputted to your terminal or SD out, they will be visible within the state file. So if somebody opens up the state file, they're going to be plainly visible there. So just understand that sensitive does not protect the values there, okay? Now, in terms of how we would use the CLI with the output values, if we type Terraform output, it's just going to print out all the values that are within the state file. I don't show this in the example here, but if you wanted to use a like bash command to parse JSON, you could extract them out and see they're just plainly in the JSON, okay? If you need to get exactly a particular field, you type in Terraform output and then followed by the name. If you wanted it in a JSON format, all the output, then you could give that flag. I don't know if it would work with this one. I actually didn't test it, just thought about that here for this one here. If you want the raw output of it, meaning like if you output a string and you want it to be escaped or what have you, then you could use it pragmatically by passing it to something like curl to do something. But the idea with all these output values is that it's one way of inspecting, but you could also use this in a configuration script or something to do kind of like an after action, okay? All right, so we're taking a look at local values, also known as locals, that assigns a name to an expression so you can use it multiple times within a module without repeating it. So here, what we're going to do is define our local block up here. And then the idea is that we're assigning these names or IDs, expressions or values, so that we can reuse them throughout our code. Notice that we can define multiple local blocks in the same file. And I just say this because like when you use required providers, you're only allowed to have a single block. But in this case, like with variables or locals, you can have many. And you can even nest them within each other. So notice down here, we're referencing local within a local. So that's totally possible. And I imagine it's in the order to which it is specified. We can do static values or computed values. So we can actually, here's a function, right, an expression, and then it'll output a value. Once a local value is declared, you can reference it via the dot as local dot the name. So here, notice within our AWS resource, we have local and common tags. I have to point this out, but when you're referencing, you use the singular local because you might get an exam question where it shows you local dot or locals dot. And the trick here is you got to remember which one it is. Locals can help dry up your code. It is best practice to use locals sparingly since it's in Terraform, it's intended to be declarative, and overuse of locals can make it difficult to determine what the code is doing. This all comes back to describing Terraform as declarative plus, where they give you functionality that's imperative-like. But the idea is that, if you overuse these, you can run into trouble, okay? Hey, it's Andrew Brown from ExamPro, and we are taking a look at data sources for Terraform. So the idea here is you want information defined outside of Terraform, and it's defined by another separate Terraform configuration or modified by functions. So the idea here is we are going to define ourselves a data block, and we have an external resource we're looking for. So we're saying, hey, I want to see if I have an AWS AMI. We're going to use these filters as a way of kind of selecting it within our AWS account. So we'd have a provider set up, and so it'd be looking within that account to find it. And it's even saying, look for the most recent AMI, okay? And once we have found that data source, we can just reference it. So notice we're using data to reference it there. So data, AWS, AMI.web ID. So there you go. We're taking a look here at name values, and these are built-in expressions that reference various values that you'll find in your configuration scripts. We do cover these in their respective sections, but I wanted to consolidate them here in one place just so that you get a second chance to reinforce this information, because crux of questions on the exam could be based on knowing how the name values work. So let's go through them. The first is resources. I'm going to get out my pen tool here. And so the way resources work is that you start with the resource type, so AWS instance, and then you're going to do the name of it. So there's nothing that starts before the left-hand side of it. So just remember, it just starts with that resource type. Then you have input variables, and that starts with var period. So that's the singular var. Then we have local values, and again, that's singular, so local period. For child modules, it starts with module period, again, singular. For data sources, it's going to be data singular. Just remember singular because they can have a matchup on the exam questions where it'll be like data or datas. For file system and workspace info, we have path.module. This is the path of the module where the expression is placed. We have path.root. This is the path of the root module of the configuration. We have path.cwd. This is the path of the current working directory. And in practice, the default CWD is the same as the root, so those would be technically the same. We have terraform.workspace. This is the name of the currently selected workspace. Then we have block local values. These are things that appear within a body of blocks. So this could be within a resource, provisioners, things like that. So we have, if we're using the count meta argument, we're going to get count. And with that, we'll have count.index. So we can say, okay, this is the fourth iteration of, this count loop. Then we have for each, and this allows us to have the key and the value, so we can access that during our iterations. We have self. So self is references information within provisioners or connections. So it's just like a self-referencing thing. Name values resemble the attribute notation of map or object values, but are not objects and do not act as objects. You cannot use square brackets to access attributes of name values like an object. So there you go. this is Andrew Brown from ExamPro, and we are taking a look at resource meta-arguments. So the Terraform language defines several meta-arguments which can be used with any resource type to change the behavior of resources. And so we'll quickly go through the list here, and then we will deep dive on each. So the first is depends on. So this is for specifying explicit dependencies. We have count, which is for creating multiple resource instances according to a count. We have for each, which is used to create multiple instances according to a map or set of strings. Provider, so this is for selecting a non-default provider configuration. Lifecycle, this is for lifecycle customizations. Provisioner, this is, and also for connections, for taking extra actions after resource creation. So there's the quick list. Now let's jump into them. All right, the first resource meta argument we want to look at here is called depends on, and this is the order of which resources are provisioned and is important when resources depend on others before they are provisioned. Terraform implicitly can determine the order of provision of resources, but there may be some cases where it cannot be determined or like the correct order. So this is where you can be a bit more explicit. So here we have some Terraform configuration where we have an AWS instance and it relies on a policy. And so what we're doing is we're setting an explicit depends on here so that it knows that it requires that. Now, in a normal use case, you would not have to do this, but it's hard to find use cases where this happens. But when it does become a problem, you'll know because your resources will not provision correctly, you'll get an error. So there you go. Let's take a look here at the count resource meta argument, and this is when you are managing a pool of objects. So an example here would be a fleet of virtual machines where you want to use count. So here on the right-hand side, we have an example of us using that in Terraform. So we can specify the amount of instances we want. So here it is 4, and then we'll have access to this name value called count.index. So the tags will start at 0, so it'll be server 0, 1, 2, and 3. Then just down below here, I just want to show you that with count, you can accept a numeric expression. So, you know, if you had a variable that you had set as the subnet IDs or even just an arbitrary number, like you want to have X amount of servers, this would allow you to do that, okay? But just so you know, those numbers must be whole and a number must be known before the configuration, which you'd put it in your input variables, okay? All right, so let's take a look here at for each, which is for iterating over resource meta arguments, but it's slightly different because it allows you to map over dynamic values, giving you a little bit more flexibility. So here's an example of us defining a for each, and notice that we have defined a map. Sometimes I call it an object because they're so similar, but this is a map. And the idea is that once you have your map defined with your for each, you will now have access to these name values. So you can do each.key or each.value to extract that out. You can also just use it like with an array. So here we have an array and then we use toSet to turn it into a set, which it will accept as well. And then we can just pull out the key because there will be no value. So just an example of with a map and then with something that looks like an array, okay? To understand the resource meta-argument lifecycle, we need to understand how resource behavior works. And so when you execute your execution order via Terraform apply, it will perform one of the following to a resource. So the most common one you'll see is a create. So these are resources that exist in the configuration but are not associated with a real infrastructure object in the state. The way you can tell it's creating, it will have this nice little green plus sign. The next one is destroy. So resources that exist in the state but no longer exist in the configuration. And so that's going to tear down your resources out of your cloud providers. This is represented by a minus symbol. Then you have update in place. So the resources whose arguments have changed. So the idea here is that if you have a virtual machine and let's say you change the size of it, it's not going to destroy it. It's just going to modify its settings. This is represented with a tilde. And the last one here is destroy and recreate. So resources whose arguments have changed, but which cannot be updated in place due to remote API limitations. So there are just some cloud resources that always require destroy and recreate. And this is something very easy to trigger if you are using the replace command or the older Terraform tank command in order to replace a degraded or damaged instance. So let's talk about lifecycle. So lifecycle blocks allow you to change what happens to resources on the create, update, and destroy. lifecycle blocks are nested within resources. So here is a resource, which is just an Azure resource group. And within it, we have a lifecycle block, and we're setting our first option here that's possible called the create before destroy. So this is a Boolean, and when replacing a resource, first create the new resource before deleting it. So the default is destroyed old first. So this is more about just the order of how it's destroyed. Prevent destroy, so ensures a resource is not destroyed. Then we have ignore changes, and this is based off a list of attributes that you feed to it. So don't change the resource on create, update, destroy if a change occurs for the listed attributes. So maybe you're just changing a tag, and you say don't change don't tear down, create, or do anything strange if we change a tag. Okay, so there you go. That's life cycles. So we're looking at our last meta argument here, which are resource providers, and this goes along with the idea of an alias. So here we are defining ourselves a provider in Google Cloud, but there's a case where we might need to override the provider at a per resource level. And the way we do that is by creating an additional provider and setting an alias. And then here we could change something like the region. And then once we have that set, we can then reference our provider explicitly under a resource. And so that's all there is to it. Definitely on your exam, you will see a question about alias, or you'll see that example. So definitely want to know how to do that, okay? All right, so we're starting our introduction here into Terraform expressions because there's a lot we can talk about here. So expressions are used to refer to or compute values within a configuration. So Terraform expressions is a large topic, and we'll be covering types and values, strings and templates, reference to values, operators, function calls, conditional expressions, for expressions, splat, dynamic blocks, type constraints. Actually, I don't think we covered type constraints just because there's nothing really to say about it, but we definitely cover version constraints. So yeah, let's start off this section and go to it. So we're taking a look here at types and values for expressions. And so the result of an expression is a value, and all values have types. And so we have primitive types, no type, and complex structural collection types. That last one is a bit more complicated than what we are presenting here. We're going to simplify it and then cover it later, okay? So for primitive types, we have string. So you have your double quotations, which represent your string. Then you have numbers, so this can be integers or floats. Then you have booleans, so this is either true or false. For no types, we have null. And so null is different in all different types of languages, so it's very important to understand how it works. And so null represents absence or omission when you want to use the underlying default of a provider's resource configuration option. So when you're saying null doesn't mean it's nothing. It's going to be whatever the default is. And the default also could be nothing. It's just depending on what that is on the provider. So for collection types, complex structural types, we have list or tuple, and this generally looks like an array. Then you have map and object, and this looks like basically like a JSON object or a Ruby hash, or I think they call it in Python a dictionary. So that gives you an idea of the basic types. But for this last one here, because this I found really confusing, list, tuples, map, object, we definitely explain this more in the course, okay? Okay, so we're giving a little bit more attention to the string type because there's a little bit more going on here. So when quoting strings, you got to use double quotes. At one point, Terraform, I believe, supported single quotes. I think it only supports double quotes now. And honestly, you generally want to just use double quotes because double quotes always support escape sequences. This is pretty much standard across all programming languages. But the idea here is you can do things like new line, carriage return, tab, literal quotes, literal backslashes, Unicode characters, both basic multilingual plain and supplementary planes. There are some special escape sequences. This makes sense when we look at the next slide for string templates. But there's these things where you can do interpolation. And so you might not want to actually do them. You might want to do it without. And so if you just use double of the symbol, that will allow you to do it. Then there is also the ability to have multi-line strings, and we use HereDoc for that. And so HereDoc is a little bit different in all languages, but here we're using Unix style. So that means that we're going to start with these two angled brackets to the left. or opening angled brackets, followed by some word that is all in uppercase. It doesn't have to be EOT. It could be whatever you want. I always like to type here doc, and then it has to end at the same indentation level with the same word all uppercase, and then everything in between will be treated as multi-line. The nice thing about this is that when you have this, you can actually just use double quotes wherever you want because you don't have to escape them, okay? Let's take a look at string templates because this is the real power of strings. So the first is string interpolation, and this allows you to evaluate an expression between the markers. So the idea is instead of having to do double quotations and do plus signs to stitch together strings, what you do is just do a $sign, curly braces, and then put the expression or variable that you want to be converted, okay? Then you have string directives, and these are slightly different. This allows you to evaluate an expression for a conditional logic between the markers. So let's say we want to have an if-else statement. So if the name is blank, then use var name, or sorry, if it's not blank, then use the name provided. Otherwise, put it as unnamed, okay? You can also use interpolation directives with here docs. So, just to show that you can do it. And then the last one thing here is you can strip out white space that would normally be left by directives blocks by providing a trailing tilde. So just notice this little tilde here on the end because these do take up space. So if you were to view it, there'd just be an empty space there. If you want that space to vanish, then you just put that tilde on the end. So there you go. Let's take a look here at the possible operators that we can use within Terraform expressions. And so just a refresher, operators are mathematical operations you can perform to numbers within expressions. I'm not going to show full examples here and the outputs of them because this is pretty common for programming or scripting languages. And also the exam's not really going to focus on the use cases for these. So it's just more so to tell you what is available to you so you know what you can use. The first is multiplication, so you take two numbers and times them to get a larger number. Division, so it uses a / modulus. And if you've never used modulus, I really like this. It allows you to see if something is divisible by a certain amount, and then you get the remainder. You have addition, subtraction. If you need to flip to a negative number, you can just put a minus sign in front of it. If you need to do equals, it's doubles. If you want to do does not equal, it's exclamation equals. Then we have a less than, so that's a open angled bracket. Less than or equal, so that will be followed by an equal sign. Greater than is a closing angled bracket, and then followed by an equal sign for greater than or equal. You have or, which uses the double pipes. You have and, which uses the double ampersands. If you need to flip a Boolean, you can just put an exclamation in front of it. So if it was true, now it is false. If it was false, now it is true. I'm not sure what it would do for null. I would think that it would turn it to true. But yeah, so there you go. We're taking a look here at conditional expressions, and this is pretty much the only way that you can do if-else statements within Terraform, but it works out fine. And so it's actually using the ternary style of if-else. So what that looks like, it's a single line. So it starts with a question mark, so that's the if. And then it's the true value, and then the colon represents the else, and then you have your false value. It's ternary because there's three things, 1, 2, and 3, okay? So that's the way I remember this thing. It's not a preferred way of doing if-else statements in other languages because it is a little bit condensed, but it makes sense when you're using scripting language and you're really restricted on per line actions. So this is what it would look like in action. So we'd have a variable that is A. If A does not equal blank, then use the variable or set it to default A as a string. So that's kind of an example there. Just wipe that away there. The return type of it of the if and else must be the same type. So if you have a number, okay, and the one if statement, and then you have a string, they have to be the same. So obviously, we want a string to be returned in both cases. So what we'll do is use this built-in function toString to turn this into a string so that we're not going to run into any problems. So there you go. All right, we're taking a look here at for expressions. And so these allow you to iterate over a complex type and apply transformations. A for expression can accept as input list, set, tuple, map, or an object. I want to distinguish for this between for each, which is a resource meta argument, which allows you to iterate over a resource or a collection of resources that are similar, but for expressions are for these primitive types, or not these primitive types, but these collection structural types that we talked about in types and values, okay? So here's an example of something we might want to do. Imagine we have a list of names and we want to iterate through our list and make them all uppercase. So we could do that with this for. So we have the for with the in, and then we're providing the value of each item in our list. It's easy to think of list or tuple as an array, so I'll just call it an array, okay? Then you have a map, and so this is where it has a key and value. This is going to be for maps or objects. And the idea is that we can then go apply transformations. And notice that we are returning only a single string. So we're actually going to get back something like a tuple. And so how does it decide whether it returns a array or something that looks like an object? We'll explain that here in a moment. The last one here is we have a list with an index. So it's very similar to the first one, but in this case, we want to know the index here. So imagine this says 0 is Andrew, 1 is Cindy, 2 is Peter, and it would come back as an array or list. So let's talk about the return types. The return types are defined by the braces or brackets that are around the actual expression. So if you have square braces, we're going to get back a tuple. So let's just think of an array. So for in this case where we had our list, it was returning back a tuple, okay? If we have curly braces, it's going to return an object. So here we have a list, so it's like an array that's coming in here, and then we are specifying as the return this kind of object structure, and so that's how we're going to get that. So that's that. There's one other thing we want to mention, which has to do with reducing or ordering. So an if statement can be used to reduce the amount of elements returned. So in this case, what we're doing is we're using an if statement. And so we're saying unless this is true, so if this is true, then return. If it's not, then return less of what is there. So if there's any blank names that are in our list, they just won't show up. It'll just only show names that are actually there. Then we have implicit element ordering. So since Terraform can convert an unordered type, so map objects and sets, to an ordered type, list or tuples, it will need to choose an implied ordering. So for maps and objects, they're stored by key A to Z, set of strings stored by strings A to Z. Everything else is going to be arbitrary ordering. So there you go. All right, we're taking a look here at splat expressions, and these provide a shorter expression for the for expression, which we just looked at. So what is a splat operator? A splat operator is represented by an asterisk. It originates from the Ruby language, and splats in Terraform are used to roll up or soak up a bunch of iterations in a for expression. So here is an example where it's for list sets or tuples. So here we have a list, and the idea is that we're iterating over this ID, or in this case, we're iterating over its objects, or sorry, an array, and then that array is containing a bunch of objects, and so we're accessing the name within it. And so instead of writing it like that, we don't even have to use a for at all. What we can do is put this asterisk here, and this is going to equate to the same thing. So here, this is going to return all the IDs, and in this case, it's going to return all the lists and allow us to access the interfaces along to the name, okay? So let's take a look at splat expressions when we're applying them to lists. So if the value is anything other than a null value, then the splat expression will transform it into a single element list. If the value is null, then the splat expression will return an empty tuple. And so this behavior is useful for modules that accept optional input variables whose default value is null to represent the absence of any value, to adapt the variable value to work with other Terraform language features that are designed to work with collections. So I know that's a big mouthful. It's just kind of like an edge case to these splat expressions. This is not going to show up in the exam, but I just wanted to show it to you in case you're interested here. And just notice the splats being used over here, okay? So we're taking a look here at dynamic blocks, and this allows you to dynamically construct repeatable nested blocks. So I want to emphasize that this is a very powerful feature that can lead to abuse where your code becomes difficult to read, but it's also very flexible. It will absolutely show up in the exam, so pay close attention on how this works. So let's say you needed to create a bunch of ingress rules for your EC2 security group. And so this would lead to a lot of repeatable elements for rules within your resource. And so what you can do with dynamic blocks is you can define objects locally. So here I have my ingress rules as an object. So here's 1 and here is 2. And then using dynamic block, what I can do is use a for each to reference those ingress rules. And within this dynamic ingress block, we'll have our content, and this will specify the things that we're swapping out. So the idea is that it will iterate over this and apply all those values there. So it's something you can't do with a for each or a count. This is basically the most advanced iteration. But just understand, if you remember this use case, then it's very easy to understand or remember how to use it when you're doing your exam, okay? We're looking at version constraints. So Terraform utilizes semantic versioning for specifying Terraform providers and module versions. So semantic versioning is an open standard on how to define versioning for software management. So you have your major, minor, and your patch. And so here are examples or variants on this here. So we have, where you see major, minor, then you can have this RC1, or you could not have it, or you can have beta. And this can all be read about on the samver.org, but just to quickly go through it, major version is when you want to make incompatible API changes. Minor is when you add functionality that is backwards compatible in Manner. Patch is when you make backwards compatible bug fixes. There are additional labels for pre-release, build, metadata that are available as extensions. So that's where we see those little additions there at the top. A version constraint is a string containing one or more conditions separated by commas. So you have your equals or no operators, your equals or no operators. So match exact version of the number. So it's either with the equals or not with the operator at all. Okay, that's what I'm trying to write there. Excludes an exact number version. So if we just said does not or will not be 1.0.0, then you have comparative ones. So the version has to be greater or equal to 1.0.0. And then we have one with a tilde. So allows only the rightmost version of the last number to increment. So what this means is that the last number here is only allowed to increment, okay? So let's talk about progressive versioning, because this kind of ties into semantic versioning. But progressive versioning is the practice of using the latest version to keep a proactive stance of security, modernity, and development agility. And we like to describe this as practicing good hygiene when we're working with our code, okay? So by being up to date, you're always pushing left on things that need to stay fixed or compatible. You'll have to deal with smaller problems instead of dealing with a big problem later on. Run nightly builds is a good example where you might have golden images, and the idea is to provide a warning signal. Just to kind of elaborate on that, a nightly build is an automated workflow that occurs at night when developers are asleep. So if the build breaks because a change is required for the code, the developers will see this upon arrival in the morning and be able to budget accordingly. So what I'm trying to get at is that when you are putting in your providers, especially if you copy from the Terraform website to get the providers and modules, what they'll do is they'll actually have it set as I'm just going to roll back here for a second, but they'll actually have it set as the equals. But what I'm saying to you is you want to use something like a tilde or a greater than or equal sign so that you are staying progressive, okay? So that's just one thing I want you to watch out for. And we will talk about that when we go through the follow-alongs, okay? Hey, it's Andrew Brown from ExamPro, and we are moving on to our expressions section, starting with string templates. So let's learn all about that, and we are going to have to cd into a new folder here. So I have one called expressions, and we will make ourselves a new file called main.tf. We'll define a local backend, and I'm going to just define a new variable. I'm going to call this variable hello, and I'm going to give it a type of string. Okay, and that's all I'm going to do there. And then what we're going to do is create ourselves a tf-var file. So we'll say terraform.tf-vars, and in there we'll just set hello to world. And so what I want to do is enter Terraform Consul. Okay, this is going to allow us to just run arbitrary expressions. I want to show you how you quit it. You just type exit. And so what we'll do is make a string. So we'll just first do a hello world. I want to show you that you can put a new line there, and we'll get back a multi-line document. This console doesn't allow for multiple lines, so we can't write our own here doc, but I can show you what it looks like. And then we can interpolate a variable there. So we'll just say hello. And notice we get hello world. So that's how interpolation works. It's not super complicated. Directives is a little bit different, where we have string, right? So we can do instead this. But the control word's a bit different because you're using the this percentage sign, the directives, when you're doing something like an if-else statement. So what we could do is say something like barsoon here. Okay. And what I'm going to do is just exit out here, clear. So I don't know if it reloads the variables there if you just change them on the fly. But what we'll do is we'll just say hello, and we will write ourselves an if statement. So we're going to say if var.hello equals barsoon. What it's going to do is then print out. It's going to instead print out Mars. Okay. Otherwise, what we're going to get is world. Okay. And you know what's really interesting is we're using the if and else here. But I could have swore that the only thing you had was ternary operators. So like if you look at the conditional expressions, notice here that it's doing this and it's not showing the documentation, the if else. So, you know, maybe that's just for a one-liner and if else does exist for expressions, and I might have missed that in the course. But you cannot blame me if the documentation shows it like that, okay? So what I'm going to do here is just go ahead and hit enter. And here we get hello Mars. So that pretty much shows you how string interpolation works for both interpolation and directives. We'll just type in exit. And so that's all we want to do there, okay? All right, so let's learn about for expressions. So for expressions allow us to kind of iterate over something and do something fun with it. And so what we're going to do is create ourselves some more complex types here. So how about instead of like this was just hello a second ago, but we'll change this over to worlds. And what I'm going to do is just list out a bunch of worlds here from the book, John Carter books. So we have barsoon, we have jasum, we have things like sesum. Okay, and then we have sesum, and then we have something like cosum, okay? And so the idea here is now that we've defined that there, we got to go back to our main TF. I'm just going to update this to be worlds. This will just be a list. All right. And so what we'll do is make our way over to Terraform Cloud, or sorry, Terraform Consul. And we'll try to do a for loop here. So I'm going to do square braces for, and we'll just say w in var.worlds. And then what we can do here is make a colon, okay, and then type upper W. And so that returns them all in uppercase there. And if we were to use the splat operator, and technically this is something we want to move on to the next part, but yeah, we'll leave it for the next video. I'll just keep that separate. So that is for just if we had a list. Imagine if we had this as an index here. Or we'll say map. Because what we can do is actually map these to names. So we'll bring this down here. And this would be Earth. Now you can use the colon or the equals, it's just whatever you want to use here. They're both supported. Actually, this is an Earth, this is Mars. And then this one here is Earth. And this one here would be Jupiter. And then this one here would be Venus. Okay. And so I think we still need to define it over here. So I'm just going to say worlds map. And then what we can do here, instead of having list, we can say map. And we'll try to iterate over this. So it's going to be very similar, except the difference is now we have a key and we have a value. And so if we just want to return the names in capital, we can just do K here. Oh, that's the index. What if we do... Oh, you know why? It's because we have to do worlds map. Okay. So reference to undeclared variable map. So we do have to exit and restart. And, oh, sorry, the input was complaining there. So I'll just copy the one up here so I don't have to type it again. Nope, it did not work as we thought. Okay, so I do have to type it by hand. Kind of a pain, but I guess that's just how it works. So we'll say for kv in var.worlds map. And then we can say upper v here. Okay, or we could just say take the k here and get the other values. Now, I didn't show you this a moment ago, but if we do worlds here, we can specify an index, and an index would come first, so it would be the value, like the world is second, and the index is first. So notice that I is all a number, the index of it, and then that is the value there. We could probably also return this as a map. So notice that square braces are going to give you a list, or and then curlies are going to give you map, which kind of correspond to their actual data structure. So if we wanted to turn this into the opposite here, what we could do is just say, we could probably do string interpolation, like this here, and do I, and then do equals, or even maybe a colon here, and then do the world like that. And it didn't like the way I specified it, so I'll try it like this instead. Extra characters after line 4. So I don't see that wrong there. Just give me a moment. I think, oh, you know what? We need to use, in this case, I think we have to do it this way. Okay. So we use the hash rocket. So in that particular case, you have to use the hash rocket. That's what that symbol is called, the equals arrow. And so that's how we can get that value there. So that pretty much outlines how to use the for loops. And next we're going to go probably look at the splats, okay? So I'll see you back here in a moment. I'm just going to exit this. Actually, before we move on to splats, I just want to add one more thing to for expressions, which is filtering. So we'll just go back here and get back into our Terraform console here. And what I'm going to do is just write another for. And it probably would make sense to use the worlds list we just did there. So I'm going to do kv. Type in var worlds map. And so the idea here is that I only want the, we'll say the upper, I only want the key value here, but I would just say at the end here, I can say if the value equals, and I can't remember what we set these as. So this is key and value. So if it is Mars, I think it's double equal. So if it is Mars, then only return it that way. Or we could say the opposite, say, get me everything but Mars. Okay, so I just wanted to show you could use that if to do that filtering. So I'm going to exit there, and we'll move on to splats, okay? All right, so we're moving on to splats, and what we'll have to do is create ourselves a new variable here. I'm going to call this one worlds splat, and this one is going to be a list. And so if we go back up here to tfvars, we'll make ourselves a new variable down here, and we'll just call this one splat. And it's going to be a list, but it's going to contain inside of it a bunch of maps. Okay, so we'll do pretty much this up here. Okay, but what's going to happen here is going to be slightly different, where we are going to set, one is the name. So we'll just say like Earth name. That's actually Mars name. So we'd say Mars name here for all these. And then over here, these are going to be the Earth name. So I think that is valid, and what we're going to do here is just type in Terraform console. And if we wrote that correctly, oh, no, we got an error. So it says expected an equal sign to mark the beginning of a new attribute value. So, I mean, this should be okay. Oh, you know what? I think this colon's just missing here. Put it up again. There we go, we're fine. So if we just want to look at that variable, I think we just type it in here and it might print it out if we're lucky. Yes, so there it is. So what we're going to do here is use a splat to get maybe the Mars name or something. So if we used a for loop, what we'd have to probably write, we could try this, but we'd have to do for, and then it would be for the actual map. So say M for map in worlds splat, and then we would have to do M dot Mars name. And so a reference to the attribute, but one access attribute specifying the resource name. So I mean, that looks, oh, you know, it's because we didn't write var. Okay. I say we, but it was really me. So, you know, that's that, but we could write this in a more concise way. Okay, and so we use a splat, Mars name. Okay, so, you know, that's a lot more convenient if we're just trying to access variables like that. I think that if you're trying to do things like, if you want to do upper here, I think you still have to use a for expression. Okay, I don't think you can do this. We can try it, but I really don't think that will work. No. And if we look at the documentation, they don't show an example like that. So, you know, it's not that bad, but you can see that it's for a particular use case. You can't use that for maps or whatever the equivalent, the other map is, object. But it's useful for this one particular use case, okay? Hey, it's Andrew Brown from ExamPro, and we are on to the dynamic blocks follow along. So this one should be pretty fun because it's quite a powerful feature. So what I've done is I've created a new folder here called dynamic blocks. I'm going to make a new file here. As always, it's going to be main.tf. And a really good example for this would probably be an AWS security group, just because there's all those ingress and outgress or egress rules. So what we're going to do is just define our Terraform settings block, and I'm just going to pull up over here and make our way over to the registry for Terraform. And what we're going to do is go over to the AWS provider and go to the documentation. And actually, I first want to grab the provider itself, because that is something very easy that we can do here. We'll just move that on over so we can see what we're doing and paste that on in. And we're going to have to define our provider, of course. So we'll name that as AWS. The profile is going to be default. And our region will be US East 1. Okay, and so now what we need is to go create ourselves a security group. So we have, of course, done that previously here, but let's pull up the documentation here. I believe it was actually under VPC, so let's just go down to VPC here, and we will expand that. And then underneath here, there should be an AWS security group. There it is. And if we scroll on down, there's the thing, okay? So what I'm going to do is copy this code here and go over, and we'll just paste that on in. And there is our security group. So I remember that we had to have the description. If you remember, it complained about that. So outgoing for everyone. And we need to also have a few additional things. We will just scroll on down here because it wanted the prefix list IDs. Okay. Remember, we needed that. I think there was like self false. And there was like security groups. I think it was actually AWS security groups in particular. Let's just double check to make sure that is the case. It is called, oh, it's just security groups. Okay. So, we'll say self equals false. We do not need CIDR block 4 here, or 6. We do not need this one here. And it doesn't really matter what we set this to. So it could be set to the main CIDR block. That's totally fine. But we are going to need to add a data source, just like last time, for the VPC. So we'll say VPC. We'll call that main. And I think it just needed the VPC ID. It was as simple as that. And so we will go over to AWS, over to VPC. And from there, we are going to go to our VPCs, and I will go grab that VPC ID. Okay, so we've grabbed our VPC ID, and then we just need to name this as data. And then we're going to name this as data. We don't really care what the CIDR block is. It's just, again, for this demo purposes. We don't need tags. We'll take those out. And yeah, everything else is fine. Okay, so this now comes to the fact that we want to use dynamic blocks. Before we do that, let's just, well, I think I didn't leave the console there last. But what we'll do here is just do our Terraform init. And as that is pulling that stuff, we're going to look up dynamic blocks. Terraform. So we'll go here. And so dynamic blocks is like way more powerful than the for each, where what we can do, I'm just trying to find that example there, but we have to set the dynamic part, the for each. You know what, I'm pretty sure I have these in my slides, so let's just use my slides as the reference here. Dynamic, here it is. Okay, so the idea is that we'll just set up a locals with all of our information here, and then we'll create this dynamic block and then provide the content, okay? So I'm just going to move that off screen so I can see what I am doing here as we type it in, and we'll see if we run into any problems. Failed to query the available provider packages, could not retrieve the list of available versions for the provider. Not have a provider registry, Terraform name. All modules should specify the required providers. So I'm not sure why it's complaining here, but we'll scroll all the way to the top, and the required providers is correctly set here. So it shouldn't be a problem. Not sure what it doesn't like. So we'll just type in Terraform Providers here. The VPC. Is VPC a module? You know what? It's probably because I didn't do AWS VPC. That's probably my problem here. Terraform init. And as that's thinking there, we'll just pull this on down and we'll start to make our locals block. Okay, so we can go here, make some locals, and we'll do our ingress. And we'll just go like that. And the idea is we can say port, whoops. We can set the port like that, 443. We have to always have a description, so we'll just set that as well. So port 443. We can set as much as we want here, so I'll just go hit enter. Okay. And I think that looks right. Yeah, so we have one ingress here, and then we'll just copy this and make a comma. VS Code's not really formatting the way I want it to, and so we'll do port 80. And then down below, we will need to specify our for each, okay? So that's going to be within our dynamic block. So what we're going to do is tab in here, and we're going to say dynamic, and we'll type in ingress, because that's a match for what we're doing. And then from there, we can do our for each equals local ingress. And then we need to specify our content. I don't really understand why it's called content and things like that, but I just know that that's what we have to do. And it's not really that big of a deal. So we'll go here and paste that in. We can take out our ingress block there. We know we're going to need self, these all here, but what's going to change are these ports. So we will go here and we'll say ingress, value, port, And this will also be ingress value port. And then this will be ingress value description. If we really wanted to, we could also set the protocol. And this could be then TCP. And so we would just say ingress value protocol. So it just saves us from repeating these over and over again if they're all the same. There's a lot you can do with dynamic blocks, but honestly, you shouldn't do anything too crazy. We'll do our Terraform plan and see if this works. Whoops. Bring that up there. An argument VPC ID is not expected here. Okay, so that was me just guessing from memory, and I guess I guessed wrong. So what we'll do is we'll just look that up. Database VPC data source Terraform. Oh, it's just ID. Okay. So what we'll do is just set ID here. And then we'll just hit plan again. And that should resolve our issue there. Inappropriate value for attribute egress security groups is required. Okay. That's fine. Well, this one it says, doesn't say security groups. And this one doesn't say security groups, so that's probably our problem here. So we'll just hit Terraform plan again. And here it says this VPC ID does not exist. Probably what happened is I might be in the wrong region. It's a very common problem on AWS just because of the way their UI works. If I can get this window over here. And so this is because we're in US East. We're supposed to be in US East 1 here. And I'm going to go up to here. We will save that. I'm going to hit Terraform plan. And we could probably like use the filter and also just say choose the default, but it's just so easy to put that in like that. So doesn't seem like we have any problems here. So let's go ahead and execute it. Let's just double check to make sure these values are correct. So for the ingress, port 443, it's probably just because I didn't update the description. Probably because of a copy paste job. Yep. Okay, and let's just make sure this works. So we'll say Terraform apply auto approve. And we'll give it a moment. And it's already created, so it's that fast. We can go here and take a look at it if we like. It's not that big of a deal. So we should see it in here. I just have so many junk security groups here. It's just a bit hard to find. Oh, allow TLS is what we called it, so here it is. Go to our inbound rules, 80443, and that's pretty much it. So Terraform, apply, destroy, auto approve. Okay. And there we go. All right, so I want to talk about versioning very quickly here. And so I have a new folder called versions. I'm going to just make a new file called main.tf. And we're going to create a Terraform block. But what we're also going to do is set required providers, or sorry, required, not providers, required version And so what this is going to do is say explicitly what version of Terraform we want to use. And I'm setting this as 1.0.0, and I'm using this tilde arrow. If you're wondering, what is the logic behind all those things, I think it's all explained in the semantic or semver.org. So if you want to learn more, I strongly recommend you read through this to understand all this stuff inside and out. Highly applicable across the DevOps sphere, not just to Terraform. But, if we go over to Terraform GitHub repository and we drop down the branches and go to tags, here we can see all the versioning. We are using version 1.0.0, and it all goes up to 1.1.0 alpha, which is not out yet. And if you wanted to really know what's going on here, you go to releases, and you can read what they have done. So here in 1.0.7, remove check for computer attribute, prevent object types with optional attributes for etc., empty containers. So when you're looking at the patch, which is the third number, the rightmost number, that's going to keep you up to date in terms of security for the major minor version that you have for the 1.0. And you absolutely always want to be using the latest. And so that's what this tilde does. It says take the farthest number to the right and make sure that it's the latest version that has been published. And this comes back to my progressive versioning slide, which is if you want to have really good hygiene in terms of your DevOps, what you should be doing is at least setting the tilde for sure, like this, the tilde arrow, or I would even go as far as saying equals arrow. And if you're really concerned about, not using the next major version, you could say, well, less than 1.2.0, even if it's not out, that's a good indicator to say, okay, well, I don't want to go too far ahead of time, but if you want to have progressive versioning, you should really be setting it like this, okay? And this is going to be applicable for your AWS providers, anything else. So, if we go over to, the registry and we choose, AWS, and we drop this down here, we have that required version as well. So as you copy it in, you're going to notice that it's actually hard-coded, but I would strongly recommend, again, if we go here and take this and at least do this, and if you're really, really being clever, you could do that, okay? And these are also all in GitHub repositories, as that's how everything works. So you can go here and click, and you can go over to the tags and see the versioning, and you can go over to the releases, and it's the same thing. You can read about all the things that have changed, okay? And that's something that you should, consider doing, all right? So that's all there really is to this. I might want to just show you one more thing, and this one is with Terraform Cloud. So I'm going to go to Terraform.io, and we're going to open up our Terraform Cloud, and I'm going to sign in. I probably haven't signed in a while, so I'll probably ask, oh, nope, no username and password. That's great. But what we can do is in a workspace, we can go to settings, and is it version control? No, it is general. And under here, we can actually set the Terraform version. So if you happen to be working with a particular version, you can go and say, okay, only use this version for Terraform Cloud, and that will not upgrade it. It'll just keep you there if you need it for legacy reasons. But again, what you really should be doing is using that progressive versioning, doing nightly builds, and discovering overnight that things are breaking, so you can go fix those in the morning, okay? And that's it. Hey, this is Andrew Brown from ExamPro, and we are taking a look at Terraform State. So what is state? Well, it's a particular condition of cloud resources at a specific time. So give an example. Imagine we expect to have a virtual machine running CentOS on AWS with a compute type of T2 micro. That would be the state that we are expecting, okay? So how does Terraform preserve state? Well, when you provision infrastructure via Terraform, it will create a state file named Terraform TF state. It's very important to remember that name because it literally is an exam question, the exact naming of that, okay? This state file is a JSON data structure with a one-to-one mapping from resource instances to resource or to remote objects. And if you're wondering what is a remote object versus a resource instance, I cannot tell you. I would imagine one is a representation of things that are deployed in the cloud, and the other one are objects or things represented in the state file, but they don't clarify it, so I just had to take a guess. So this is kind of what the JSON structure looks like. You can see, you see resources, it's describing like a type of instance and stuff like that. There's not really any case for you to ever go through the Terraform state file and look at it. but we might take a peek just so that we get familiar as to what it is doing. So just to kind of give it a diagram to help you visualize this, imagine you have your configuration file. So you have your main TF, maybe a variables TF, a TF vars to load in your variables, and then you run a Terraform apply command. What it's doing is using the Terraform API, and it's going to create, we'll say these, we'll call these remote objects, but maybe these are resource instances. But it will go ahead and create those things, and then those will get represented within a state file. So the idea is that whatever is in the cloud is going to match what's in that file, okay? Now, there is a CLI commands for Terraform State, and it's good just to quickly go through them. So we have Terraform State list. This will list resources in the state. Terraform State move. This will move an item in the state. Terraform State pull current remote state and outputs to SD out. Terraform State push, so update remote states from a local state. Terraform State replace provider, so replace a provider in the state. Terraform State remove, so remove instances from the state. Terraform State show, so show a resource in the state. Some of these are a little bit interesting, so we'll definitely look in greater detail to move, and some of these we will just explore through our follow-alongs, okay? Okay, so we're going to give special attention to Terraform State Move because it's definitely on the exam, and it is a little bit interesting to what it can do. So Terraform State Moves allow you to rename existing resources, move a resource into a module, move a module into a module. So if you were just to rename a resource or move it to another module and run Terraform apply, Terraform will destroy and create that resource, but State Move allows you to just change the reference so you can avoid a create and destroy action. So an example for renaming a resource, we would have Terraform State Move, and then we would identify the old one. So here we have packet device.worker, and we are renaming it to helper. So that's just how we're doing it, okay? If we wanted to move a resource into a module, what we do is say something like packet device.worker and then do module.worker.packetdevice.worker, okay? So the idea here is that we're moving it into this module here. And I think we could probably even rename it at the same time, but we're not doing that, okay? So move module into a module. So here we have module app, and then we're moving it into the parent one. So we go module.parent, module.app, okay? So what's important to remember for the exam is that Terraform State Move is when you want to rename existing resources. They're not going to get into these more complicated use cases, but that's how you rename a resource, okay? Okay, let's talk about how we back up our state file. So all Terraform State subcommands that modify state will write a backup file. So read-only commands will not modify it. So imagine list and show will not cause a backup file to be created. Terraform will take the current state and store it in a file called terraform.tstate.backup. So this is what it would look like. Backups cannot be disabled. This is by design to enforce best practices for recovery. To get rid of the backup file, you would need to manually delete the files. So there you go. Hey, it's Andrew Brown from ExamPro, and we are taking a look at Terraform Init. So it initializes your Terraform project by downloading plugin dependencies, so providers and modules, creating a .terraform directory, so that's a hidden directory, and creating a dependency lock file to enforce expected versions for plugins in Terraform itself. So on the right-hand side here, we can see we have that hidden directory. But also notice here that we have a .terraform lock.htl. That is our dependency lock file. And so our dependencies are all going to end up within this, see where it says providers, that's the provider version there, okay? So Terraform Init is generally the first command you will run for a new Terraform project. If you modify or change dependencies, run Terraform Init again to have it apply the changes. You need to know that for the exam because they will absolutely ask you that. The first command here is, and these are ones with flags, so you can just do Terraform Init, but we have some extra options. So Terraform Init -upgrade, upgrade all plugins to the latest version that complies with the configuration version constraint. Terraform Init -get plugins, and I think it's supposed to be equals false there, but skip plugin installation. Terraform Init plugin -dir equals path, so force plugin installation to read plugins from only target directory. And then we have Terraform Init -lock file, so you can change the lock file mode. It actually doesn't say what the modes are, so I don't even know what you do in that case, and I could not find any examples, but it is an option. I just want to make it very clear that there is a dependency lock file, but there's also a state lock file. And the way you know that they're different is that one has .lock in it and the other one has .tf state. This one up here is for dependencies. This one, of course, is for state. Terraform init does not create a state lock file. That is going to happen when you do a Terraform apply, okay? Let's take a look at Terraform get. So Terraform get command is used to download and update modules in the root module. So when you're a developer, you own Terraform modules, and you may need to frequently pull updated modules, but you do not want to initialize your state or pull new provider binaries. And so the idea here is Terraform get is a lightweight way because it's only updating the modules, it's not pulling providers. In most cases, you want to use Terraform init with the exception of local module development. This will not show up in the exam, but I saw Terraform get and I was just so confused about it, so I just wanted to make sure I included it here, okay? Okay, so we're going to be looking at 3 CLI commands that are used to improve debugging configuration scripts. The first is going to be Terraform format. This rewrites Terraform configuration files to a standard format and style. Terraform validate. This validates the syntax and arguments of Terraform configuration files in a directory. And then you have Terraform Consul, an interactive shell for evaluating Terraform expressions. And so let's go jump into these 3, okay? All right, let's take a look at Terraform format. So this command applies a subset of Terraform language style conventions along with other minor adjustments for readability. So Terraform format will be, by default, look in the current directory and apply formatting to all your .tf files. So let's look at some examples of what it would format. So the first is adjusting spacing to spaces indent. So here we have something and it's over indented. And so by running Terraform format, it fixes the indentation. We can also get syntax errors. So notice here that we have a problem. And so what it's saying is that this bracket, okay, is supposed to be up here, okay, but it's down here. And the last one here is we can do Terraform format --diff. And that's going to show what it would change, okay? So there you go. Let's take a look at Terraform validate. So this runs checks that verify whether a configuration is syntactically valid and internally consistent regardless of the provided variables in existing state. Validate is useful for general verification of reusable modules, including correctness of attribute names and value types. So here's an example where I just had some code and there was a problem. It's just saying you're missing an argument because for an AWS instance, you always have to specify an instance type. So when you run Terraform plan or Terraform apply, validate will automatically be performed. One thing I need to mention about Terraform validate is that it does not go to external resources to check things are valid. So if you have a value and it's expecting a string, that's all it's going to check for. It's not going to check that the string is actually a proper like type of size. So if it's supposed to be like a t2.micro and you write, you know, gobbledygook in there, it's not going to know that that's not a valid type. So, but we do cover that in the follow-alongs, and I think we have like some practice exam questions that cover that use case, okay? We're taking a look here at Terraform Consul, and this is an interactive shell where you can evaluate expressions. So the idea is you type in Terraform Consul, and what I can do is I can, you know, use like built-in functions and expressions. So there I'm using min, and I've actually entered it in incorrectly. So there it's throwing an error, and here I'm using the correct way of using it, and so I get the output. So this is a great way just to kind of test very simple things. You can't do things like define variables or resources or define providers, but if you need to figure out how the expressions work before you apply them in your code, this is a great place to do that, okay? All right, let's talk about Terraform plans. So this command creates an execution plan, also known as a Terraform plan, and it consists of reading the current state of an already existing remote object to make sure that the Terraform state is up to date, comparing the current configuration to the prior state and noting any differences, proposing a set of change actions that should, if applied, make the remote objects match the configuration. And so this is an example of one that is generated. You're going to see it throughout this course multiple times, so it's not going to be unique. That's why I don't have to make that too big for you there. Terraform plan does not carry out the proposed changes. That's going to be the responsibility of Terraform apply. And a Terraform plan file, if you happen to generate one out, is a binary file. So if you open it up, it's just machine code. You cannot make sense of it, okay? So when you run Terraform apply, you have speculative plans and save plans. And so speculative plans is what's going to happen when you run Terraform apply. So Terraform will output the description of the effect of the plan, but without any intent to actually apply it. When you have a save plan, you're going to have this -out flag to save it, and you can name that file whatever you like. And it will generate out that save plan file. And again, that's a binary file, so you're not going to be able to see what it does. And what you can do is then pass it along to Terraform apply. So you do Terraform apply, whatever the file name is. And when you are using Terraform apply, what you have to understand is that it will not ask to manually approve it as you normally would. It would just be auto approve. So that's one thing you have to watch out when using those save plans. But, I just wanted to make it concretely understood that Terraform plan can generate out a file, and it's not actually the one that's doing the apply, okay? I don't have it written in here, but when you do Terraform apply, it also is running Terraform validate as well, okay? Let's talk about Terraform apply here. So Terraform apply command executes the actions proposed in an execution plan, and it has two modes: the automatic plan mode and the saved plan mode. So for automatic plan mode, that's just when you run Terraform apply. What it's going to do is execute the plan, validate, and then the apply. You have to manually approve the plan by writing yes. But if you want to skip that process, you can use the -auto approve flag to automatically approve the plan. We just saw save plan mode, like how it worked in the previous slide, but let's cover it again. So when you provide a file name to Terraform to the save plan file, it's going to be Terraform apply file, and it's going to perform exactly the steps specified by that plan file. It does not prompt for approval. So if you want to inspect a plan file before applying it, you can use Terraform show, okay? All right, let's talk about managing resource drift. So drift, or configuration or infrastructure drift, is when your expected resources are in different state than your expected state. And the way we can resolve drift are in three different ways in Terraform. We can replace resources. So when a resource has become damaged or degraded that cannot be detected by Terraform, we can use the -replace flag. We can import resources. So when an approved manual addition of a resource needs to be added to our state file, so we use the import command and refresh state. So when an approved manual configuration of a resource has been changed or removed, we're going to use the refresh only flag to reflect the changes in our state file. It's very important to know these three different ways. They will all show up in the exam, and in practice, you're going to need to know them, okay? Let's first here take a look at replacing resources. So we can use the Terraform Taint command. It is used to mark a resource for replacement the next time you run apply. And why would you want to mark a resource for replacement? Well, the idea is that, and here's the command here, but a cloud resource becomes damaged or degraded, and you just want to return the expected resource to a healthy state. So that's the idea behind it. And the unfortunate thing is that Terraform Taint was deprecated in version 0.152. However, there is a better way of doing it now, and so it is recommended to use the -replace flag and providing it a resource address when you're doing a Terraform apply. So it's basically the exact same thing. The reason why they made this change was so that you actually have an opportunity to confirm your change beforehand, because Terraform Taint would just run, and this one down below will actually prompt you to say, are you sure you want to do this, okay? But it's not complicated. You just do -replace, and then you use the resource address of the thing that you want to use that for. And this can be used for both plan and apply. The replace flag appears to only work for a single resource, so you can't use multiple resources. It's just one at a time, and that's something that you should remember, okay? So we just saw a resource address, and resource addressing is very important to know for the upcoming commands. So let's just give it a bit more attention here. So resource address is a string that identifies 0 or more resource instances in your configuration. An address is composed of two parts, so the module path and the resource path. And just to expand out that module path, it would be module.module name, module index. And then on the resource spec, this is resource type.resource name. And then if there's multiple instances, you give it an index. So module path addresses a module within a tree of modules. A resource spec address is a specific resource instance in the selected module. So a module is the namespace of the module. Module name is user-defined name of the module. Module index when the so when there's multiple specifying index. On the other side, that's your resource type, your resource name, and instance ID. Most of the times you're going to be just working with resources, but once you start getting to modules, it becomes pretty simple. It's always going to be module period, because that's just, I think that's the name of the name value. So it's always going to be module dot and then the module name. But here we have a very simple example just for resource type. So here, if we had a resource called ABUS instance and it was web, and there was 4 of them, and we wanted to select the third one, we do AWS instance.web square braces 3, and that would get us the third virtual machine. So there you go. Okay, let's take a look here at Terraform import, and this is a command that is used to import existing resources into Terraform. So this is how you define it. So you'd say what resource you want, and you can just leave it blank. So you define a placeholder for your imported resource and configuration file, and you can leave the body blank and fill it in after importing, but it will not be autofilled. So you do have to specify all the values, okay? So the idea here is you're going to do Terraform import AWS instance.example, and then the name of the ID. So that maps over to the resource address and the ID, okay? The command can only import 1 resource at a time. This sounds very similar to that other command we saw for replace. Not all resources are importable. You need to check the bottom of the resource documentation for support, okay? Okay, so we're going to look at refreshing, and so we're going to break this between the old command refresh and the new command refresh only across 2 slides. So Terraform refresh command reads the current settings from all managed remote objects and updates the Terraform state to match. So here we have the Terraform refresh, and I just want to point out that the Terraform refresh is basically the alias for Terraform apply -refresh only -auto approve. So you technically have this functionality in the latest version. It's just that you can't use the old alias Terraform refresh. Terraform refresh will not modify your real remote objects, but will modify the Terraform state. So Terraform refresh has been deprecated, and the refresh only and with the refresh only flag, like it's been replaced with it because it's not safe, since it did not give you the opportunity to review proposed changes before updating the state file. So that's why the reason they got rid of it. Let's take a look here at the refresh only mode. So -refresh only flag for Terraform plan or apply allows you to refresh and update your state file without making changes to your remote infrastructure. Just to really make this clear, I want to give you a scenario, and I want you to pay close attention here to understand the difference, because this is so important on the exam and also extremely useful for your day-to-day operations. So here's a scenario. Imagine you create a Terraform script that deploys a virtual machine to AWS. You ask an engineer to terminate the server, and instead of updating the Terraform script, they mistakenly terminate the server via the AWS console because they don't know any better. So what happens if you were to run a Terraform apply versus with a refresh only flag? So that's what we'll do with and without the flag. So without the flag first, Terraform will notice that the VM is missing. Terraform will propose to create a new VM. So the state file is going to be what's considered as correct, and the changes to the infrastructure will be made to match the state file, okay? If we use Terraform apply -refresh only, Terraform will notice that the VM you provisioned is missing, but with the refresh only flag, it's going to know that the VM is missing. It's intentional, okay? So I have a couple spelling mistakes there, but the idea is that it knows that the VM is supposed to not be there. So Terraform will propose to delete the VM from the state file, so just the JSON code from the state file. So the state file is considered wrong, and changes to the state file will be made to match the infrastructure. So hopefully that makes it clear, okay? So let's take a look here how we would actually go about troubleshooting Terraform. So there are 4 types of errors you can encounter with Terraform. The first is language error. So Terraform encounters a syntax error in your configuration for the Terraform or HCL language. You have state errors. So your resources states has changed from the expected state in your configuration file. Core errors, so a bug that has occurred with the core library. Provider errors, so the provider's API has changed or does not work as expected due to emerging edge cases. And when we talk about what's easy for us to solve and what's hard, well, the first two are very easy and the other two are harder to solve. So for language errors, we can use format, validate, or version to resolve our language errors. Version would just say, hey, what version are we using? Maybe we need to update it, right? Validate would detect if something's wrong with the syntax, and format would fix formatting syntax, but that probably wouldn't fix that much there. For state errors, the idea here is we might want to use refresh, apply, replace, everything that we saw in the drift section. For core errors, we might want to go check out the log. So tf_log is basically just the way of saying like, hey, these are where the log files are, or is logs turned on? We have a whole slide on that. But really, like, all you're going to do is use the logs to find information and then report a GitHub issue. Since all Terraform is on GitHub, you would just go there and then somebody would try to resolve it. And the same thing with providers. So providers are all hosted on GitHub. And so you would just use TF logs to try to find some information there. But we'll take a greater look at TF log and how to, get that information for the harder to solve cases, okay? Okay, so let's talk about how we would go about debugging Terraform via the log file. So Terraform has detailed logs which can be enabled by setting the TF_log followed by the type of environment you want to run. So the variables that we have, or the environments we can specify, is trace, debug, info, warn, error, or JSON. JSON will output logs at the trace level or higher and use parsable JSON encoding as the formatting, okay? So logging can be enabled separately. So you can do this via TF log core, or you can get it at the TF log provider. So if you just want core stuff, or if you just want provider stuff, you just set those environment variables. And as we saw in the previous thing, that there was core errors and provider variables, so that could be a good way to do that. And so TF log core, and TF log provider take the same environment variables we see on the right-hand side there: trace, debug, info, etc. Okay. If you want to choose where you want to log things, you just can set the TF log path. I don't think I actually say where the default path is. I think it's actually in the project directory, but if you want to override that, you can. I imagine it either takes an absolute path or a relative path. And here's an example of a Terraform log. So this is for everything. And so there you can see information. I'm going to get my pen tool out here for a moment, but you can see we have information about the provider. This is using there. Then there's some backend local stuff. So, there's some information. You're not expected to understand this information generally, but you could go bring it to the provider. But you could probably solve something, if you were to read the core code or the providers, okay? Okay, so we looked at TF log, which is the Terraform log, but there's also a crash log. And so if Terraform ever crashes, and basically this means it goes into panic because it uses the Go runtime, it saves a log file with the debug logs from the session, as well as the panic message and backtrace to the crash.log. And so I imagine this is Golang information. So I don't use Golang that often, but you can see we have .go, panic.go. So I think that there's not much you can do with it. So this is where you would just create a GitHub issue and pass it along to the Terraform team, because they're going to be able to make sense of it, okay? All right, so we're on to our module section. So let's first talk about how we would go find a module. I know we already saw this earlier when we were looking at the Terraform registry, but let's just cover it again and talk about some of the details of search, okay? So Terraform modules can be publicly found in the Terraform registry. And so on the left-hand side, when you're under the modules within the Terraform registry, you can filter your providers, okay? But another thing you can do is you can type in search terms, and you can do partial search terms like Azure Compute. But what I really want you to know is that only verified modules will be displayed in search terms. And so I assume that means verified and also official ones. And the reason I'm giving this extra emphasis is because it was an exam question. So I just want you to know that only verified and official ones are going to show up when you search, okay? Let's talk about using modules, and there's our public modules and private modules. So public modules are going to be on the Terraform registry, and private modules are going to be in Terraform Cloud, or I suppose Terraform Enterprise. So Terraform registry is integrated directly into Terraform, so it makes it really easy to start using them. So all you're going to do is use the module block. So I'm just going to highlight that there. Then we have the name of our module. We're providing the source of our module, and then there's the version of our module. Terraform init command will download and cache any module referenced by a configuration. Now looking at private modules, it looks very similar. It's just that the name is different. So we're specifying the host name in front here and a namespace as well. So to configure private module access, you need to authenticate against Terraform Cloud via Terraform login. So that's something there. We definitely cover that a lot in the practice exam. So just in case, you know all the edge cases there. Alternatively, you can create a user API token and manually configure credentials in the CLI to configure the file. So there you go. Let's talk about how we would go about publishing modules, and this in particular is for the Terraform registry. So these are public modules. So if we want to publish modules, it supports versioning, automatically generating documentation, allowing users to browse the version histories, showing examples and readmes. And all of these modules are actually going to be hosted on GitHub. So the idea is you're going to put your module there first. And once a module is registered to push updates, you simply push new versions to properly formed Git tags. You have to name your modules in a very particular way on GitHub. So the thing is, it has to start with Terraform hyphen, then the provider, so AWS, and then the name, so hyphen VPC. And the way you publish it on Terraform registry is you have to connect and publish via your GitHub account. So you just hit sign in with GitHub, and it's just going to give you a drop down, and you're just going to choose the repo, and that's as simple as it is, okay? All right, let's talk about verified modules. So these are reviewed by HashiCorp and actively maintained by official contributors to stay up to date and compatible with both Terraform and the respective providers. So here's an example of a module from our friend Anton down below. And as you can see, it has a little badge. That's how you know that it's verified. So verified modules are expected to be actively maintained by HashiCorp partners. Verified badges aren't an indication of the flexibility or feature support. But just to kind of go through some things here, very simple modules can be verified just because they're great examples of modules. Unverified modules could be extremely high quality and actively maintained. Unverified modules shouldn't be assumed to be poor quality. Unverified means it hasn't been created by a HashiCorp partner. So, that again, it's not indicative of quality, but it just means that it's gone through a bit of vetting, okay? All right, let's take a look here at the standard module structure. And this is a file and directory layout recommended for module development. And this is the idea if you were to go and publish your own module, this is what people would expect to see. So if you had a root module, that's what it'd be. And you have nested module. I want to point out that when you are writing Terraform, you technically are creating modules, even if you aren't intending them to publish them into the Terraform registry. But when you make a main.tf, you've basically made your own root module, okay? So the primary entry point is the root module, and these are required files in the root directory. So your main.tf is the entry point file for your module. Variables.tf is the variables that can be passed in. Outputs.tf are outputted values. README describes how the modules work. License, the license under which the module is available. For nested modules, which are optional but must be contained in the modules directory, a submodule that contains a README is considered usable by external users, and a submodule that does not contain a README is considered for only internal use. And the idea is to avoid using relative paths when sourcing module blocks. So hopefully that gives you an idea, okay? Let's talk about core Terraform workflows, and these have 3 steps: write, plan, and apply. So write, plan, and apply. We saw this kind of in the Terraform Lifecycle. And the idea here is that, it's just to try to describe what it's going to be for your team and requirements as you grow and you're utilizing this workflow. So if you're talking about individual practitioners, so a single person, a team using OSS, so they're using open source software, so they're using Terraform, but they're not using the Terraform Cloud platform. And then what it would be like if they're using the Terraform Cloud platform. In terms of this right plan apply, you're going to see these examples don't perfectly fit here. I am just presenting a summarized versions of the documentation. And the reason why is because on the exam, this is one of the subdomains that you need to know. So I'm not saying that I think these are perfectly presented, but I think that I have to cover them because they are on the exam. And you do learn something here, so we will go through them, okay? So let's take a look at a Terraform or team workflow for a single person, an individual practitioner, looking at the right step first. So you're going to be writing your Terraform configuration in your editor of choice on your computer. But the thing is, you'll be storing your Terraform code in something like GitHub. Even if you are an individual user, you're going to be putting in Git or GitHub or some kind of version control system. You're going to be repeatedly running Terraform plan or even possibly Terraform validate to find syntax errors. And the great thing about this is that you get this tight feedback loop between editing the code and running your test commands because it's all on your local machine. We're not sending things off to build servers or other services, so it's very fast and easy. Talking about the plan stage, so when the developer is confident with their workflow in the right step, they commit their code to their local repository. This is the stage where it's a local commit, it's not a remote commit. They may be only using a single branch, so just you're probably working in main, or if you're still using the old syntax, master branch. Once their commit is written, they'll proceed to apply. That'll bring us to the apply stage. So they will run Terraform apply. This is on your local machine. It's not part of any other process. You're just running Terraform apply, and they'll be prompted to review their plan. After the final review, they will approve the changes and await provisioning. After a successful provision, they will push their local commits to their remote repository. So this is where you will then finally commit your code. So there you go. So we looked at what it would be like if we had a single person working with Terraform. Let's talk about if it's a team and they're not using Terraform Cloud, they're just doing it the old-fashioned way, okay? So each team member writes code locally on their machine in their editor of choice, as per usual. A team member will store their code in a branch in their code repository, whether it's a per feature, per user, per whatever is up to you. Branches help avoid conflicts while a member is working on their code, but branches will allow an opportunity to resolve conflicts during a merge into main. It's no different than working with, code, because that's what it is. Terraform plan can be used as a quick feedback loop for small teams, so we still have that option. But as your team grows larger, a concern over sensitive credentials becomes a concern. And so this is where you may need to introduce a CI/CD process. So that it's going to be in control of the credential. So the idea is that you don't run plan, you just push to your branch and it could run it, or it only happens on pull requests. That's up to your team and how they decide to set it up. When a branch is ready to be incorporated on pull requests, an execution plan can be generated. I guess when we say execution plan, this could be a speculative plan, okay? So it's not something we're going to run, it's just something we're going to review and displayed within the pull request for review. To apply the changes, the merges need to be approved and merged, which will kick off a code build server that will run Terraform apply. That's the apply stage there. So this is all good, but what we need to kind of highlight is all the work and labor that goes into setting up your own team if you're going to do it all from scratch without Terraform Cloud. So the DevOps team has to set up and maintain their own CI/CD pipeline. They have to figure out how to store the state files, whether they're going to be in a standard backend remote state, or they're going to encrypt it and put them into the code repository, which is not recommended. They are limited in their access controls, so they can't do granular actions to say, okay, I only want to allow this person to destroy and this person to apply. It's not like that with Git repos. They have to figure out a way to safely store and inject secrets into their build server's runtime. And that's not it's not very hard depending on the solution that you choose, but it is a thing that they have to figure out. They might need to manage multiple environments, and this can create additional overhead because for each environment, you'll have to create another CI/CD pipeline, okay? So hopefully that gives you the idea of the effort here, and this is going to set us up to say what Terraform Cloud is going to solve, okay? Let's take a look at what our team workflow or our Terraform workflow will be if we were using Terraform Cloud. So a team will use Terraform Cloud as a remote backend. Of course, they're using their favorite editor as per usual, working on their local machines to write that code. The input variables will be stored on Terraform Cloud instead of their local machine. Terraform Cloud integrates with your version control system, such as Git, to quickly set up a CI/CD pipeline. A team member writes code to a branch and commits per usual, so that doesn't change. A pull request is created by a team member, and Terraform Cloud will generate the speculative or execution plan, however you want to call it, for review in your version control system. The member can also review and comment on the plan in Terraform Cloud. After the pull request is merged, Terraform Cloud in the Terraform Cloud runtime, the Terraform Cloud runtime will perform a Terraform apply, and a team member can confirm and apply the changes within the Terraform Cloud UI. Okay, so Terraform Cloud streamlines a lot of the CI/CD effort, storing and securing sensitive credentials, and makes it easier to go back and audit the history of multiple runs. So in terms of the exam, and I didn't see any questions on this, but I know they exist, they're just going to be asking you, which, they might describe something and say, which kind of workflow does this fit? And so if you generally know the difference between Terraform Cloud, working with a team open source software without Terraform Cloud, and an individual workflow, it's not too hard. You'll be okay, all right? All right, we're taking a look here at backends, and each Terraform configuration can specify a backend which defines where and how operations are performed and where state snapshots are stored. So Terraform divides their backends into two types. We have standard and enhanced. First, looking at standard, this is where you can only store the state. And it does not perform Terraform operations such as Terraform apply. So to perform operations, you have to use a CLI on your local machine. And the reason why is that standard backends are basically third-party backends. So a standard backend could be AWS S3. And so, this is a stored service. It doesn't have the capabilities of pragmatically triggering things, okay? When we're talking about enhanced backends, we can store both the state and perform Terraform operations. So enhanced backends are subdivided further. So we have local, so files and data are stored on the local machine, executing Terraform commands, and remote, so files and data are stored in the cloud, so Terraform Cloud. The reason why they can perform Terraform operations, and when you look at local and remote, local is your machine, so of course it can execute Terraform, and then remote is Terraform Cloud, which has its own runtime environment. It's basically a build server, so it, of course, can do both those operations. And that's how you're going to remember the difference between those two, okay? All right, so we were just talking about standard and enhanced backends, and I was saying that standard backends are basically third-party providers, so it's something other than Terraform Cloud. So let's take a look at what options we have available to us, starting with the major cloud service providers. So AWS has simple storage, S3. Azure has block storage account. Notice it says Azure RM because that's just the name of what they call it. I don't know what the RM stands for. Resource Manager, I imagine. Google Cloud Storage is an option. Then we have Alibaba, we have OpenStack, we have Tencent, and then we have Manta, which is part of Joynet's cloud storage. So I don't think a lot of people are going to remember Joynet. Joynet was a very popular provider like post or pre-2010. So I remember them. Tencent is a Asia provider. I think they were a texting service. They're very popular, but they're not the largest provider over in Asia. Alibaba is. And of course, we have the three major ones here. And then OpenStack is for private cloud, okay? Then on the other side of it, when we're looking at more exotic or things that aren't cloud service providers, we have Artifactory, we have HashiCorp Consul, etcd, Postgres database, Kubernetes secrets, and you can also use the HTTP protocol. Now notice I have these little locks here. That's indicating which have state locking, which do not. If you don't know what state locking is, don't worry. We'll talk about it here in a moment. Would there be a question on the exam saying, oh, which service, doesn't have state locking? And the answer is no, they would never ask that. It's too minute. But just notice that the only thing that doesn't have state locking is Artifactory, which I'm kind of surprised because it's a universal repository manager. And there's the one case like with HTTP protocol where it's optional. So it's not that you can't have it. It's just that it's not, it doesn't necessarily have to be there. And in particular, the state is, or the state locking is by another service. So for AWS, it's DynamoDB that is doing the state locking. And then with Alibaba's cloud storage, it's table store. Okay, so there's not much to know here, but it's just kind of interesting. If you want to have a different kind of backend, maybe you want to use Postgres because you're really familiar with it, you can actually store it there. Okay, so let's take a look at what it would look like if we were to use a standard backend. So here's an example for AWS, since I think S3 is very popular. So if you were to set up your backend, so here I have a bucket here, and I have to name the state file, so I call it state file, and then I give it the region, and there it is. So the backup of a state file will reside on your local machine, so the backup's not going to be in S3. Configuring a standard backend does not require Terraform Cloud account or Workspace because it's totally separate from it. So that's something I wasn't sure when I was first using it was, okay, can I use a standard backend, but I still have to have a Terraform account or Workspace? And the answer is no. All right. All right, so we're taking a look at enhanced backend. So we're going to start with local and then move on to remote. So for the local backend, we store the state on the local file system, and it locks the state using the system's API. It also performs operations locally. And when we say local, we just mean a local machine. We don't necessarily mean it has to be our workstation. A code build server can also be considered a local machine. Okay, it just means anything but Terraform Cloud that is running the Terraform code. So by default, you are using the backend state when you have not specified any kind of backend. So normally you'd see a background defined in here, and we don't. So it's going to just default to the local. You can specify the backend with an argument local. Most people don't. We just leave it blank. And you can change the path to the local file and working directory. So I think that if you were to specify, you'd want to put the path in, but generally, again, we keep that blank. You can set a backend to reference another state file, so you can read its outputted values. This is a way of cross-referencing stacks. So just notice that we have this thing that says Terraform remote state. We're going to repeat this later on in the course because this is a very important concept, and I feel that it gets overlooked in the documentation. But it has to do with local backends. So the idea is that you could say, hey, I have this other file that has a backend, and I'm just going to use data sources, specify its backend, and then point to its actual Terraform state file, okay? All right, we're taking a look here at remote backends for the enhanced backend type, and a remote backend uses the Terraform platform, which is either Terraform Cloud or Terraform Enterprise. By default, I usually just say Terraform Cloud when I'm referring to the Terraform platform, but just to understand, there is a distinction between Terraform Cloud and Terraform Enterprise, Enterprise being the on-premise offering, okay? So with a remote backend, when Terraform apply is performed via the CLI, the Terraform Cloud run environment is responsible for executing the operation. So that's what you get when you get Terraform Cloud. You get this run environment. So it's basically just a built-in code build server to run Terraform commands for you. One thing I really want you to know about remote backends, because this really tripped me up when I was actually trying to make the follow along, which is the fact that because the Terraform Cloud run environment is the one executing the command, your provider credentials need to be configured in the environment variables in Terraform Cloud. So, if you had a project and you configured it with TF-vars locally, and then you were to swap out your remote backend, it's not going to work the way you expect it to because, again, the Terraform Cloud run environment is not going to take your credentials and then move them to the cloud, okay? You have to do that yourself. When using a remote backend, you need to set a Terraform Cloud workspace. So you would go ahead and go to Terraform Cloud and just go create one. You create one or multiple ones for a single project. If you use a single workspace for a project, you're just going to use the workspaces name. And if you set multiple workspaces via prefix, you can use a prefix, okay? And the way this prefix works is that you're going to say like my app or something, and when you go to run Terraform apply, what it's going to do is prompt you to say which environment do you want to use. So, and this is what you've created in your Terraform Cloud workspace. You've created one called dev, you created one called prod, and saying which workspace do you want to deploy to. I want you to know that you can only set either name or prefix. You can't set both, okay? So just understand that. All right, so we're taking a look at the cloud backend code block here. And so this is very similar to Terraform backend remote. If we were specifying Terraform as our backend, but now instead of having to do backend remote, we can just give it a cloud block. And the reason for this is, well, I don't know. You can still All right, let's take a look at the cloud backend block. So when using Terraform Cloud as a remote backend state, you should instead use the cloud block to configure its usage. So previously, in previous Terraform versions, it would look like this. So you'd have Terraform backend remote, and the way you'd know it'd be using Terraform Cloud is that the hostname would be set as app.terraform.io. And so this has been changed. So now that all you have to do is use this cloud block, and so you just don't specify that hostname. And for the most part, the configurations between them are very similar. So the only thing that we're seeing different is this prefix. Maybe that prefix is still there. We'd have to double check the documentation on that. But what's important to understand is that there's this cloud block, and it is the recommended way to do it. Now, I do want to point out that I tested both, and the remote version still works. So you can still do it this way if you're doing it the old school way. And this is just an alternate way. Would they ever make it so you could not use the remote state in the future for Terraform Cloud and you'd have to use the block? I don't know, but I can tell you right now that they do have that cloud block. So both are valid options, and the latter, of course, being the recommended use one. So yeah, there you go. So since we're talking about backends, let's talk about backend initialization, and in particular, the backend -config flag. This is more of an exotic option, but I figured we should go over it because it could appear on your exam. So the flag for the backend config flag for Terraform init can be used for partial backend configuration. So in situations where the backend settings are dynamic or sensitive, so they cannot be statically specified in your configuration file, this is what you would do. So here would be your main.tf, and notice it says backend remote, and it has no details in it. So then what you do is you create a separate file called backend.hcl, and now you're specifying the workspace, the host name, the organization, and then with Terraform init, you're going to then say, okay, use this file as the backend information that we're going to inject into our backend remote. So there you go. Okay, we're taking a look here at Terraform Remote State, and I give this a lot more attention in the course because I feel that it gets overlooked within the Terraform documentation. It's such a powerful feature, and it's something that I'm used to having in CloudFormation, which is cross-referencing stacks, so I want to make sure that you know it too. So Terraform Remote State data source retrieves the root module output values from another Terraform configuration file using the latest state snapshot from the remote backend. So the idea is that you can reference a state file from somewhere else. You can do it via a remote backend and a local backend. So just take a look here. we see data, and the data source is Terraform remote state, and we're setting the backend as remote. On the right-hand side here, it is local. And if it's a local backend, we give the path to the TF state file. If it's remote, that means it's another workspace in Terraform Cloud. So we set the workspace that we want to access. And then when we want to access those resources, we're using data sources. So we do data dot, and then it's Terraform remote state, and then we specify it. Notice that it's no difference whether it's remote or local, but you're going to be getting data from outputs, okay? So only the root level output values from the remote state snapshots are exposed. Resource data and output values from nested modules are not accessible. To make module outputs values accessible as a root module output values, you must explicitly configure a pass-through in the root module. So here's just an example of us doing a pass-through. So we have a module called app, and it has a source, and then we're just setting an output. Notice that we are just grabbing the value and passing it along. I want to tell you about the alternative to Terraform remote state, because if you can, you should use these as opposed to using Terraform remote state. So Terraform remote state only exposes output values. Its users must have access to the entire state snapshot, which often includes some sensitive information. It's recommended explicitly. It's recommended explicitly publishing data for external consumption to a separate location instead of accessing it via a remote state. So what would be alternatives? Well, you've seen this because when we looked at data sources, we were using alternatives. But the idea is that you are going to say AWS S3 bucket, AWS Route 53 zones, and these are kind of already set up to work with AWS or whichever provider, okay? So that's that there. But, hopefully that's pretty clear. So the idea is that when you can, use these data sources because, they're actually working off of live data, right? Like it's hitting a resource. It's not just looking at a state file that contains data, okay? So we had mentioned state locking just briefly when we were looking at standard backends, but let's go take a look in detail what these are because they're very important for your workflows. So Terraform will lock your state for all operations that could write state. This prevents others from acquiring the lock and potentially corrupting your state. So state locking happens automatically on all operations that could write state. You won't see any message that it's happening if the state locking fails, all right? So Terraform does not output when a lock is complete. However, if acquiring the lock is taking longer than expected, Terraform will output a status message. So neither on failure and neither when it is complete, just if it takes too long. So there's a transient issue, something with like a networking issue. You can disable lock. So what you do is use the -lock flag, but it's generally not recommended. You can force an unlock. There's cases where it just does not unlock. And so what you'll have to do is use the force unlock command. If you unlock the state when someone else is holding the lock, it could cause multiple writers. Force unlock should only be used to unlock your own lock in the situation where automatic unlock failed. To protect you, the force unlock command requires a unique lock ID. So Terraform will output this lock ID if unlocking fails. So this is what it would look like. So you have Terraform, force unlock, and then whatever the ID is, -force. So yeah, there's a lot going on here, but yeah, that's what it is. All right, so let's talk about protecting sensitive data. So Terraform state file can contain sensitive data, so long-lived AWS credentials, and is possible attack vector for malicious actors. And so when you're dealing with the local state, when you're using local backend, the state is stored in plain text JSON files. You need to be careful you do not share the state file with anyone. You need to be careful you do not commit this file to your Git repository. When you're using a remote state with Terraform Cloud, the idea here is the state file is held in memory and is not persisted to disk. The state file is encrypted at rest. The state file is encrypted in transit. With Terraform Enterprise, you have detailed audit logging for tampering evidence to take it one step further. So you can just see that there's a lot of work that has to be done when you are using it locally. But with Terraform Cloud, this is kind of the sell for Terraform Cloud, is that it's just going to do everything possible to make that secure. Would it be secure to use a remote state with a third-party storage? Let's talk about that. So you can store state with various third-party backends, but you need to be careful to review your backend's capabilities to determine if you meet your security and compliance requirements. Some backends are not by default as secure as they could be. So for example, AWS S3, you have to ensure encryption and versioning is turned on, and you need to create a custom trail for data events so you can get tamper evidence logging if you turn on data events for custom cloud trail events. But one thing that if it's important to you is that, if you use S3, it's not held in memory. That'd be using a cloud HSM or KMS. So, you have to just understand there are some trade-offs, okay? Let's take a quick look here at Terraform ignore files. And if you know what git ignore files, it's pretty much the same thing. So when executing a remote plan or apply in a CLI-driven run, an archive of your configuration directory is uploaded to Terraform Cloud. And so you could define paths to ignore from upload via the .terraform ignore file at the root of your configuration directory. If this file is not present, the archive will exclude the following by default. So .git, .terraform, and .terraform ignore works just like a .git ignore, with the only difference is that you cannot have multiple .terraform ignore files in subdirectories. Only the file in the root directory will be read. So there you go. And yes, I know there's a double the, okay? So don't worry about that. All right, let's talk about resources. So resources in configuration files represent infrastructure objects such as virtual machines, databases, virtual network components, and storage. And so it pretty much looks like this. A resource type determines the kind of infrastructure object it is. So here it says AWS instance, and this would represent an AWS EC2 instance. This is all defined within the providers documentation. So you have to kind of look at what name they use to figure out what it is. And even though you don't see provider explicitly set here, a resource does belong to a provider, and you can explicitly set it, and you would do this when you'd want to set a resource outside the default provider that you have in your configuration file. And so one little thing that I hadn't mentioned anywhere else, and that's why I made this slide, was to mention about special timeout nested blocks within resources. So some resource types provide a special timeout nested block argument that allows you to customize how long certain operations are allowed to take before being considered to have failed. Okay, so there you go. Let's talk about complex types. So a complex type is a type that groups multiple values into a single value, and complex types are represented by type constructors, but several of them have shorthand keyword versions, okay? So there are two categories of complex types. We have collection types for grouping similar values, so list, map, set, and structural types for grouping potentially dissimilar values, so tuple and object. And now that we have an overview, let's go jump into collection types and structural types. A collection type allows multiple values of one other type to be grouped together as a single value, and the type of value within a collection is called its element type. The three kinds of collection types are list, map, and set. And so looking at our first one here, what we're doing is we are setting ourselves something that looks kind of like an array, and it's this list type here. And what we can do is use our index, so the indices 0, to reference the first element, which is Mars. So that's going to make our username Mars. For a map, it's very similar to a Ruby hash or a single nested JSON object. And the idea here is that it's very similar to the first, except now we're doing a key and value, and then we access it based on the key name. So plan B is going to return 50 USD, okay? We have set. It is similar to a list, but has no secondary index or preserved ordering. All values must be of the same type and will be cast to match the first element, okay? So it's a great way to kind of have, well, I guess no secondary index, but yeah, so you do toSet, and then it would turn into this, okay? All right, let's take a look here at structural type. So a structural type allows multiple values of several distinct types to be grouped together with a single value. Structural types require a schema as an argument to specify which types are allowed for which elements. So this is what they're talking about when they say this schema. So when you actually define the variable, notice where it says object, and you are actually setting A is going to be a string and B is going to be a string. There's this optional option, which I think is right now in beta, but hopefully by the time this course is out or it's the future, you have that option there, but just assume that they're all required. So that's what they're talking about, is that you are specifying exactly what you expect the schema to be, okay? So there are two kinds of structural types. We have objects and tuples, and they're going to look very familiar to maps and lists because they're pretty much the same, but with explicit typing. So object is a map with more explicit keying. So this example, we'd have name for string, age for number, and so that's what it would expect the data structure to be. For tuple, multiple return types with a parameter, so we can have string, number, or Boolean. So this is where we'd have A as a string, 15, or true as a Boolean. So, there you go. Hey, this is Andrew Brown from ExamPro, and we're going to look at the collection and structural types. So I have a new folder down below, just in case we need to define some things. So I'm going to go here and just call this main.tf. And we are just going to configure this for local Terraform. So we'll just give the brackets there. And so the idea is that we might have different kinds of variables. And we had done this previously where we created a list and a map, but we can do that again. So we'll have like planet, right? So that's list. And then we just default that to a value, Mars, Earth, Moon. And then we could also have, plans here, and that would be our map type. Okay, and so here we'll just set it with the curlies. Plan A. Plan B. Plan C. So we'll do Terraform Consul, and so that should load these variables for us to use. And so if I do var.plans, I get that. And if I do var.planets, didn't like what I did there. Input variable has not been declared. I suppose it's just planet there, so I should have named that planets up here. And so what we're going to do here is just go ahead and exit. Type clear. I'm just going to expand this a bit bigger so we're taking over more of the screen. And let's take a look at structural types. So these require you to actually define parameters. So what I'm going to do is go down below and we're going to do the object. And object is very similar to the map. So we'll just go down here. Plans object. And so here what we do is we'd say type object. And we would just have to define some settings here. So we could say A is a string. All right, we'll see if that works. The default value is not compatible with the variable type constraint attribute A is required. So that's fine. What we could do is just define this as like plan A, plan B, plan C. And now if we just do var plans object. When you are using this, you might want to specify some different kinds here. So you could just say like plan here. So we say plan name, plan amount, maybe it's like number. And so then we'd say plan name, plan amount, basic, and maybe this would be 10. Okay, and we'll just type exit here and go back into Terraform Cloud. Hopefully we don't get an error here. So the plan amount is required. So, we can't have a spelling mistake here. Just do var plan here. Well, we named it correctly there. And when we went up here and specified it, I think we got it right. Plan object. So
Sure what it doesn't like here. Oh, you know what? We're not in Terraform Cloud. Okay, that's fair. And we're still spelling this wrong. Whoops. Okay, so there we go. We get our basic plan. And then we can do a tuple here. So I don't know if I've ever defined a tuple before, so let's just try it here. And so we'll just say groceries or value or random. Type equals tuple. I'm just looking up if there's any kind of definition I can find here. I'm not really finding anything, but I'm just going to go define this here because I thought maybe it needed like a schema or something, but maybe it doesn't. So we'll just say hello 22 false. Okay. Terraform Consul. Tuple constructor requires one argument specifying the element types as a list. Okay, so if that's the case, then what we could do is say string, number, Boolean. The type constructor requires one argument specifying the number of elements. So clearly I'm doing this wrong, so just give me a second, I'll be back in a moment, okay? All right, so I think the problem here was just that I need to make brackets here like this. We'll give that a go. Boolean is not a valid option. What if we try bool? Okay, we say var.random. Good, and so I'll just go ahead and exit that out. I'm just going to see what happens if I change the order here. So let's say I do, instead of 22 here, we go here. Okay, and so notice that, you know, we can have all sorts of kinds, but they have to match exactly the order that is there. So yeah, that's pretty much it. So there you go. The Terraform language includes a number of built-in functions that you can call from within expressions to transform your combined values. So we have numeric, string, collection, encoding, file system, date and time, hash and crypto, IP network, type conversions. So we are going to go through all of these. We might not go through every single function, but we'll go through every single major category. In terms of the exam, the only thing that's going to show up might be string functions. Why they do this, I don't know. It's not a very good exam question, but those might appear. But I think that this is one of the strongest features of Terraform over something like CloudFormation. And I really want to just show you the gambit of them, okay? Let's take a look here at numeric functions, starting with absolute. So returns the absolute value of a given number. So 23 is 23, 0 is 0. And if you get a negative number, it's going to flip to the positive. For floor, what it does is it rounds down to the nearest whole number. So see where it says 4.9, it becomes a 4. You have log, so returns the logarithmic, I can't say that word, logarithm of a given number in a given base. So log 50, 10 is going to give you that. 16, 2 is going to give you 4, okay? Seal, it's where it will always round up. So see where it says 5.1, and it goes all the way to 6. We have min, so take one or more numbers and return the smallest number from the set. And max, take one or more numbers and return the greatest number of the set. I don't have examples because that's pretty straightforward. You know, if there's a 2 and a 4, it's going to return the 2 in min. If it's a 2 and a 4, it's going to return the 4 for max. We have parse int, so parses the given string as a representation of an integer in the specified base and returns the resulting number. So if we have 100 here in strings, it's going to, and we say comma 10, we're going to get 100 because that's the base system. It's base system 10. Base system 16, we can see letters in there, right? So it's able to translate that. This is 2, so that's basically binary, so zeros and ones. So you get the idea there. POW, so calculates an exponent by raising its first argument to the power of the second argument. So that's just a way of doing powers. And then we have signum, so determine the sign of a number, returning a number between -1 and 1 to represent the sign. So there you go. All All right, let's take a look here at string functions, the first being chop. So removes new line characters at the end of a string. So, if there's a -n, or sorry, \n, you don't want to see that there. That's the way you get rid of it. Then you have format, so produces a string by formatting a number of other values according to the specification. So here there are %d light, so this is representing a digit. So it's taking that number. This says it's going to be formatted as a string, okay? Format list, so produce a list of strings by formatting a number of other values according to a specification string. So here we have an array, and then we have our specification. So you can see it's substituting the name there. We'll look at indent, so adds a given number of spaces to the beginnings of all but the first line in a given multi-string. So here we have a string, and what it's going to do is, see, we have the interpolation here, and then we have indent. I know the highlighting is not great because it's a single string, but we have interpolation. We have parentheses 2, so give it a layer of 2 indentation. And then it's going to break that up and give it indentation. So we have join, so produce a string by concatenating together all elements of a given list of strings with the given delimiter. So you use delimiter is a comma, and so it's going to glue that together to make this, okay? If there's only a single one, there just won't be any comma in there. We can lower all the text. That's pretty straightforward. We have regular expressions, so that is an extremely powerful feature. So here we have the regex. I don't know what the regex format is. Maybe it's Perl. I'm not sure. There's like a bunch of different types of regex standards. So, you have to figure that out so you know how to use it. And then there's a regex all, so applies to a regular expression to a string and returns a list of matches where this just is returning 1, okay? We have replace, so searches a given string for another given substring and replaces each occurrence within a given replacement string. This is just like the JavaScript replace. We have split. This is the opposite of join. So if we want to split on the comma, we specify comma here. We have str, rev, so string reverse. So reverses a string. So hello becomes ole. We have sub olel. Sure, I don't know. So substring, so extracts a substring from a given string by offset and length. So we have a substring, and we're saying we want 1 to 4, so we only want 1, 2, 3, 4 here, okay? Because it starts at 0. We have title, so make it title case, so capitalize the H and the W. We have trim, removes the specified character from the start and end of the string, so we don't want these, and we tell it to remove those. There's a lot of string functions. So we have trim prefix, so removes the specified prefix from the start of the given string. If the string does not start with the prefix, the string is returned and unchanged. So here we say we want to get rid of hello in the front, so we do that. Suffix is the opposite, so we want to get rid of world out of the suffix, so we do that. We have trim space, so removes all types of white space from both the start and end of the line, so it gets rid of the new lines and the spaces. Upper is going to put everything to upper, and there you go. On the exam, they probably will ask you like what string function does or which one does not do something. So this is the only part of the built-in functions you have to know for the exam. I don't think it's a very good exam question, but it does appear there, so you need to know it, okay? We're on to collection functions, and these are the most powerful built-in functions, and there's a lot of them. And I made sure to give you an example for each one because I really do want you to know these, because this is the power of Terraform. The first on our list here is all true, so returns true if all elements in a given collection are true, or it also returns true if the collection is empty. So it's either true, true, right? Or we have true, false. So because there's a false, it's not going to be true. So any true is very similar, but there only has to be one that is true. So if this is true and there's a false, it's going to be true. If it's blank, it's going to be false, okay? We have chunk list, splits a string list into fixed size chunks, returning a list of lists. So here we're telling it to chunk it every 2, so grab every 2 and make them into their own little array or list, I suppose. We have coalesce, takes any number of arguments, returns the first one that isn't null or empty string. If you're used to Postgres, you use this all the time. But the idea is it's going to grab the A. In this case, it'll grab the B because that's blank. In this case, it'll grab the 1 because that's the first value. We have coalesce list, takes any number of list arguments and returns the first one that isn't empty. So very similar, it's just using lists, or if we want to call them arrays. So the first one is available, so it takes that one. We have compact, so it takes a list of strings and returns a new list with an empty string, elements removed. So it's just going to get rid of that space there, and we'll get ABC. We have concat, so it takes two or more lists and combines them into a single list, so that's very convenient. We have contain, so it determines whether a given list or set contains a given single value as one of its elements. So does it have an A? Yes, it does. Does it have a D? No, it does not. We have distinct, so it takes a list and returns a new list with any duplicate elements removed. So we just want to make sure we only have one of each. So do we have any duplicates here? We have two A's and two B's. So we're going to end up with just a single list, so only exactly one of each letter. We have element retrieves a single element from a list. So get me the element at 3 here. So retrieves a single element from a list. Okay, well, that's what it does. You give it a 3 and it gives you an A. I don't know why it's not clicking for me, but I'm not following through here. Index finds the element index for a given value in a list. So we say, where is B? And the index of B is 1, because it'd be 0, and this would be 1. Still really confused about this one. Flatten takes a list and replaces any elements that are lists with a flattened sequence of list content. So basically it says, give me a bunch of arrays or lists, turn it into one flat list. Keys, take a map and return a list containing the keys from the map. So we just want the keys A, C, and D. We want length. This is pretty straightforward. So what's the length of this? 0. This is 2. This is 1 because it's a one map or one thing, key value in there. And if it's a string, it's going to count the characters. So there's 5 characters. We have lookup. So retrieves the value of a single element from a map given its key. If the given key does not exist, the given default value is returned instead. So we say lookup A, and what we get is a Y, right? Lookup C, and it could not find C, so by default, give us what instead? Match keys. Construct a new list by taking a subset of elements from one list whose indexes match the corresponding indexes of values in another list. That sounds complicated. Let's read that one more time. So constructs a new list by taking a subset of elements from one list whose indexes match the corresponding index of values in another list. That is confusing. So we have one list and another one. So we have this one here, and we have US West, US East, US East. So we say, okay, we have US East. So the elements here is 2 and 3. So give us 2 and 3. So that's what it does. That was a tricky one. I can't think of what you use that for, but that's an interesting function. Merge takes an arbitrary number of maps or objects and returns a single map or object that contains a merged set of elements from all arguments. So it just merges them together. So it's just like concat, or I suppose like flatten. 1 takes a list set or tuple values from with either 0 or 1 element. If the collection is empty, 1 returns null. Otherwise, 1 returns the first element. If there are 2 or more elements, then one will return an error. So it returns null in an empty list. It returns the first one, and then here it says invalid function. So it's just saying, is there 1, right? Is it 1 or 0? Ranges generates a list of numbers using a start value, a limit value, and a step value. So we say 3, and we get 0, 1, and 2. Generates a list of numbers using a start value, limit value, and a step value. Okay. Reverse. So takes a sequence and produces, reserve. Reserve takes a sequence and produces a number, a new sequence of the same length with all the same elements as the given sequence, but in reverse order. Oh, it is reverse. reverse. I guess I spelt it wrong here. Sorry. Reverse. 1, 2, 3, 3, 2, 1. Just notice this is a spelling mistake, okay? Set intersection. So function takes multiple sets and produces a single set containing only the elements that all of the given sets have in common. In other words, it computes the intersection of the sets. Well, that's tiring. So from what I can tell, it's like they all have B, so give us B, right? Set product. Functions find all of the possible combinations of elements from all of the given sets by computing the Cartesian product. We're really getting into math here. So we got app 1 and app 2. And so we get development. Okay, so this continues on. So it's going to say, give me app 1 with development, give me app 2 with development, then app 1 with staging, and then app 2 with staging, and et cetera, because that's why I put the 3 dots there. Set subtract function returns a new set containing the elements from the first set that are not present in the second set. In other words, it computes the relative complement of the first set in the second set. It lost me there, but it says set subtract. So here I see A, B, and C. A and C minus it, you get B. Okay. Set union function takes multiple sets and produces a single set containing the elements from all the given sets. In other words, it computes the union of the sets. So it says set union. So we have A, B, B, C, and D. And in the results, we get D, B, C, A. So I guess single set containing the elements from all the given. So yeah, I guess it's just we get unique ones across the sets. We have slice, and notice like we're going through all these things. It's like you probably won't use these more exotic ones, so it's not a big deal if we don't nail them here. But it's important that we go through these so that you just know all the options are here. So slice extracts some constructive consecutive elements from within a list. So here we are saying 1 and 3. So we have B and C. That's where they start. Index 1. And then extract some consecutive elements from within a list, 1, 3. Okay. Sort takes a list of strings and returns a new list with those strings sorted lexicographically. So we have E, D, A, and X, and so now they're alphabetical. So A, D, E, and X. Well, I think this is the last one. Sum takes a list of set numbers and returns the sum of those values. That's pretty straightforward. Add them all up. Transpose, take a map of list of strings and swap the key and values to produce a new map list of strings. So kind of like inverts it. Values takes a map and returns a list containing the values of the map. So we saw this earlier. We got the keys. This is where we just want to get the values. Zip map. So construct a map from a list of keys and a corresponding list of values. So we have A, B, 1, 2, and this turns it into A equal 1, B equals 2. I think I saw this on the exam. So that one you might want to remember. But yeah, that's collection functions. As you can imagine, they're extremely powerful, but they can also be really confusing. So maybe just use them a little bit when you need to, okay? We're taking a look here at encoding and decoding functions. So functions that will encode and decode for various formats. So imagine we need to encode into base 64, so we do hello world, or imagine we give that encoded string and we want to decode it back to hello world. That's what we can do. So there's a lot of different encoding, decoding functions. Most of them are the same. They're just kind of variants. So we're not going to go through every single one, but I'll list them out so you know what they are. So we have base 64 encode, JSON encode, text encode base 64, YAML encode, base 64 gzip, URL encode, base 64 decode, CSV decode, JSON decode, text decode, base 64, YAML decode. And just notice that, these aren't one-to-one. So there is one for this. We have one for here. We have one for YAML. This is unique. This is unique. This is unique. Okay, just so you can tell. For URL encode, I think this one's a very common one that you'll use, but the idea is that, let's say you have hello world, you want to replace that string with a whatever friendly for a URL, right? So it just encodes it, okay? It's very useful when you're making URL links. So there you go. We're taking a look here at file system functions. So this has everything to do with the file system. So the first is absolute path. So the idea is you give it something that's relative and it's going to give you something absolute. Directory name. So this is a string containing a file system path and removes the last portion from it. So we don't need the file name, so we just remove that off of there. We have path expand. So it takes a file system path that might begin with a tilde and expands it into its absolute path. So this would be like for home, okay? Base name. So it takes a string containing a file system path, and it's basically the opposite of directory name. We just want the file here, okay? On to the next page here. This file will read the contents of the file. Pretty straightforward. We can check if a file exists. So we just do file exists here. We have file set. So it enumerates a set of regular file names given a path and pattern. File base 64. So it reads the contents of a file at a given path and returns the base 64 encoding. That might be good for images. Template file, so reads the file at a given path and returns its content as a template using a supplied set of template variables. So that's really useful if you want to do some kind of templating. And just notice it's a two-step process. So this is the template file, the actual file itself, and then we load it here, and it's called a .tpl. So there you go. We're taking a look at date and time functions. The first is format date. So the idea is that we provide a format that we want, and then we give it a timestamp that is in the RFC 3339 format, and we get a variety of different formats out there. We can add time. So again, it's going to be that RFC 3339 format, and we say add 10 minutes, add 1 hour. Then we have timestamp, so it returns a UTC timestamp string in the RFC 3339 format. So you just say timestamp, I guess it would get right now, and then you get it in that format, okay? Let's take a look at hash and crypto functions. So it generates hashes and cryptographic strings. So the most popular one out there would probably be bcrypt. So here we just say hello world, and we're going to get this thing here. Understand that a hash cannot be reversed. So once it is turned into this format, the only way you're going to be able to confirm the contents of it is to hash something that is similar and then compare it against it, okay? So we have base64 SHA-256, we have 512, we got bcrypt, we have file-base64 SHA-256, file-base64 SHA-512, file MD5, file SHA-1, file SHA-256, file SHA-512, MD5, RSA decrypt, SHA-1, SHA-256, SHA-512, UUID, UID v5. So I only showed the one because, it gets kind of boring to go through all these, and really it's just going to be based on your use case. What you're going to be using on a day-to-day basis is probably bcrypt, MD5, and UUIDs. So there you go. Let's take a look at IP network functions. These are the coolest functions, I think, that are built into Terraform. So we have CIDR host. So what we can do is give ourselves a address, and then we can give it a subnet mask size, and we'll get back an IP address. And so you can see we have this both in the IPv4 and the IPv6. We have CIDR net mask. So here we are doing CIDR net mask. So we just say /12, and it's going to translate it into the full IPv4. Then we have CIDR subnet. So this is just where we say, okay, I want a subnet of a particular size. So we say 172.16.0.0, and look, it's going to give us 18.0 back. If this doesn't make sense, that's okay. I mean, networking is really hard, but I just want you to know that these functions are here for you, okay? CIDR subnet calculates a sequence of consecutive IP addresses within a particular CIDR prefix. So 4484, and then you get those sizes there, okay? All right, we're on to type conversion functions. So the first we're looking at is can. So can evaluates the given expression and returns a Boolean value indicating whether the expression produced a result without any error. So can we use this, right? So we say local.foo.bar. And so, if this foo wasn't defined, then it would say false, but apparently we made it all the way to bar, okay? We have defaults, a specialized function intended for use with input variables whose type constraints are object types or collection of object types that include optional attributes. And I don't show that one here because it's not that exciting, but non-sensitive takes a sensitive value and returns a copy of that value with the sensitive markings removed, therefore exposing the sensitive value. So if we have an output here and we want to make it non-sensitive, that's what we could do. Then sensitive, as you imagine, is just the opposite, okay? We have toBool, so converts its arguments to a Boolean value. So if we have a string that's true, we can turn it into a real Boolean value. We have toMap, converts an argument to a map value. toSet, converts it to a set. toList, converts it to a list. toNumber, converts it to a number. String to string. And then last we have is try, so evaluates all of its arguments, expressions in turn, and returns the result of the first one that does not produce any errors. The thing that's the hardest to figure out is set. I cannot find really good examples or documentation on the use case of set. There are some cases where you need to use sets, which is an actual type, but even talking to DAs and technical writers, they weren't even sure themselves. So this is not something you're going to come across very often, but there's like one case where I saw it. So I'll probably point that out when we do hit it, okay? Hey, this is Andrew Brown from ExamPro, and we are going to go take a look at built-in functions as soon as my terminal decides to be responsive. I don't know why, as soon as I start recording, it decides to lock up. So we'll just give it a moment there. There we go. And so I have a new folder there. I figured we could just define some variables so that we don't have to, constantly write stuff in. So we'll just say main.tf. We're going to go Terraform here. And so it might be fun to, some kind of variable here. And so I have off screen here all the functions. So we're just going to kind of pick some at random here to play around with so we get some experience, okay? So just going through strings. I think what we can do is define like our string. So we just say str here, and we'll just say type equals string. And we'll just say default here, and we'll just say hello world /n, something like that. Okay. And then we'll do Terraform Consul here. I gotta remember to do it this way. So we do var.str. Okay, and so that accesses our string there. Maybe we might want to take out the new line for now. So I'm just going to kind of pull this up over here. Look at some kind of things we can do. Okay, maybe collapse that, get that out of the way. All right, so there's a lot of string functions, and on the exam they might actually ask you some, which is, in my opinion, I don't really like that, but that's what they do. And so we might want to look at something like split or something. So here we could do hello world. Okay. Start that up again. So we'll do split, comma, var str. Okay, and that would split that into a list. We might want to do something like upper. So I think we did that earlier where we did upper. Okay. Might want to do trim, remove specify characters from the start and end of a string. So maybe we have this here. And so we'll say trim var str. And whoops, that's not what I wanted it to do. Trim var str, like that, okay. And there's not a lot that's exciting here. Maybe we'll try a replace. So we can do replace, and we want to replace, we will provide our string, and then the substring that we're looking for, so world, replace that with Barsoon, which is Mars. There we go. So nothing super exciting over there. What's more interesting are some things like these hash and cryptos. So something we might want to generate out as a UUID. I think that we might be able to do this here. So let's just see what happens if we try to call it like that. Clear. Terraform Cloud. Oops, Terraform Consul. That's what I meant to type. And so functions can't be called in here, which is totally fine. So we'll go back and just set that like that. But I just wanted to show you that. So if we did UUID, we would get that. If we used bcrypt, so I might say bcrypt hello world. Okay. Might be something interesting in the IP network here. So we might want to generate out a CIDR subnet, right? The typing conversions is something that you might come across a bit. So we already saw that when we converted a set to a list and things like that. So maybe we might want to convert something to a Boolean. So we might say to bool true. Okay. These are pretty complicated, the collections. but we might have something that we want to do here. So coalesce might be something that's interesting where we have an array, or a list, I suppose. So we might say like items and make that a list. Null, null, empty, last. Okay. Bar items. So we might say coalesce. Okay. And that didn't look like it pulled anything out of there. To perform coalesce operation with a list of strings, use this symbol. So we could use that to do that. So that just kind of expands the arguments. And so that what happened here is null didn't exist, this didn't exist, so it pulled out last, okay? Maybe we might want to just use keys. Maybe we might just want to use keys here. Okay, so I might say like hello world, goodbye moon. And remember, we can do hash rocket arrow equals or colons, just up to your preference. I just wrote that in for whatever reason. I'm used to using Ruby, and that's what we use as hash rockets. That's the name of the symbol, the equals arrow. Okay, didn't like that, so I guess we do have to do it this way. That's totally fine. I'm not upset by that. I thought it supported all three. Maybe it's like minus equals or something. I don't know. But what we'll do is say var stuff. And then what we can do here is do keys. Okay. And it didn't look like it grabbed the... Oh, yeah, it grabbed the keys. That's fine. Okay, and then we might say values. All right. You know, maybe we might want to try reverse. That one's pretty clear. One, two, three. Okay, so nothing super complicated. I wonder if absolute would work in here, like the file system. So we have absolute path. I don't know if this would produce anything here. Oh, it does. Okay, so we could ABS path. Say path.root. There you go. Okay, so that pretty much gives you a general idea of built-in functions. So there you go. All right, let's take a look here at Terraform Cloud again, but in greater detail. So Terraform Cloud is an application that helps teams use Terraform together. And so there is the UI there. And Terraform Cloud is available as a hosted service on Terraform.io. It's actually at the app.terraform.io once you're logged in. And it has a lot of different features. So it can manage state files, have a history of your previous runs, a history of your previous states, easy and secure variable injection, tagging, run triggers, so chaining workspaces together, specify any version of Terraform per workspace, global state sharing, commenting on runs, notifications via webhooks, email, and Slack, organization and workspace level permissions, policy as code via Sentinel policy sets, MFA, single sign-on, cost estimation, integrations with ServiceNow, Splunk, Kubernetes, and custom run tasks. And that is not the limit to what it does, but this is what I could fit on the slide, okay? Let's take a quick look here at the terminology or anatomy of Terraform Cloud. So we have an organization, and within an organization, we have our workspaces. And a workspace represents a unique environment or stack. Then you have your teams. These are composed of multiple members, and a team can be assigned to multiple workspaces. Then you have runs. A run represents a single run of the Terraform run environment that is operating on an execution plan. Runs can be triggered by like the UI itself, or maybe like a Git repo. It can be API driven or CLI driven. So there you go. So there are three types of Cloud Run workflows. So when you create a workspace, you have to choose a workflow, and you have either version control workflow, we have CLI-driven workflow, or API-driven workflow, okay? So just going over them in greater detail. For the first one, which is that version-controlled workflow, Terraform Cloud is integrated with a specific branch in your VCS, so GitHub's via webhooks. Whenever pull requests are submitted for a branch, speculative plans are generated. Whenever a merge occurs to that branch, then a run is triggered on Terraform Cloud. Then you have API-driven, so workspaces are not directly associated with the version control system repository, and runs are not driven by webhooks on your VCS provider. A third-party tool or system will trigger runs via uploading a configuration file via the Terraform Cloud API. So this configuration file is a bash script that is packaged in an archive, and you're pushing it as a configuration version. So you're basically creating configuration versions every time you do that. Then there's CLI driven, and this is the way we're going to be using mostly in the course. So runs are triggered by the user running Terraform CLI commands. So you'll run Terraform apply or plan locally on your machine. It's going to just work as per usual, okay? Let's take a look at organization level permissions, which manage certain resources or settings across an organization. So the first things that you can set would be something like manage policies. So create, edit, delete the organization's Sentinel policies. Manage policy override. So override soft mandatory policy checks. Manage workspaces. So create, administer all workspaces within an organization. Manage VCS settings. So set of VCS providers and SSH keys available within the organization. And for an organization, we have this concept of organization owners. So every organization has at least one organization owner, and you can have multiple. This is a special role that has every available permission and some actions only available to owners. So this could be publishing private modules, invite users to organizations, manage team memberships, view all secret teams, manage organization permissions, manage all organization settings, manage organization billings, delete organizations, and manage agents. So just understand that there are these special ones just for this organizational owner, and then these are these other ones here that you can set for other types of organizational level permissions, okay? Let's take a look here at workspace level permissions that allows you to manage resources and settings for a specific resource. And we have granular ones, and then we have pre-made permissions. So let's go through the granular permissions first. So these granular permissions you can apply to a user via a custom workspace permissions. And so we have read runs, queue plans, apply runs, lock and unlock workspaces, download Sentinel mocks, read variables, read and write, read state outputs, read state versions, read and write state versions. And so the idea is that what you can do is just go and cherry pick out what you want to assemble your permissions for your user. Now, if you want something a little bit easier to do, you can use fixed permission sets. And these are pre-made permissions for quick assignment, and they're based on the read, plan, and write. So we have read runs, read variables, read state versions. For plans, we have queue plans, read variables, read state versions. We have write, so apply runs, lock and unlock workspaces, download Sentinel mocks, read and write variables, read and write state versions. And then there are workspace admins, and this is kind of like the organizational owners. So a workspace admin is a special role that grants all level of permissions and some workspace admin only permissions. Those admin only permissions would be read and write workspace settings, set or remove workspace permissions of any team, and delete workspaces. So there you go. Let's take a look here at API tokens. So Terraform Cloud supports three types of API tokens: users, teams, and organization tokens. So for organization API tokens, they have permissions across the entire organization. Each organization can have one valid API token at a time. Only organization owners can generate or revoke an organization token. Organization API tokens are designed for creating and configuring workspaces and teams. They're not recommended as all-purpose interfaces to Terraform Cloud. So basically, you just use them when you are setting up your organization for the first time and you want to do it pragmatically, okay? Then you have team API tokens. So this allows access to workspaces that the team has access to without being tied to any specific user. Each team can have one valid API token at a time. Any member of a team could generate or revoke that team's token. When a token is regenerated, the previous token immediately becomes invalid. Designed for performing API operations on the workspaces. Same access level to the workspace the team has to access to. I would imagine this is when you're setting up your own custom CI/CD pipelines or something like that. I'm not really sure exactly the use case for Team API tokens. We have user API tokens, the most flexible token type because they inherit permissions from the user they are associated with. Could be for a real user or a machine user. When you do Terraform login, this is what you're getting, a user API token, okay? All right, so I just wanted to quickly show you this access levels chart that helps you understand what kind of permissions you are giving at the access level. And notice there's implicit and then required or explicit permissions. I'm assuming that this means that you need to assign those permissions to the user first before they'd have it. So just because you have a user token doesn't mean you get all of these orange diamonds. It's just the ones that you've assigned to that user or team, where I believe that the organization, you're going to run into a chance where you're going to have all these permissions by default, whether you want them or not. So just understand that you have to double check this before you use your tokens and that this chart exists, okay? All right, so we covered private registry earlier in the course when we were looking at the Terraform registry, the public one, but let's cover it again with a little bit different information. So Terraform Cloud allows you to publish private modules for your organization within Terraform Cloud private registry, and Terraform Cloud's private module registry helps you share Terraform modules across your organization. It includes support for module versioning, a searchable, filterable list of available modules, a configuration designer, which I didn't find this thing, but it sounds really cool. All users in your organization can view your private module registry. For authentication, you can either use a user token or a team token. So I guess this would be the case where you might want to use a team token for authentication, but the type of token you choose may grant different permissions, as we saw with the access levels just the slide prior. Using Terraform login will obtain a user token, just a reminder. And to use a team token, you'll need to manually set it in your Terraform configuration CLI file, okay? So there's a feature within Terraform Cloud that can do cost estimation, and it is a feature that will give you a monthly cost of resources displayed alongside your runs. This feature is only available starting at the Teams and Governance plan and above, but the idea is that it will tell you for specific resources and then give you a summary. So notice here that we have some pricing. I'm going to get my pen tool out, but we have the overall cost, and then it's broken down per resource. And so you can see we have an hourly, monthly, and monthly delta. I don't know what the monthly delta is, but it gives you kind of an idea of cost. You can use Sentinel policies to assert the expectation that the resources are under a particular cost. So that's just kind of a bonus there where you're like, okay, I want to ensure my spend is this. The only downside, at least at the time right now for cost estimation, is the amount of support it has. So we have AWS, Azure, and GCP. So these are the resources that it will support. And so you have to look through here and say, okay, is there any resources I'm using outside of this that I really care about? So I think that if you're using like core services, so like EC2 instances, load balancers, things like that, that should help you out. So like we see AWS instance, the load balancer, the volume, some CloudWatch logs, ALB. For Google, it's just disk, instance, and database. So yeah, it's just really dependent on, what's here. So, it may meet your needs, or you might say, okay, this is not enough, okay? Here's just a few options that I think are worth noting within the Terraform Cloud workflows. We have a whole section on workflows, but I decided to put it over here just because. But let's talk about it. One thing you can do within Terraform Cloud is set whatever version you want. So you can go as far back as you want. And this is great if you need to mix and match different workspaces because you have different stacks and they were built on different Terraform versions and you're just not ready to upgrade them yet. You can choose to share state globally across your organization for a particular workspace. This could be really useful if you need to reference things wherever. You can choose to auto-approve runs. So if you don't want to always do that manual approve, you can do that. This is great if you're looking for that kind of agile kind of workflow where if something is merged, then it should be rolled out, okay? Let's talk about if we had to migrate our local state and we're using just the default one to Terraform Cloud, how would we do it? So to migrate Terraform projects that only uses the default workspace Terraform Cloud, it's pretty easy. You're going to create a workspace in Terraform Cloud. You're going to replace your Terraform configuration with a remote backend. So if you have nothing, it's using local, and then you just put in your remote state. And then once you have that in there, you do a Terraform init, and it's going to say, hey, do you want to copy the existing state? You're going to type yes. And once you've done that, I believe you have to delete your old state file. If you are migrating multiple environments, or you're moving from a standard remote backend, it's a little bit more complicated. They definitely have guides in the docs, but this is the pretty much standard one that you're going to come across when you're working very early, and we'll definitely see this as we are using Terraform in our follow-alongs, okay? I want to talk about what kind of integrations we have for Terraform for version control systems. So we have GitHub, GitHub Auth, GitHub Enterprise, GitLab, GitLab EE, and CE. I assume that's Enterprise Edition and Community Edition, Bitbucket Cloud, Bitbucket Server and Data Center, Azure DevOps Service, Azure DevOps Server. So it's very simple. You're just going to choose from one of the four, right? And then you're going to just drop down and choose what variant it is there and connect your repo. Every single provider has different configuration settings, so you might have to meet those depending on what they are. You can get from private repos. You might have to add your SSH key or something like that, okay? Let's talk about Terraform Cloud run environment. So when Terraform Cloud executes your Terraform plan, it runs them in its own run environment. So what is a run environment? A run environment is a virtual machine or container intended for the execution of code for a specific runtime environment. A run environment is essentially a code build server. So the Terraform Cloud run environment is a single-use Linux machine running on the x86 or x64 architecture, and the details of its internals implementation is not known. It is possible to install software on it, but the only issue is that we don't know what it is. Is it Debian? Is it Ubuntu? You just can't tell. Terraform Cloud will inject the following environment variables automatically on each runtime. So we have TFC run ID. This is a unique identifier for the current run. The workspace name, the workspace slug. So this is the organization followed by the workspace. Just going to get my pen tool to just kind of point out over here on the right-hand side. We have the configuration version and git branch. So, you know, if it is going to be on main, it's going to tell us that. If it's going to be a particular version, we'll know that as well. We can get the SHA of the current commit. There's that version. And if you want to access these variables, you just define variable and the name, and then you can access it throughout the code, okay? Well, let's take a look here at Terraform Cloud Agents. This is a paid feature of the business plan to allow Terraform Cloud to communicate with isolated private or on-premise infrastructure. It's kind of like an in-between between Terraform Cloud and Terraform Enterprise, where you want to use Terraform Cloud, but you have on-premise infrastructure, but you're not ready to move to Terraform Enterprise. So this is useful for on-premise infrastructure types such as vSphere, Nutanix, and OpenStack. The agent architecture is pull-based, so there are no inbound connectivities required. Any agent you provision will pull Terraform Cloud for work and carry out execution of that work locally. Agents currently only support the x86 architecture or the x64-bit Linux operating system. Okay, so you can also run the agent within Docker using the official Terraform agent Docker container if you just prefer that over a VM. Agent supports Terraform versions 0.12 and above. The system requires, I'm going to change that in the slide later on, but the system requires at least 4 gigabytes of free disk space for temporary local copies and 2 gigabytes of memory. Needs access to make outbound requests. So you need to have open port 443 for app Terraform IO, registry Terraform IO, releases, HashiCorp.com, and archivist.terraform IO. So there you go. Hey, this is Andrew Brown from ExamPro, and we are on to our Terraform Cloud follow-alongs. Now, we already did Terraform Cloud version control system earlier than I thought we were going to do, so I'm going to remove it from the list. And what we'll do is focus on permissions and maybe the API tokens and things like that. So what I want you to do, and I've got some old tabs open here, but I'm going to make my way over to terraform.io, and I'm going to go log into Terraform Cloud here. And I don't think I've ever done this, but I can upgrade to the trial account, because the thing is that when we are in our account here and we're trying to look at permissions, and we're not using force unlocking anymore, I might just keep that around for a little bit. But if we were to go to our user settings here, we go to organizations, that might not be a very good example. I guess I wanted like the organization settings here, which would be maybe here, yeah, up here. And so, when we go to our teams and our users, everyone's being added as an owner. We don't have like granular permissions, and that's because we'd have to upgrade. And so I figured this would be a good opportunity for me to just kind of upgrade to show you those more detailed role-based access control permissions, just so you know where they are. So I'm going to go to the upgrade now, and notice that we're on the free plan. And also take note, because later on in the course I talk about pricing, or we've already crossed it, but notice that we have a team plan and a team and governance plan. This one's at $20 and this one's at $70. So, this is not something that's reflected, at least not right now, on the Terraform website. And so it just looks like there's a team and governance plan for $20 and this middle one's missing. The key difference here is this one has Sentinel policy as code. But you can see on the free plan, we are able to do team-based stuff. But let's go switch over to the trial plan. I'm going to see if I can do this without entering a credit card in. So here it says you're currently on trial plan. I didn't have to enter anything in. That's really great. And so that means now I have all these team management options. So if I go over to team management, I can actually go ahead and create some teams. So I'll just say like developers. Okay. And so now I have all these options. So we can say this person, if someone's in this team, they're allowed to manage policies. They're able to do that. A visible team can be seen by every member, or we can keep them secret. We can generate out team API tokens, which I guess we could just like cover this as we do it. But notice we can go here, and that generates out that token that we can use. I'm going to go ahead and delete that token. So nothing super exciting there. It's not like that complicated. If we want to set things on the workplace, now if we go back to workplace or workspaces here, and now we have team access. And notice I can go to add team permissions here, and we can say select this team for their permissions. And so these are these pre-built ones in. So we have read, plan, write. So these are those 3 predefined ones that we talked about previously. And then we have down here like assign permissions for the admin of a workspace. We are able to set customized permissions. So if we toggle this, we should be able to do it. I mean, this looks like it's the same thing. No, I guess it's more granular. So here, I guess we have our granular permissions that we can set. So for runs, we can do read, plan, or reply, lock or unlock a workspace, send unlocks, things like that. It's not super complicated. If we want to drain out API tokens for, well, there's the organizational one, there's the teams one, and then there's the user one. So if we go to the organization, we can see that we can generate out one here. So I can say create an API token. So there it is. Just go ahead and delete that. And if we go back to our teams, we did this earlier, but we can generate one here. And then if you want to generate one for your user, it's probably under user settings. Yeah, so we generate tokens there as well, okay? So, I mean, again, there's not a lot to talk about here, but yeah, so I guess that really covers permissions and API tokens, okay? Okay, so that finished deploying there, and so we can see our resources have been created. But one thing that we didn't set was the prefix. I'm actually interested to see that that worked properly, but what I could do is say prefix, and then do an underscore here. And I don't know how that would affect it. And this actually happened over in this repository here. I'm actually using a hyphen, so I'm going to just change that to that. Might have to do a Terraform init there, migrate the state. So that was a complete mistake on my part, but I guess my thought was that I thought I had to have, this is still on main, and I guess we never really set up a production branch, but yeah, so now when we have the prefix in, it's actually going to prompt us for the other ones. So the currently selected workspaces are default, does not exist, and so dev is showing up, and notice that we can't deploy to main. So I think the thing is that if we wanted a production one, we would just create that workspace, and then it would reflect here. So the way you make multiple workspaces here would actually have to make them all. So we'd have to make a VCS Terraform prod, and I'm very certain that it would just show up here, and then you would select the number that you'd want. Though what's interesting is the fact that we are in the dev branch, and we have to say, oh, I want to deploy the dev one. So that's kind of a little bit of a caveat there, but I guess there's not really any way around it. But I mean, this pretty much, explores what we need for multiple workspaces with Terraform Cloud, and we did the remote ones, and we're all good. So there we go. I guess the last thing here we should probably do is just clean up. So if we go to Terraform Dev here, we're going to go down to destruction, and we'll run a destroy plan here. Okay. And once this is all done, you can go ahead and just delete these repositories. And notice this one it has a private lock on it. So, because it's actually running right now, so it's being locked. So, yep, there we go. So that's it. All right, now let's take a look at the Terraform registry, the private registry. So just go over here and click on registry at the top. And we can bring in public things here. So I can just go here and type this in, and we can hit add. And so now we just hit add to Terraform Cloud, add to my organization. And that's public facing, but we could also add private facing modules. So if we go back to our registry here, I'm just going to go ahead and down to publish here. And we can go to GitHub and I guess custom. And so then I suppose we just have to enter all the stuff in here. So as an optional display name for your version control provider, client ID, client secret. So it seems like there's a lot of work to do. We'd have to set up the SSH key pair, but I mean, that's generally the details that you need to know for that, okay? It just seems like a lot of work for us to set that up. And the course is just gonna be like, hey, can you add a private module? And you'd be like, yes, okay. So we'll go ahead and just remove this. So you can add both public and private modules, so there you go. I have mentioned Terraform Enterprise so many times in this course, but we've never really talked about it in detail, and now is our opportunity to do so. So Terraform Enterprise is the self-hosted distribution of Terraform platform. And I just want to point out, sometimes I call the Terraform platform Terraform Cloud just because that's the more prominent version of it, but Terraform Cloud is a separate product from Terraform Enterprise. It's just one is a SaaS and the other one is self-hosted. So Terraform Enterprise offers a private instance of the Terraform platform application with the benefits such as no resource limits, with additional enterprise-grade architectural features such as audit logging. So you'd have tamper evidence, SAML, single sign-on, and I'm sure there's a lot more other options there. So let's just kind of look at the architecture really quickly on how this works. So the first thing is you have the Terraform platform, which is going to be installed on a machine. And in particular, this is installed on Linux, and it's specifically installed on Debian. Okay, so I believe that is the Debian logo, as far as I remember. If it's not, we'll find out on the next slide if I'm wrong, okay? You're going to have some kind of storage, and there's a few different options. Probably the most common is going to be on something like S3, but you can store it on the storage or on the disk itself. You have to have a Postgres database, so that's part of the infrastructure because that is what the platform uses. And you'll also have to have your own TLS certificate to access the machine. But there are also cases where, these are going through air-gapped environments. But the idea is that you have SSL or TLS. It's like end-to-end encryption. It goes all the way to the machine. That's where it terminates, okay? You'll also need your Terraform license. So you'll have to plug that in once you start up the Terraform platform and say, hey, tell us the code so you can unlock this, this software for you to use on this dedicated machine, okay? So the requirements for Terraform Enterprise is going to highly vary based on your operational mode that you choose to run it in. And that is really dependent on how data should be stored. And when we were looking at the architectural diagram, that was the operational mode of external services. There's three types of operational modes. The first being external services. That's when you use Postgres and then use cloud storage. So in that example, we're using S3, but you could use GCP, Azure Blob Storage, or Mino Object Storage. But the idea is that Postgres and the cloud storage are external. They're not part of that Linux server, okay? Then you have a mounted disk. So this would just be having a persistent disk attached to the VM. So, in AWS case, it's called EBS. So this stores data in a separate directory on the host intended for external disk. So that would be both the Postgres database and the storage volume itself. Postgres is still a requirement in no matter what mode you use. Then you have demo, so stores all data on the instance. Data can be backed up with snapshots, not recommended for production use. So this is where you have ephemeral data. So, the data, can vanish if you restart the machine unless you make physical snapshots. Another component is credentials. Ensure you have credentials to use Enterprise and have a secure connection. So the first is you need the Terraform Enterprise license, so you obtain that from HashiCorp. And the other part is having a TLS certificate and private key. So you need to prove you own your own TLS certificate. Okay. Then we have the Linux instance. So Terraform Enterprise is designed to run on Linux, and it supports more than one version. So, I said it was only Debian, but I guess there's a bunch. I just forgot. So we have Debian, Ubuntu, Red Hat, CentOS, Amazon Linux. There's a variety for those. Oracle Linux. So yeah, I guess I'm just a big fan of Debian. So that was my thinking there. For hardware requirements, we have at least 10 gigabytes of disk space on the root volume, at least 40 gigabytes of disk space for the Docker data directory. So that would be the var lib docker, at least 8 gigabytes of the system memory, and at least 4 CPU cores. So there you go. Let's talk about air-gapped environments. So what is an air gap? An air gap or disconnected network is a network security measure employed on one or more computers to ensure that a secure computer network is physically isolated from unsecure networks, so the public internet. So it's no internet, no outside connectivity. Industries in the public sector, so government, military, or large enterprises, finance, and energy often employ air-gapped networks. And so I want you to know that HashiCorp Terraform Enterprise supports an installation type of air-gapped environments. Okay, so to install or update Terraform Enterprise, you will supply an air-gap bundle, which is an archive of a Terraform Enterprise release version. So that's how you would, provide it. Okay. So let's take a look at Terraform Cloud features and pricing. So I just want to quickly go through it here. So we have 3 models. We have the open source software, so OSS. We have the cloud offerings and the self-hosted offerings. And under these tiers, we have free, teams, and governance. Technically, it's teams, and then teams and governance. So they're 2 separate plans, but this is the way they display it in their marketing content, but it really is 2 separate tiers in there. You have business and then enterprise, which is considered self-hosted. So in terms of feature set, across the board, you have IaC, workspaces, variables, runs, resource graphs, providers, modules, the public model registry, which is Terraform registry. Workspaces is a bit odd because there are Terraform Cloud workspaces, right? And then you have local workspaces. So technically those should be broken up into 2 separate things or named differently, but that's just how it is with Terraform. So, just asterisk on that workspaces there. For the free tier, you get remote state. For everything outside of the open source, you get remote state, VSC connection. So that's version control state connection. So connecting to GitHub or GitLab or whatever. Workspace management, secure variable storage, remote runs, private module registry. Once we get into cloud, we get team management, Sentinel policy as code management, cost estimation. The reason why I have that in red is because on the exam, it could ask you, when is Sentinel policy available? Is it available at what level? And the thing is, it goes from teams and governments all the way to the enterprise level. Now, technically, there is, again, one called teams, and there's teams and governance. So it's part of teams and governance, not part of teams, okay? Once we get into business, this is where we start to get single sign-on and audit logging. So, if you need it in the cloud or if you need it self-hosted, both options are available. In the business, you can have the self-hosted agents. For configuration designer, ServiceNow integration, you have it for those as well. In terms of how many runs you can have, this is very important because this is going to put a bottleneck in terms of your infrastructure, right? So in the free tier, you can have 1 current run of a workspace. In Teams, you can have 2. And then at the business level and beyond, it's unlimited current runs. For how you would actually interact with Terraform, this is going to be through the local CLI for the open source software. For these, it's cloud, meaning that it's cloud that is triggering the execution commands, and then self-hosted, it's not in the cloud, it's on that private machine, okay? Then we have support. So for support, it's all community. So that's just reaching out to DAs. Maybe there's a Slack channel. I believe that they have a forum. So they have like a forum where you can ask questions. And then they have these layers like bronze, silver, and gold. I could not determine what these are, like what is offered in them. And the odd thing is that, there's a silver and gold, but it's offered both at business and enterprise. So I don't know if like you can upgrade from silver to gold, so it's optional, or you always get silver and gold. Could not get clarification. I tried asking the sales team. No one would tell me. So I think you have to really be deep in that sales funnel to find out. In terms of pricing, it's 0 to up to 5 users. So the thing is, and this is really confusing about Terraform Cloud, and they really shouldn't have called it teams up here, but you can start using Terraform Cloud for free up to 5 users as a team. Okay, so just negate the fact that it's not called teams. What they're saying is that teams is really about getting workspace remote management, which is actually RBA, like RABC controls, role-based access controls. So that's the whole point of using teams. So if you need that, and that's when you're at 5, that's when you use it. But you can use it in the free tier as a team, and you absolutely should. Once you get to the Teams plan, it's going to be $20 a month. And then if you need Teams and governance, it's actually like $7 a month. So again, it's kind of like a bit misleading how they've labeled this out. But if you go and open up Teams Cloud, you can see what the actual packages are. For business, self-hosted, your contact and sales. So I have no idea what the cost is there. So there you go. All right, we're taking a look here at Workspaces. So Workspaces allow you to manage multiple environments or alternate state files, such as development or production. And there are 2 variants of the workspace. We have CLI workspaces, a way of managing alternate state files locally or via remote backends. And then we have Terraform Cloud workspaces that act like completely separate working directories. I'm going to tell you, these 2 are confusing because they don't exactly work the same way, but they have the same name. And originally, workspaces were called environments. And so, when you're using Terraform Cloud, it makes a lot of sense to call them environments. And the CLI workspace, it's just a little bit different. So, I'm not sure if I'm going to do a great job explaining the difference of these things. You really have to go through the motion of it to really get the hang of it. But I'll do the best I can here, okay? So think of workspaces as being similar to having different branches in a Git repo. Workspaces are technically the equivalent to renaming your state file, okay? So in Terraform 0.9, they used to be workspaces used to be called environments, but people got confused, which I have no idea why, but that's what it is now. So by default, you already have a single workspace in your local backend called default, and the default workspace can never be deleted. So even if you don't think you're using workspaces, you absolutely are, even the first time you use Terraform, at least in the CLI workspace, okay? Let's get a little bit into the internals. This isn't really that much detail, but depending if you are on a local or remote backend, changes how the state file is stored. So if you're on a local state or a remote state, it's going to be different. So Terraform stores the workspace states in a folder called terraform.tf state.d. On the remote state, the workspace file are stored directly in the configured backend. In practice, individuals or very small teams will have known to commit these files to the repos, but using a remote backend instead is recommended when there are multiple collaborators. So I guess there's not really much to say here, but just understand that when you have a local state file, it's going to be in that Terraform TF state D, and then when it's remote state, you don't have to worry about it, okay? Let's talk about interpolation with current workspaces. So you can reference the current workspace name via the terraform.workspace named value. So we saw that in the lineup way earlier in the course. So the idea here is that if you wanted to see if the default, like let's say you want to say, am I in the default workspace, then return 5 as opposed to 1, because maybe you're very comfortable spinning up more in the default than whether it was something else. And just another example, maybe you want to use it to apply the name of the workspace as a tag. So here that would actually give this virtual machine in AWS the name web hyphen whatever it is, production or development. So there you go. Let's talk about multiple workspaces. So a Terraform configuration has a backend that defines how operations are executed and where persistent data is stored, so like the Terraform State. So multiple workspaces are currently supported by the following backends: Azure RM, Consul, COS, GCS, so that's Google Cloud Storage, Kubernetes, Local, Manta, Postgres, Remote, S3. They're not going to ask you this on the exam, which ones are supported, but for your own purposes, if you want to use multiple workspaces with a standard backend, you probably want to know which ones. Certain backends support multiple name workspaces, allowing multiple states to be associated with a single configuration. The configuration still has only one backend, but multiple distinct instances of the configuration to be deployed without configuring a new backend or changing authentication credentials. Why would you want to use multiple workspaces for something like a standard backend? Well, the idea here is that, if let's say you're using Terraform Cloud and you've reached your limit of 5 users, and it just gets too expensive to go to the 6th user where you have to pay for all of them, then the thing is that this is an option for you. It's just kind of like another option out there until you are ready to pay for Terraform Cloud at the next tier up. So that's the reason why I'm mentioning it here for you, okay? All right, let's quickly walk through the Terraform Cloud workspace. And the easiest way is to just show you a screenshot. So you create a workspace on Terraform Cloud. So first you'll create an organization. Mine's called ExamPro. And within that, you'll create multiple workspaces. From there, you'll click into your workspace and you'll see like previous runs, states, variable settings. We'll click into runs. From runs, what we'll get is a list of what happened previously. We can click into one of those and we can see our plan and our apply. We can leave a comment on each run that has happened. If we just want to expand the plan and apply here, for plan, we will see all the details of what it would change. And then apply is it actually setting up that infrastructure and whether it was successful or not. Notice you can also download Sentinel mock files. We'll come and talk about that later when we get to our Sentinel section. We can also see a history of previously held states. So these are snapshots of that infrastructure. And so you can click into there and exactly see what it looks like. This is useful if you want to go and download it if you were to need it. So here's a diff of what changed since the last state. Okay, and of course you can download that stuff. So, hopefully that gives you an idea of what you can do with Terraform Cloud workspaces. Let's talk about Terraform Cloud run triggers. So Terraform Cloud provides a way to connect your workspaces to one or more workspaces via run triggers within your organization known as source workspaces. So run triggers allows runs to queue automatically in your workspace on successful apply of runs in any of your source workspaces, and you can connect each workspace to up to 20 source workspaces. So run triggers are designed for workspaces that rely on information or infrastructure produced by other workspaces. If a Terraform configuration uses data sources to read values that might be changed by another workspace, run triggers lets you explicitly specify the external dependencies. So the idea is just allow you to say, okay, I have one workspace, I've triggered that, I want it now to do that. So this is really great if you have a bunch of environments or stacks that are reliant on each other and you want it to kind of have a chain reaction. The reason I'm mentioning run triggers is A, I think it's a cool feature, and B, because triggers is something that is also something else when we're looking at provisioners. And I just wanted to just clarify that there's run triggers from Terraform Cloud, and then there's triggers that are for, when I said provisioners, I really mean null resources. They have triggers in that, okay? So it's not going to show up in the exam, but it's just a good to know feature. I just want to make sure there's no confusion with the other triggers. Let's take a look at some of the Terraform Workspace CLI commands that we have available to us. The first starting with Terraform Workspace List. So list all the existing workspaces, and the current workspace is indicated by an asterisk. So that is our current workspace there. Terraform Workspace show the current workspace. So right now we're working in development. Terraform Workspace Select, switch to a target workspace. So here we could say select default, and now we're in the default. Terraform Workspace New, so create and switch to a new workspace. And then we have Terraform Workspace Delete, so delete a target workspace. Now, understand that this is affecting your local ones for the CLI commands, okay? But Yeah, so this would actually show up in the exam. They might ask you like, which is select and what does list do and things like that. So make sure you know these commands, okay? All right, so I just wanted to contrast against the local or CLI driven workflows via the Terraform Cloud workflows, because there's this great table chart that's from the documentation that I want to show you. So Terraform Cloud workspaces and local working directories serve the same purposes, but they store their data differently. So just looking here, we'll go down the components here. So for Terraform configuration, it's going to be on disk for local. For Terraform Cloud, in linked version control repositories or periodically uploaded via the API or CLI. We have variable values, so this is where we use TFRs, and when we're in Terraform Cloud, it's in the actual workspace, the Terraform Cloud workspace, and so that means that we are setting environment variables to propagate that into our code or inject those variables into our code on execution. For state, it's on disk or in a remote backend, and in the workspace for Terraform Cloud, it's actually in the workspace. Credentials and secrets are in shell environments or are entered at prompts. In workspace, they're stored as sensitive variables. These are environment variables again. So there you go. Hey, this is Andrew Brown from ExamPro, and we are on to our Terraform Cloud follow-alongs. Now, we already did Terraform Cloud version control system earlier than I thought we were going to do, so I'm going to remove it from the list. And what we'll do is focus on permissions and maybe the API tokens and things like that. So what I want you to do, and I've got some old tabs open here, but I'm going to make my way over to terraform.io, and I'm going to go log into Terraform Cloud here. And I don't think I've ever done this, but I can upgrade to the trial account, because the thing is that when we are in our account here and we're trying to look at permissions, and we're not using force unlocking anymore, I might just keep that around for a little bit. But if we were to go to our user settings here, we go to organizations, that might not be a very good example. I guess I wanted like the organization settings here, which would be maybe here, yeah, up here. And so, when we go to our teams and our users, everyone's being added as an owner. We don't have like granular permissions, and that's because we'd have to upgrade. And so I figured this would be a good opportunity for me to just kind of upgrade to show you those more detailed role-based access control permissions, just so you know where they are. So I'm going to go to the upgrade now, and notice that we're on the free plan. And also take note, because later on in the course I talk about pricing, or we've already crossed it, but notice that we have a team plan and a team and governance plan. This one's at $20 and this one's at $70. So, this is not something that's reflected, at least not right now, on the Terraform website. And so it just looks like there's a team and governance plan for $20, and this middle one's missing. The key difference here is this one has Sentinel policy as code. But you can see on the free plan, we are able to do team-based stuff. But let's go switch over to the trial plan. I'm going to see if I can do this without entering a credit card in. So here it says you're currently on trial plan. I didn't have to enter anything in. That's really great. And so that means now I have all these team management options. So if I go over to team management, I can actually go ahead and create some teams. So I'll just say like developers. Okay. And so now I have all these options. So we can say this person, if someone's in this team, they're allowed to manage policies. They're able to do that. A visible team can be seen by every member, or we can keep them secret. We can generate out team API tokens, which I guess we could just like cover this as we do it. But notice we can go here, and that generates out that token that we can use. I'm going to go ahead and delete that token. So nothing super exciting there. It's not like that complicated. If we want to set things on the workplace, now if we go back to workplace or workspaces here, and now we have team access, and notice I can go to add team permissions here, and we can say select this team for their permissions. And so these are these pre-built ones in. So we have read, plan, write. So these are those three predefined ones that we talked about previously. And then we have down here like assign permissions for the admin of a workspace. We are able to set customized permissions. So if we toggle this, we should be able to do it. I mean, this looks like it's the same thing. No, I guess it's more granular. So here, I guess we have our granular permissions that we can set. So for runs, we can do read, plan, or reply, lock or unlock a workspace, send unlocks, things like that. It's not super complicated. If we want to drain out API tokens for Well, there's the organizational one, there's the teams one, and then there's the user one. So if we go to the organization, we can see that we can generate out one here. So I can say create an API token. So there it is. Just go ahead and delete that. And if we go back to our teams, we did this earlier, but we can generate one here. And then if you want to generate one for your user, it's probably under user settings. Yeah, so we generate tokens there as well, okay? So, I mean, again, there's not a lot to talk about here, but yeah, so I guess that really covers permissions and API tokens, okay? Okay, so that finished deploying there, and so we can see our resources have been created. But one thing that we didn't set was the prefix. I'm actually interested to see that that worked properly, but what I could do is say prefix, and then do an underscore here. And I don't know how that would affect it. And this actually happened over in this repository here. I'm actually using a hyphen, so I'm going to just change that to that. Might have to do a Terraform init there, migrate the state. So that was a complete mistake on my part, but I guess my thought was that I thought I had to have, this is still on main, and I guess we never really set up a production branch, but yeah, so now when we have the prefix in, it's actually going to prompt us for the other ones. So the currently selected workspaces are default, does not exist, and so dev is showing up, and notice that we can't deploy to main. So I think the thing is that if we wanted a production one, we would just create that workspace, and then it would reflect here. So the way you make multiple workspaces here would actually have to make them all. So we'd have to make a VCS Terraform prod, and I'm very certain that it would just show up here, and then you would select the number that you'd want. Though what's interesting is the fact that we are in the dev branch, and we have to say, oh, I want to deploy the dev one. So that's kind of a little bit of a caveat there, but I guess there's not really any way around it. But I mean, this pretty much, you know, explores what we need for multiple workspaces with Terraform Cloud, and we did the remote ones, and we're all good. So there we go. I guess the last thing here we should probably do is just clean up. So if we go to Terraform dev here, we're going to go down to destruction, and we'll run a destroy plan here. Okay. And once this is all done, you know, you can go ahead and just delete these repositories. And notice this one it has a private lock on it. So, oh, because it's actually running right now, so it's being locked. So, yep, there we go. So that's it. Hey, this is Andrew Brown from ExamPro, and we are taking a look at Sentinel, which is an embedded policy as code framework integrated within the Terraform platform. So what is policy as code? When you write code to automate regulatory or governance policies, and features of Sentinels include that it's embedded, so enable policy enforcement in the data path to actively reject violating behavior instead of passively detecting. So it's very active or proactive. Fine-grained condition-based policies, so make policy decisions based on the condition of other values. Multiple enforcement levels, so advisory, soft, and hard mandatory levels allow policy writers to warn on or reject behavior. We have external information, so source external information to make holistic policy decisions. We have multi-cloud compatible, so ensure infrastructure changes are within business and regulatory policy across multiple providers. And Sentinel is a paid service part of the team and governance upgrade package. So starting at team and governance, it's available for that. Business and enterprise, okay? Let us expand a bit on the concept of policy as code and relating to Sentinel. So Sentinel is built around the idea and provides all the benefits of policy of code. Let's talk about the benefits we get with this. So sandboxing, the ability to create guardrails to avoid dangerous actions or remove the need of manual verification. Codification, the policies are well documented and exactly represent what is enforced. Version control, easy to modify or iterate on policies with a chain of history of changes over time. Testing, so syntax and behavior can easily be validated with Sentinel, ensuring policies are configured as expected. Automation, so policies existing as code allows you to direct integrate policies in various systems to auto-remediate and notify. We're talking about Sentinel and policy as code. We have language, so all Sentinel policies are written using the Sentinel language. This is designed to be non-programmer and programmer-friendly, embeddable, and safe. For development, Sentinel provides a CLI for development and testing. And for testing, Sentinel provides a test framework designed specifically for automation. So hopefully that gives you an idea of the benefits of policy code, and in particular with Sentinel. All right, let's take a look at the Sentinel language and also just a broad range of use cases that we could use these for, so you can start thinking about how to start applying Sentinel. The great thing is that there are a bunch of example policies provided by HashiCorp, so you can easily start using them right away. But let's go through the big list to kind of give you an idea where you would use policies code. So for AWS, maybe you'd want to restrict the owners of the AWS AMI to of the data source. Maybe you want to enforce mandatory tags on taggable AWS resources, restrict availability zones used by EC2 instances, disallow 0.0.0.04.0, basically anywhere address out to the internet, restrict instance types of EC2, so maybe you only want people using T2 micros, require S3 buckets to be private and encrypted by KMS, since that is a big problem for people on AWS where their buckets get leaked. Require VPCs to have DNS host names enabled. We're looking at GCP, enforce mandatory labels on VMs, disallow anywhere CIDR, enforce limits on GKE clusters, because those can get really expensive, restrict machine types of VMs, just like AWS. For VMware, require storage DRS on data store clusters, restrict size and type of virtual disks, restrict CPU count memory of VMs, restrict size of VM disks, require NFS 4.1 and Kerberos, I never can say that properly, on NAS data stores. For Azure, enforce mandatory tags of VMs, restrict publishers of VMs, restrict VM images, restrict the size of Azure VMs, enforce limits on AKS clusters, restrict CIDR blocks of security groups. For cloud agnostic, allowed only say we can only use these allowed providers. Say or explicitly say what providers are not allowed, limit proposed monthly costs, prevent providers in non-root modules, require all modules have version constraints, require all resources be created in modules in private module registry, use most recent versions of modules in a private module registry. That's more so like about the tooling around modules. Now let's take a look at an example. And this is one for restricting availability zones on EC2 instances, so like what data centers you're allowed to use. And so we first import our language functions. That's going to allow us to use particular feature functions in this. We're going to specify our AZs. We're going to get all the virtual machines. We're going to filter that and restrict the AZ for those VMs. And we're going to define that rule to make it enforceable. So there you go. All right, let's take a look here with Sentinel with Terraform. So Sentinel can be integrated with Terraform via Terraform Cloud as part of your IaC provisioning pipeline. And where it's going to sit is between plan and apply, okay? So the way you do it is you're going to have to create a policy set and apply these to the Terraform workspace. So it's not that complicated to get it hooked up. So yeah, that's all there is to it, okay? Hey, this is Andrew Brown from ExamPro, and we're going to learn a bit about Sentinel with Terraform. I'm not going to say I'm amazing at it, but we are going to stumble our way through and see what we can accomplish. We know we can download Sentinel mocks, and there's also the ability to set policy sets. And I do know that there are a bunch of pre-made Sentinel policies. So we go Sentinel policies here, Terraform, and we go examples. There we are, probably here. There are a bunch of ones that we can go in here. So I'm thinking that there's something that we can do here, but we'll have to figure our way through here because I actually haven't ran any policies myself. So we have these two environments. I'm not using dev anymore. I'm done with this. I'm going to go ahead and destroy that. And we're going to go down to Terraform destroy. I'm pretty sure I don't have any running infrastructure. Actually, I'm going to double check by going to the overview. Everything has been destroyed. And so I'll go back over here and we're going to destroy this. I'm going to type in VCS Terraform dev. Great. And if we go into this workplace or workspace, nothing is provisioned right now. So I want to get everything running again. because last time we ran a destroy. So I think that if we want to get this working, it should be pretty easy. I'm going to go back to our workflows file here, and we're just going to revert some changes. So I'm going to go back and change this to name. And I'm just going to go, whoops, we're going to go into our 120 directory here, and we're going to go git checkout main. And that actually might just revert those changes there. I don't think anything really changed much other than this part here. And so what I'm going to do is just go make a minor change. It doesn't matter what it is. Maybe a space. Git add all. Whoops. Git commit -m. Changes. Git push. We'll have to do a git pull here. Git push. Sorry, git push. And so what I want to see here is a trigger for the run. There we go, and I'll see you here in a bit when it's provisioned, okay? All right, so after a short little wait there, it looks like our branches ran, so I think our resources are provisioned. It's cool, we actually have cost estimation. I didn't have to do anything to turn that on. We already have it. Notice that it's giving us an hourly of 0.12 cents. The monthly is going to be $8 and, 35 cents there. If there was more resources there, we would obviously get that. I assume that it would show up here in the top right corner. So we're not really interested in the provisioned infrastructure, but more so looking at these Sentinel mocks. So I'm going to go ahead and download them there, and that's going to download as a zip or an archive of some sorts. And so what I can do here is just unzip it. So I'm just going to make a new folder here, and we'll just call these Sentinel mocks. Okay, I'm just going to open up the zip, and so here's all the stuff in here. So we have a variety of different files. I think some of them might be redundant. I'm not sure what we have to do with them, but I'm just going to go ahead and grab these and drag them into the folder here. Okay, and actually what I'm going to do is I'm going to just make a new section in my folder here. Whoops. Just give me a second here. We'll just open up the Explorer to anything. Yeah, we have a folder right here. Because what I want to do is just drop those files in so we can just see them in VS Code, the contents of them. There we go. And so now I'm just going to go down to here, and we'll take a look. So we have Sentinel HCL. All right, and so that's just defining a bunch of mocks. We have this Sentinel file here. So I was hoping when we open this that we'd be able to figure out what to do with this, and I have no idea. So you know what? What I'm going to do is I'm just going to do a little bit of reading, and I'm going to come back to you after I finish reading this, okay? All right, so spending a little bit of time watching some stuff. So I was just going through the deep dive of Sentinel here and just going through the documentation. And as far as I understand it, it looks like that you write policies, and then you can also write tests for your policies to assert that your policies are doing what you expect them to do. And I guess those Sentinel mocks are written in a form of HCL, but it is a little bit confusing because you get this folder with a bunch of stuff in it, and it can be either written as JSON or like this HCL-like format. But as far as I can tell, it's just saying what it's done is it's generated out the current state of exactly what your infrastructure is, and I think that it's going to check to see is it exactly what you expect it to be. So I don't know if mocks is that very useful and might be a little bit too much for this particular course. So I'm just going to say let's just kind of ignore mocks because they're just a little bit too difficult and out of scope here. Let's focus on trying to get a policy implemented. So I'm going to go back over here, and what I'm going to do is I know that if I go to settings, I mean, I've seen it before. I just can't remember if it's under a workspace. No, I think it's at the organization level. So we're going to go to the settings here, and there we have our policies. So here we can create new policies. So managing individual policies, Terraform is deprecated. Policy sets now supports VCS integration with direct API uploads. This provides a streamlined policy management experience policies, which includes, okay, so this is the old way of doing it. And so we'll go here and create a new policy set. So connect a new policy set. Okay, so I guess what we have to do, oh boy, this is a lot different than I thought it was going to be. So I thought it was just like, we're going to go here and create it and then dump our code in, which apparently that's what it is. But it seems like we need to associate with the policy set. So just give me a moment because I do want to show you the most up-to-date way to do this. So I'll be back in a second, all right? All right, so doing a little bit of reading here, it looks like what we have to do is create ourselves a sentinel.htcl file, and this is going to say what policies we want to enforce. So I assume this is basically the policy set as a file, and here we specify the policies that we care about. And I actually just want to go back to the files we were looking at earlier because we saw this HCL file, so I guess this would technically be a policy set. Is that what we would call that here? But notice it says mocks, so these aren't policies per se, these are just grouping mocks. But in any case, I think we'll have to create this file. So what I'm going to try to do, and I don't know if this is going to work, but we'll just stumble our way through here because it's the best way to learn, is we're going to create ourselves our own Sentinel file here. So we're going to say sentinel.htcl, and we're going to have to define ourselves a policy. This isn't going to be the one that we're going to use, but I'm just going to grab it here. Notice there are different enforcement levels, so I don't really care what we put in. I just want to see that we can successfully get anything working here. And I'm going to go back to the examples, if we can go find that there. So Sentinel policy examples, and let's just go take one of those and see what we can do with it, okay? So if we scroll on down, disallow 000 CIDR block in the security group. That seems like something that would be pretty relevant. Restrict instance type of EC2 instance. That could be something as well that we could do. So, you know, I just have to decide what it is we want to do here. Restrict owners. So there's a few that are good here. Let's take a look at this one because I feel like this might be very simple. So yeah, this is perfect. Okay, so what we'll do is we'll take this policy here. So I wonder if I could just go download this file here. There's probably like a download button. Well, I can't find it, so we'll just, or maybe it's up here? No, okay. We'll just create this by hand here. So I'm gonna go copy, and it looks like we can just drop it in here. So I'm just gonna go new file here, and put that there, and we'll just go to raw. And we will go ahead and drop that on in there. So I wish I had like Sentinel highlighting. I don't know if there is such a one for VS Code. If there is, it'd be really nice. So we would type in Sentinel. Yes, we do. This one has more downloads, so we'll go with that one. No rating as of yet. Looks like it works, so let's go give them a 5-star. I think that's only fair because no one's done that yet. Might be a bit too hard to, I've never written a review before, but we'll go here and say, works as expected. Thank you for this extension. Okay, so what I'm going to do is go back over to here. And so here we have some kinds. Now we're running a T2 micro, I believe. So this policy should cause it to fail. And that's exactly what we want. But I'm just going to go look up and down to see if it's all correct. It looks good to me. The only thing we'll have to change over here is the name. So I'm just going to clear this out and we'll say restrict EC2 instance type. We'll save that. Hard mandatory sounds really good to me. Probably have to spell it right for it to work. RES, yeah, strict. Okay, great. And so what I'll do is just copy this up here. Okay, and so we have our Sentinel HCL file and it's referencing a local file. Now the question is, you know, can we use the same repository? I assume we would be able to for our policy set, but it almost seems like it might encourage you to have your policies separate from your repository that you're testing. And that might be really good because let's say you have multiple workspaces or environments and they all require the same policy set. You wouldn't want to have them in your code base like that. But for the purposes of this, we're just going to keep it simple. I'm going to go ahead and open up terminal here, and we're going to commit these changes to our repository. And this will end up triggering a deploy, even though we don't necessarily want that to happen, but there's no way around that. So git, well, I suppose we could just cancel it out, or not have the auto apply, but I don't feel like changing that. So we'll do git status here. We'll go git add all, git commit -m simple policy here. git push. Okay. And so that's being pushed to our repository. That's going to trigger a deploy, and we don't care. I assume that it won't pick up the policy because we have to connect the policy set. So apparently you can use the API to upload your policy set, which is kind of cool. I suppose we could have done that, but well, too late. We probably should use VCS anyway, you know what I mean? So we'll go to GitHub here, and we will find our Terraform repository, which is here. You know, policy. Well, we should probably name this, right? So we policy to enforce instance type. I don't know if we need a description. I guess we'll find out in a second here. I guess we could have also put the policy in a subdirectory there. That might have been okay to do. It's going to default to the main branch, which is fine. Policies enforced on all workspaces or policies enforced on selected workspaces. And we only have one, but that's what we'll do down here. So we'll say update. The name is invalid. Oh, it has to be like a proper name. So restrict EC2. Now again, this is a policy set, so you could just say like, you know, basic server policy set. That'd probably be better. And then you probably want a list to say what it does. Restricts EC2 instances, instance type. Okay. And we'll go down here and create that policy set. And that looks like we're in good shape. So we applied it. Now, will it actually happen on this run? Because it's already running, I believe. We go into this workspace. I like to say workplace. It's workspace. And we go over here. This is already planned and finished. So what I want to do is just trigger another deploy here. So there's nothing changed. So I'm not sure what we do here. I guess what we could do, and actually this is something that I don't know, but like how would you trigger a replace on here? Because if we were doing, let's go to plan and see what happens. I wonder if we could do that in the plan here. Reasons for trigger, do refresh only, plan. Because one thing I was thinking about is like, imagine I wanted to replace an element. You can do that -replace, but I don't know how you do that through VCS. But anyway, what I'm going to do is just go change anything in our code. So it could just be a space. It doesn't really matter. Git add plus, git commit, trigger change. And we just want to observe the policy working, okay? So I'm just going to open this up here. I'm not sure if it's going to show up in the plan section or the apply section, so we'll just wait here to see the plan generate out. And so the plan finished. We don't see any Sentinel being applied there. Apply will not run. Let's expand that there. This looks fine. I guess technically we didn't change anything, so that probably is not very helpful. So what I'm going to do is go and change a variable, because maybe that's what's going to help here. So we have a micro here, which is fine. We're just going to change this over to nano. That makes sense why it didn't do it. So we'll go back over to runs, and I'm going to trigger, I'm going to start a plan. So change EC2 instance type. We'll say start plan. Okay, so we have one change, which is fine. Okay, so that part passed. It's going to go to cost estimation. That passed. It's going to apply it. Because remember, we have auto approve on the server, so it's not even going to ask us to confirm it. And so I want to see if that policy is in place. While it's running, I'm just going to go review our policy here, just to make sure it's not like the opposite, saying like you cannot have these. So include now allowed EC2 instance types. So it's small, medium, or large. So it really should quit out on this one here. But it seems like it's working. Like it's not picking up the policy. But I'll see here back in a bit. Okay. All right, so I didn't see the policy trigger there, so I'm going to go back to policy sets, and notice here it says 0 workspaces, which is unusual because I definitely selected one, but maybe I didn't click through or hit add. So I'm going to go down here and click this one again, and maybe I didn't hit this button here. Okay, and now I'll probably have to hit update policy set. Before we do, I just want to read about this. These parameters are passed to Sentinel runtime when performing policy checks. So I guess that'd be like a way where you'd have a generic policy, and then you could kind of put parameters in. So that's kind of cool. So I'm going to go back here and double check to make sure that we have a workspace set. And so what we'll do is just change the variable again. So we will go to our variables here, and I'm going to go change this back to a micro. And so I think this time we are going to have better success. Okay, so we'll hit save. We'll go back up to runs. We'll go and start a new plan, change instance type again here. And we will save that plan. And so that plan is now running. I will see you back here in a bit when we see that Sentinel policy. I don't know when it triggers, so I'll see you back here in a bit. All right, welcome back. So after our cross estimation, it did a policy check, and you can see that it failed. And here the error says, import TF plans function is not available. So I'm not sure why that's happening. So I think that, our set failed, but not for the reason we wanted to. So I'm going to go investigate this, and I'll be back in a moment, okay? All right, so what I've done here is I've gone and looked up like how to create a policy set, and HashiCorp Learn has this example project here. And if we go into its GitHub project and I go here, you're going to notice that it's like this apparently does basically the same thing: restrict AWS instance type and apparently tag as well. But it doesn't have the TF functions, the TF plan functions here. So maybe we don't need that function in there, and maybe the example is just out of date at this time. So import common functions for Sentinel. Okay, but this one doesn't have it. It does have it for mocks, right? So maybe we just need to kind of like walk through this really quickly and see how we can fix this. So the policy uses the Sentinel TF2 plan import to require that all EC2 instances have instance types planned on the allowed list. But I don't see that import there. Okay, and it is in here. So I guess what we'll do is just grab this one. Okay, and I'm going to go ahead and just delete this one out here. Again, this isn't working. I don't know if this would work with that one, so I'm going to take it out. This is pretty clear what this does, so we'll just have that allowed types. It's interesting, like here it's underscore, and then here it's like title case. There's some inconsistencies there. So they have allowed types as well. And I'm just seeing if there's like find resources in here. So allow types, rule to enforce the name tag. So I don't care about that. Rule to restrict the instance type. So I'm going to go ahead and grab this one here, and let's just take a look at the differences here. Okay, so instance type allowed rule all EC2 instances as that instance change after instance type allowed type. So this is way, way different. So, I fully don't understand this, but I do know that this one will probably work. So I'm going to go down here. We have count violations. I'm not really worried about that. And the rule's different. Like, if I was really serious about this, I'm sure I could, figure out the logic here. But again, this is just for the purposes of us learning, so we don't have to go too crazy here. Now, this says instance type allowed and mandatory instance tags. We're not dealing with tags here, so I'm just going to say this. Okay, and so I think this will produce what we want. So allows those types. I don't know if it had this in here. Get all instance types from the module. I think we didn't put this in here, so this might be kind of the equivalent. EC2 instances, filter, TF plan, resource changes. Okay. Contains a create or an update. Okay. I mean, this isn't bad. We technically have a name set, so you know what? I'm just going to grab this whole thing because then we're just going to have a much easier time. We don't have to worry about it. But it was nice to walk through that file very quickly because the name tag is set in our project A because we can see that it's the server name. So what we'll do is we'll just go ahead and add this to our repository here. And the great thing is that since it's the VS Code or it's in the same version control system, I would think that it would update in time. So what we'll do is just do git add all, git commit -m, fix the policy, git push. Okay, and we'll go back over here. And we will see if the policy check happens. And when it does happen, it's actually erroring out because we're not using the right instance size, right? That's what we want to see. A little bit of trial and error, it's not a big deal. I also read, like over here, that the Sentinel file for HCL only contains module and policies, but then we saw a Sentinel file or the HCL file that clearly had mocks in it. So, I mean, maybe it's just only used locally. Maybe it's not intended for production. So we'll go down here, TF plan. So it didn't pick it up. Okay, so what I'm going to do is go back to my policy set, and maybe it's just like the order of how this happened. So see, this says it was updated last 5 minutes ago. Updated it a minute ago. So this could just be like a race case where, you know, this ran before the other one. So I'm going to try to execute this again. Start a new plan, trigger plan. And we'll see if that works now because, again, this said literally updated a minute ago, so maybe it didn't pick it up. So you can see why it would also be good to have your policy set in a separate repo, because if you're deploying this, you don't want to keep triggering your deploys. So I think probably that's what we should have done. I mean, it's a lot extra work, but this way you kind of understand why. So waiting on that plan run. I really don't care about cost estimation. I mean, you could make a policy to check based on that. I'm assuming we can just turn that off if we wanted to. And we'll go over to cost estimation here. Yeah, we could just disable it. But the thing here is that it said our policy passed. So we'll go here. So the result means that all Sentinel policies passed. So restrict the instance type. So description, main rule that requires other rules to be true. Rule to enforce name tag is on all instances. That's true. Rule to restrict the instance type. So maybe we don't understand. Maybe this works in the opposite way. Oh, the T2 micro's here. Okay. So I just want to see it fail. So what we'll do is go back up to our variables here. And we'll go to our instance type. And we'll just change this to nano. And we'll save that. We'll go back over here to our runs. Oh, this is still running the old one here. That's fine. We can just queue up another one here. So we can just say start a new plan, new instance type. Okay, and if we go back over to here, the last one wouldn't have done anything because the infrastructure would have been the same. So the previous one we just did here, right? It would just been like, oh no, it's still trying to apply it. So I guess there is a change. Maybe we changed the instance type last time. I don't know. So anyway, I'll see you back here when this is completely done, okay? All right, great. So we got an error. If we go into our instance type here, right? And we look at it, we can see that it failed because it wasn't the right type. So, I mean, that's pretty interesting. So the other thing I would say that we could do is also kind of check out mocks now, because I kind of feel like I have a better grasp on it now that we have a test running. So just thinking straight about it, a mock really is a representation of the state of infrastructure at the time of. So if we go back to our runs and we go to a successful run, like the trigger plan here, and this one was successful, we could go to the plans here and then download these mock files So we do have the ones from prior, and I think those are totally fine and valid to use. So what if what we do is go back to our project over here, and we have the mock files over here, but really where they need to be is within the workflow directory, because looking at the documentation here, what it's saying is that you get all these things, and this basically represents the state of those mock files, and then you need to make a test folder and then a test data folder, and then there's going to be something based on the name of the mock file. So what we'll do is we'll go up to this folder here, and we'll say new folder, test, and then we'll make another new folder here, test data. Are those folders or files? I think those are files. So we'll delete that. It's just out of habit to click the file there. So we'll say new folder. So we'll say test. And then we'll say another new folder there. Test data. Okay. And so we have our Sentinel file here. So we need to have, I think, a similarly named one here. So if we go back over here, this is foo or whatever. So I think we need to have a folder in here, because it's all based on convention, and it's pretty, not that hard to figure out. I don't even have to read the docs to know that. We'll just put that in here, take out the word Sentinel. And then I would assume that we need a file in here. What's it called? Like there's pass and fail. So I'm going to just do a pass. File new. Pass.hcl. Okay, and then we have our test data. So that was what we had down below here. So I need to go grab that information. I'm just looking for a folder where I might already have open here. If I don't, that's fine. We'll just go ahead down below and just right click and reveal an explorer. We'll go over here, and I need to move all these over. So I just copy them over, and we're going to go over to our Terraform workflow here. And I'm going to go here and paste that data in. I don't know if these contain any kind of sensitive data, because if they're based on the TF state file, these might be something you don't want to share. That might be a security vulnerability, I don't know, but I definitely won't have these available when I put this repository up for free. So we have those files in the right place. And we have all this stuff here. So I think that, like you notice it's not there. So I'm assuming that we need to open up this file and copy into our main HCL file. So we'll go down below here, and then I think it's just a matter of copying all this stuff, right? We'll say cut. And then we'll go to back up to here, I suppose, into our file. It's getting a little bit confusing with all this stuff, eh? Okay, so that's in the right place. Our test data is there, good. Here we are, okay. So what I'm gonna do is just go down here and paste that in. Okay, and so we didn't write any kind of pass. Test data, test. So that's something we will need here. I'm not sure what we'll get, so we'll just scroll down here so we can find the contents of a pass.hcl. It's not showing me anything here, so just give me a moment. I'm going to see what we have to do for this test, okay? All right, so a little bit of Googling. It looks like this one's on the same track here. So since we probably copied the mock data from this one or somewhere through here, we can probably just go grab this. So this is pretty much what our pass file will look like. So we'll go ahead and grab this here. I don't know if we really need a fail to write a failing test. I don't really care about that. I just want to see anything pass here. We'll paste that in here. We do have to be sure that we are accessing our data correctly. So if we are in test, it's going to go up one directory to the Terraform directory. But wouldn't it have to then cd into test? So I don't think that source path is correct. Just going to double check that here. They do have an example repository, so let's take a look here at what we have. Yeah, it's kind of odd. So I think that if this is relevant, it needs to go to test data, because how else would it get there? Okay, so we'll do that. So test rules main equals true. Okay, so that's a pretty simple test. And so I think the way we run tests is there's like a Sentinel test thing here. I don't know if we have Sentinel installed. I don't think so. So there's no Sentinel command. So I guess that's something we're gonna have to install. Sentinel CLI Terraform. Okay, we'll go over here. We're on technically Linux, even though we're on Windows, we're on Linux. So here it's just saying download it and then put it in the correct path. So install, so we'll get the appropriate package here. And we are technically on Linux. And I guess we are 64-bit. It's going to download here. Scroll up. Oh, it is already downloading. Okay, great. And so I'm just going to go to my downloads. And I'm going to open it up here. So there it is. And so I need to get it into the user local bin here. So I'm just going to first get it in anywhere. So because I'm just working here, I'm just going to go open this up. So reveal in the Explorer. Okay. And this is not where I want it to be. I'm just dropping it here for the time being. Technically, we could run it from there. I don't think it'd be that big of a deal. So I'm just going to go back to my VS Code here. And I'm going to just type Sentinel. Sentinel. It is there, right? Yep, it's there. I'm not sure if it's executable, but I'm just going to type in Sentinel here. Sentinel test. Okay, so it doesn't think it's command. So maybe I have to do like chmod u plus x. That makes it executable on Linux. Sentinel command not found. Well, heck, I'm right there. Maybe I have to put a period / like that. Okay, there we go. So, I mean, of course, you don't want to leave it in here. And this would also end up in a repository. So this would go to like your user local bin probably. So I'm going to say like move Sentinel to user local bin. And so now I should just be able to type Sentinel. It should get picked up. It does, great. So here I can do test. And down below it says open test, no such file or directory. So it can't find the mock data. Notice that it's going into the test data, so that is no good for us. We did say to go up a directory, so maybe if I go up back one more like this. Would that work? No. Let's go put back in what they actually had there, which I have a hard time believing that would be correct. So open mock, okay, so that's definitely not right. Okay, and so personally, I just want this to work, so I'm just going to cheat. This is absolutely what you should not do, but you know, like I don't want to be fiddling around with paths all day here. And so I'm just going to give it an absolute path and see if that fixes our problem. Okay, and so we'll just say test data here. So that should absolutely work. I'm just going to expand this here. This is mock TF plan. Oh, but it says pass in the name. Okay, so the problem isn't that. It's the fact that the mock data isn't named. It's because the thing is you could download 2 different mocks, right? So you could have a state that is successful and failed, and you'd probably want to rename them to say passed or failed. So we don't necessarily have that. So I think my original thing was correct, where we had this test data. And so here we just have to make sure we match the name. So mock TF v2 is fine here. Okay. Again, I don't understand the difference between all these files. I definitely saw in the documentation they explain them all. So, you know, that might be something we want to read through here. So this is looking a little bit better. So mock TF plan -version2 Sentinel. So that is correct. But the directory, it doesn't like the directory. It's going in that test again. So again, I'm going to just go back up one more layer here. Okay. There we go. And it's passing. So yeah, so that's all it takes to do that. Again, I think if we were to commit this to our code, I don't think that these run. So we can go like, so we can just go add it and see what happens. So we'll say git add git commit -m validation. And again, I don't know if this mock data should be allowed to be committed into the repository because we have a TF state file here, right? Okay, I don't know, but I'm going to just do a push here to see what happens. But again, I really think that we're probably not supposed to have it in there. So what we'll do is go back to our Terraform IO, sign in, and we'll just see what happens here. I mean, we don't expect the this to pass because it's still using the wrong instance type. But I was just curious to see if the mock would appear in any way here. I don't think it does. I think that's just something that you would have to do beforehand. And I think what you'd have is you'd have a pull request, and the pull request could be used to run those unit tests because that's basically what it is, okay? So yeah, that's exactly what I thought would happen. But down below here, it says the mock block is not supported. So I wonder what you would do. So if you can't have mocks in the file, what would you do locally? Because you need to... I guess the thing is that the mock file, the sentinel.htcl file, would not be in this folder. So you might have the sentinel.htcl file in your main repository for mocking, right? And if you committed it, wouldn't run it because the policy set would actually be in another repository. So I think that's how it's supposed to work. So yeah, I think really we want to have policy sets in their own repository, like completely away from there, because we're running into a lot of problems. But we pretty much accomplished what we wanted to do with Sentinel, more than I thought we were going to do. So that's pretty great. So there you go. In terms of this, we probably want to tear this down. We do need to do something with Vault and stuff like that. But I think that what we'll do is just tear this down, and if we need to bring it back up, we'll do that. So I'm going to go to destruction here, and we're going to go ahead and just destroy the plan here. Okay. And we're all now in good shape. And so, yeah, I'll see you in the next part, okay? But we're all done here for Sentinel. All right, actually, I guess we're not gone here just yet because it looks like our destroy run failed because we didn't pass here. So that is a bit of a problem. So we'll have to go to the variables. I guess it's a good edge case to know about, but we'll go back and change this to a micro, even though it's going to just tear it down anyway, So we'll go and type in micro, save variable, and we'll go back to our runs. We'll start a new plan. We'll go to settings here, destruction, queue the plan. I'm just curious, queuing a plan will redirect a new output here. Okay, cool. So I'm just going to type in VCS Terraform again here. Okay, and so this should work, and I will come back and just confirm this with you, okay? So I'll be back here in a second. All right, so the real reason we can't get rid of this is because we have those darn mocks in there. So what I'm going to do is go over to our Sentinel file here, up to, we don't use this one, so I'm going to go ahead and delete that. That's not even something that's going to happen. And we need to update our HCL file here. Okay. And I'm assuming that this supports this. Okay. Because this is not how we should be doing this. And I'm going to go git add git commit -m. Minor change. Okay. And this is going to trigger a run here. But I really want to do destroy. So we'll just give it a moment there to start so we can kill it. Did I not push? Oh, maybe I didn't push. And we'll go back here. There's that run. I'm going to go in here. I want to stop it. Cancel run. Okay. And so now what I'll do is go over to here, destroy this. We'll run that. Okay. We'll destroy that. And I will, again, see if this is working, and I'll see you back here in a moment, okay? All right, so I just wanted to confirm there that everything is destroyed, so we're all in good shape, okay? So yeah, so we're actually done in Sentinel now for real, okay? Bye. All right, let's take a look here at HashiCorp Packer. So it's a developer tool to provision a build image that will be stored in a repository. Using a build image before you deploy provides you with the following: immutable infrastructure, your VMs in your fleet are all one-to-one in configuration, faster deploys for multiple servers after each build, earlier detection and intervention of package changes or deprecation of old technology. So let's take a look at what that workflow would look like. So you'd have your code, you commit it to your CI/CD pipeline, and within that pipeline, it would start up a build server running Packer, and that would trigger a build image. So you'd use something to provision it with. So you could use Ansible or a variety of different provisioners within Packer. And then Packer would then store it somewhere. So maybe this would be Amazon Machine Image because you're deploying to AWS. And then what you do is reference that image in your Terraform code. And when you provision, it would get deployed to your CSP. So this would be AWS in this case. So Packer configurations is a machine. Packer configuration configures a machine via, Hey, it's Andrew Brown from ExamPro, and we are taking a look at HashiCorp Packer. So Packer is a developer tool to provision a build image that will be stored in a repository. So using a build image before you deploy, it's going to give you the following benefits: immutable infrastructure, your VMs in your fleet are all one-to-one in configuration, faster deploys for multiple servers after each build, earlier detection, intervention of package changes or deprecation of old technology. So let's take a look at what that workflow would look like. So first we'd have GitHub, or your Git, so wherever you commit your changes, and from there that would trigger a CI/CD pipeline. Within that CI/CD pipeline, it would trigger a virtual machine, or a build server that's running Packer, and so that would trigger the build image process. From there, Packer would use some kind of provisioner like Ansible to provision the image, and then when it was done and it was all good, it would store it somewhere like an Amazon Machine Image. Once it is stored wherever you want it to go, then in Terraform, you would just reference it using like a data source, and then from there you could provision your resource, okay? So Packer configures a machine via a Packer template, and yes, I know the E is missing, so sorry about that, but Packer templates use the HashiCorp configuration language, HCL, which we saw, if you remember, way earlier in the course, and that's what we're gonna review next, is what that Packer template file looks like, okay? All right, so Packer configures a machine or container via a Packer template file, and Packer template uses the HashiCorp configuration language, HCL, so that's why it looks very familiar to Terraform and a variety of other languages we've been looking at in this course. And so what this file is doing is provisioning a virtual machine on AWS. So here you can see that it's a T2 micro in the US West 2 region, that it's probably going to be installing Apache since it's named HTTPD. And the way it's going to be created is via an EBS volumes. Let's talk about kind of the components that we're looking at here. So when you have a Packer template file, you have to specify a source. And this says where and what kind of image we are trying to build. So the source is Amazon EBS. So it's looking for an AMI image, or it's being backed by that EBS volume there, okay? In this case, it's an EBS-backed AMI. The image will be stored directly in AWS under the EC2 images. And so we have the build step. So the build allows us to provide configuration scripts. Packer supports a wide range of provisioners. So we have Chef, Puppet, Ansible, PowerShell, Bash, Salt, whatever you want, basically has it. And the post provisioners runs after the image is built, so they can be used to upload artifacts or repackage them. All right, and the place where this is going to be stored is going to be on AMIs, okay? So there you go. Let's look at how we actually integrate Terraform and Packer together in terms of a CI/CD workflow. We kind of saw this in that overall graphic in the first Packer slide. Let's just kind of look at the code, okay? So to integrate Packer, there are two steps. You're going to build the image. So Packer is not a service, but a development tool. So you need to manually run Packer or automate the building of images with a build server running Packer. Then the second part of that is referencing the image. So once an image is built, you can reference the image as a data source. So if it's stored in AWS AMI, we're going to just source it from there. And the way we select it is what we can do is say, okay, get us the most recent one and use this regular expression, and the owner has to be us, and those kind of parameters to decide how to choose that image. So that's all there is to it. You're just using data sources to reference them after they've already been built, okay? Hey, this is Andrew Brown from ExamPro, and we are taking a look at using Packer with Terraform, and mostly it's just about using Packer. And so what I want to accomplish here is to generate an image and store that onto Amazon Machine Images, and then load that into a Terraform file, or like reference it as a data source. So I've never done this before, but it should be fun, and we'll figure this out. So what we're first going to need to do is download Packer. So notice in the top right corner, we have to make your way to Packer however you want to, and we'll go ahead and download. And this one is for Windows, it's a binary, but we are going to be using Linux. We've done this so many times, these two commands, so I'm not going to do that again here, but if you have yet to do so, you can go and run that. And so I'm going to go ahead and install Packer. And once Packer is installed, I will come back here and we will get to it, okay? All right, so after a short little wait there, Packer is installed. And so what I want to do is go into my Packer folder here, and I'm just going to run Packer and see what we get. And so we have Packer build, Consul, fix, format, init, so install missing plugins. It looks kind of similar to Terraform. Build images from a template. That sounds kind of interesting. So I think the first thing we're going to need to do is define ourselves a template file. So I remember I researched one and put one in my slides here. So let's make our way over there and see if we can kind of just like use our notes here as a reference. So going down to this Packer file, let's go ahead and just write one here. I don't say what the name of the Packer file is. That would probably help, but I believe that they're just named as .hcl files. So what I'm going to do is go into this here and make a new file, and we're going to say, I guess, apache.hcl, since we are already very familiar with how to install Apache. That seems like the easiest way to do it. And again, this is going to be very similar looking to Terraform because it's, all based on HCL. So we'll do a type string. And we are going to need some kind of default AMI. So we can go grab the one we've been using all along here. I think we specified it. And we can just go back to count. Count's always a good one to go to. So I just want to go and grab. Where is it? Count. Where are you? Anybody see it? I'm blanking today, so I'm just going to grab it from AWS. It's not a big deal. I'm just pulling up AWS here. We're going to make our way over to EC2. And we're going to go ahead and launch ourselves a new server. Actually, I could probably grab it from the old one. No, I'll launch a new one just in case you don't see anything there. That might not be fair. I'm going to go ahead and grab that AMI ID. And I'll just move that off screen here for a moment. And we're going to place in that AMI ID because I assume we want one to override. Then we're going to say locals, app name. And I think the example I wrote here is Apache because that is what Apache is. It's HTTPD. Not sure how they came up with that name, but that's how they call it. So we need to provide ourselves a source. So we're going to do Amazon EBS, HTTPD. Notice that like the source is not called data, it's just called source. If we go over to the documentation here, just what I want to show you here, docs. If it ever loads. Come on, docs, you can do it. So down below here, or on the left-hand side, we have sources. So if we were to go over to here and go over to Amazon AMI. So that one says Amazon AMI. Overview. Builders. EC2. EBS. I'm just trying to find the same kind of information that it has there, eh? It's not really doing what I want. But anyway, I know that this code is correct, even though we can't seem to find this out. Probably just go type in Packer EBS, Amazon EBS. I really like to always refer to the documentation when I can here. So it does say it's a builder. Amazon EBS. Source. Down below, here we go. All right, so yep. I don't understand this this builder flag as of yet, but we'll work our way through here and figure it out, okay? So I'm going to go back and pull up my VS Code here. And we're going to put curlies here. And so we need our AMI name here. So my server, $, local app name, instance type, T2 micro, region, this is going to be US East 1, source AMI, this is going to be the variable we set up above, AMI ID. Then we are going to do SSH username, that's going to be EC2 user, that's the default that AWS always has. EC2 user. We can do some tags here. Not really necessary, but it's good to probably give it a name, right? So we'll just say name, Apache server. And actually, we could probably just do local.app name maybe instead. And then we have our build step here. So we're going to specify our sources, and we're going to do source.amazonebs.httpd, and we're going to do provisioner shell, and then we want to provide a script. I think we can actually do it inline if we didn't want to do a script there, but we know our script works, so maybe we should just stick to that. So I'm just going to call this userdata.sh because we already have that somewhere before. So we'll do post-process. We don't need a post-process here. So we just want to run that script. I believe we have that in our Terraform workflow. We go over there to our workflow, wherever it is. Might also be under modules. If we go into our module here, didn't we create one there called user data? Oh, that's a YAML file. Oh, okay. I mean, that's not a big deal. We could probably just... Okay, so we're not going to do it that way. All right. If we're not going to do it this way, we probably can provide inline things. We don't probably have to do script equals. So what I'm going to do is go back to the Terraform documentation here, or Packer documentation, I should say. And what I want to do is look at provisioners. We're going to go look at shell. So it has this inline step, and I assume that this is going to run in a sequential order. So inline array of strings. Okay, so what we will do here is we will type in inline. And I've done this like 1,000 times, but I'm just going to go Google it. Apache install AWS tutorial. There's probably like one on the AWS website for it. For like user data. And this is pretty much has some of it here. I was just kind of looking for these commands like the yum install and the sudo system start. So we're going to go ahead and grab that. And then we're going to go and grab the next few lines here. Just want to start and enable. That's the three things that we need to do. Not complicated at all. And so what I'm going to do is type in Packer build and see what happens. Now, I didn't specify any AWS credentials or anything like that. I assume it would pick up the default. And we're going to go to the top here. So it looks like we have to provide the template name. So maybe we'll do Apache HCL here. And it says error parsing JSON invalid character V for the beginning of the value. Oh, so it has to be pkr.hcl. Okay. I'm really liking the user experience to the developer experience for these CLIs. They're really good at telling us what's wrong with them. PKR HCL. If there's like a default file, I don't know what it should be called. So we got a bunch of errors, which is fine. Unsupported argument locals. An argument locals is not expected here. Did you mean to define a locals block? It's because I put an equals in front of it. It's supposed to just be this. Not that we were really using locals for much here. And it looks like it is provisioning, found an AMI. It's going to use that as the source one, creating a temporary key pair, authorizing to port 22, name, Packer builder. So I don't know if this uses, I don't think it does, but I don't know if it uses Amazon, because there's like EC2 builder image. And there might be a way to use it with Packer directly, but I'm not sure how to do that. It's going to go over here. I'm just going to see to make sure it's not running a pipeline here, is it? Image pipelines? No, okay, that's good. But what I will do is go over to my EC2 here. And what I want to go do, okay, so Packer Builder is just running as a virtual machine. So it's actually going to spin up a VM and then bake the AMI that way, which seems a lot better. We'll go over to our AMIs and see when that happens there. Existing lock and other, that red stuff doesn't look good. Seems like it didn't really matter. So the thing, like AWS has an entire pipeline for EC2 image builder, but it does cost money to run, where I kind of feel like if all Packer is doing is spinning up a virtual machine temporarily to bake that image, that's going to be a lot more cost effective. I mean, we could go look up what the cost is to use EC2 image builder while we were watching this. Builder, can't seem to type today. Just pricing, I just want to know the pricing. It can't be free. Oh, is it? There's no cost? I could have swore there was a cost for this. No cost. Image builder is offered at no cost other than the cost of the underlying AWS resource. I think the thing is that it's that when you use EC2 image builder, you have to use of a particular size. You know, if you don't really use AWS, you're more into Azure or GCP, I can understand why this is not much of an interest, but I'm pretty sure if I go here, that the size that you get for the image, what size of image does EC2 image builder use? Because I remember it was like really large, unreasonably large, and that was the cost involved in it. Can't find it today. It's not a big deal. But waiting for the AMI to become ready. So if we go over to our AMIs here and give this a refresh, we can see that it is spinning. So it is provisioning that AMI. While that is going on, what we can do is just start setting up the next part of this. So within our Packer here, we can say new file, and I'm going to say main.tf. I'm going to go as per usual and grab some default code from our count example, which is from right here. Okay, copy that. We're going to go all the way down to the ground here, and going to go into the main TF here, paste that on in. And we probably want to keep the public IP around. We actually don't really care, but I'm putting it in anyway. I'm going to take out the tags. Oh, I want to leave the name in, so I'll just say like server Packer. Okay, server Apache Packer. And this is the thing that we want to replace out. This all looks fine. So this is what we need to figure out is our AMI here. It's probably going to come in as a data source. It has to come in as a data source. And I'm pretty sure that's what I wrote in our documentation here. So yeah, AWS AMI, example, things like that. So what we're going to do is type in AWS AMI, Packer image, and we'll just define that data source. So AWS AMI, Packer image, and we have executable users equals self. I'm not saying I know what all these options do, but like you just go to the documentation, you grab them, you got something that works. True name regex. Okay, and so we would do something like start with the little caret character, and what did we name this? This starts with my server hyphen. Probably would have helped if we named it with like something like Packer in the name, but I think that's fine. We might as well go with the full name here and say HTTPD because that's technically what it's going to be. We might want to match for more values here, so I'm not sure. I guess like we do that because sometimes it's like 3 digits or whatever, but I don't know what Packer is going to do if we keep pushing additional ones. I'm not really familiar with that, so we'll just say owners equals self. And so now that should be all set up to go. As that is running, it finished, so that's all good. We're going to say Terraform init. And here it says block definition must have a block content delimiter. So we have a small problem here. It looks correct to me. This is not right. Okay. We'll see if we can init this. Now, whether our build image works properly, I don't know. So it'd be really good to write like some tests for it. I imagine that there is some kind of way to do that. I guess it'd be like the post processor scripts. Maybe you'd want to do that where you'd want to use that as a means for testing. I'm not really sure. Obviously, different provisioners might have that kind of stuff built in. So, you know, it might be just part of the provisioning tool you can use. So it initialized here. We're going to do Terraform plan because I'm hoping that it might complain about the data AWS AMI here if it does not exist properly, and it did. So your query returned no results. Please change your search criteria and try again. So however I wrote this is probably not correct. So I will just take this out here. Try this. Data AWS AMI Packer, no results. So what I'll do is go over to EC2 here. And actually, that's the only name that's here for the AMI. So I guess I could just go here and grab the name. But maybe that's not the problem. Oh, no, that might be fine. So we'll just do this. Name regex. Okay. So let's go look up data AWS AMI. Executable users, most recent, name regex, owners. Maybe we could just do like a filter here. Let's look at name regex. A regex to apply to an AMI list returned by AWS. This allows for more advanced filtering not supported by the AWS API. This filtering is done locally on the AWS returns. So I suppose that is good, but like I just need it to work. So I'm going to try the filter instead. And I'm actually going to put literally the name in my server HTTPD. I'm going to take out the regex, assuming that is the problem. Owners is self, executable users is self. Please change the criteria. I don't know what executable users actually does. Let's maybe look up what that is. Limit search to users with explicit launch permissions on the image. Is that required? No. So let's just take that out. If more than one, there isn't. So let's just take that out for the time being. Who's the owner of this? We're the owner, right? We have to be. Owner is this IP address. That must be us. Or sorry, not IP, but like our account number. So, I mean, that should be fine. Incorrect attribute value type. Oh, okay, so that was fine. So we'll do .id. But, you know, if you're doing this, like if you wanted a continuous pipeline, you'd probably want to get the most recent and have a better regex. And so I'll do a Terraform apply, auto approve, and see if this works. One thing I kind of wonder is, like, with Packer, how would you do like a versioning? Because that's what I'm not certain about. So like, I'm just kind of like looking through here and seeing what they would do for that. I would imagine that you're probably supposed to like increment it and have it part of the name. Nothing's really speaking to me there, but you know, like the idea is that you want to have things like 000, 01, 02, 03. But I imagine like there's some pragmatic way, maybe there's like a built-in function or something that we can do to do that. Or what you do is you just have a variable probably. That's actually what you probably do, is you'd have like variable, like version, right? String. And then you'd probably set it and it would come through that way, eh? Like you'd set it over here. It says our server has finished provisioning. Let's go see and see if that actually worked. We'll go up to EC2 instances here. That is running. Copy that. Paste that in. The security group doesn't have any open ports, right? So it probably did work. It's just we didn't create a security group with this. So there are no open ports for us to check. I'm not worried about this. I don't care if it actually did work or not, because we more or less followed all the steps there. But I believe the reason it's not working like there is just because we don't have a security group. And I just don't want to fiddle with that and put it into a state so that it does not match. So anyway, we're all done here. So I'm going to do a Terraform apply, auto approve, destroy. But there we go. We accomplished that with Packer. And that pretty much wraps up all the main follow-alongs for the course. So hopefully that was a lot of fun. Yeah, we'll just continue on here. All right, so let's talk about Terraform and Consul, because you're going to hear Consul mentioned throughout the documentation, and you might think it's critical to the exam, but it's not. So I just want to make sure we understand its relation to Terraform. So Consul is a service networking platform which provides service discovery, so central registry for services in the network. It allows for direct communication, so no single point of failure via load balancers. It has a service mesh, so managing network traffic between services. A communication layer on top of your container application, so think middleware. It has application configuration capabilities. So Consul is useful when you have a microservice or service-oriented architecture with hundreds of thousands of services. So these are containerized apps or workloads. And so the way Consul integrates with Terraform is in the following ways. It is a remote backend because Consul has a key value store, and this is where you could store the state of your Terraform files. Then there's a Consul provider because you can use Terraform to set up some things in Consul for you, but there's not much else outside of that, okay? All right, we're taking a look here at HashiCorp Vault. So Vault is a tool for securing accessing secrets from multiple secret data stores. Vault is deployed to a server where a Vault admin can directly manage secrets, and we have operators, also known as developers, can access secrets via an API. Vault provides a unified interface to any secret, such as AWS secrets, Consul key values, Google Cloud KMS, Azure Service Principals. It provides tight access control, so just in time, which is reducing surface attacks based on a range of time, and just enough privilege, so reducing surface attack by providing least permissive permissions. We can also record a detailed audit log, so we have tamper evidence. So this is kind of the idea of our little HashiCorp Vault stack. So you have your secrets engines. These are third-party services, or sorry, cloud services that actually store the secrets. You have your Vault cluster, which act as the adapter to your resources, and then the resources which are going to access them. So again, Vault is deployed to virtual machines in a cluster, and Vaults can be backed up via snapshots. So if you do provision them and you're worried about the state of those Vaults, you can definitely save those for later. Okay? Let's take a look here at Terraform and Vault, how they would work together. So when a developer is working with Terraform and they need to deploy a provider like AWS, they will need AWS credentials. So AWS credentials are long-lived, meaning a user generates a key and secret, and they are usable until they are deleted. So the AWS credentials reside on the developer's local machine, and so the machine is at risk of being compromised by malicious actors looking to steal those credentials. So if we could provide credentials just in time, expire the credentials after a short amount of time, so short-lived, we could reduce the attack surface area of the local machine. And so this is where Vault comes in, because Vault can be used to inject short-lived secrets at the time of Terraform apply. So imagine you are the developer and you run your Terraform apply. At that point in time, it's going to inject the secrets. The way we do that is via data sources. Data sources is always the way we get data into our Terraform configuration file, but let's look at that in greater detail in the next slide here, okay? All right, let's take a look at how this Vault injection via data source works. So a Vault server is provisioned, a Vault engine is configured like AWS Secrets Engine. The Vault will create a machine user for AWS. Vault will generate a short-lived AWS credential for that machine user. Vault will manage and apply the AWS policy, and then within our Terraform, we can provide a data source to the Vault. So that's what we're doing. We're saying Vault AWS Access credentials, and we are getting the output from our Terraform Remote State admin outputs backend. And then from there, we can reference them into AWS, okay? So when Terraform apply is run, it will pull short-lived credentials to be used for the scope of the duration of the current run. Every time you run apply, you will get a new short-lived credentials, which is the whole point of the short-lived idea, okay? Hey, this is Andrew Brown from ExamPro, and we are taking a look at Vault. And so the idea here is that we want to be able to inject secrets from Vault in a secure manner for our local developer environments. I really kind of wish I included this screenshot or this graphic within my slides. I just found it as of now, because it does really represent all the types of secret engines and capabilities of Vault. One thing in particular I wasn't aware of is that it has its own key value store. So that's what we're going to be using. We're going to keep it really simple here. But the first thing we're going to have to do is go ahead and install Vault. So just down below, I have a link here that I found, and we'll go down below. And shouldn't be too hard to install. So we are on Linux today. I mean, I'm on a Windows machine, but I'm using Linux as the Windows subsystem there. And so this is where we're going to start and grab our stuff. So making my way over to VS Code. Whoops. And I'm just trying to think, should we use this for a new project? Probably. So I'm going to just CD out here. And I'm going to make my way into Vault, which apparently I don't have a folder for. So I'm going to just go here. And we're going to find Reveal and Explore. And we'll make a new one. 200 Vault. Okay, and so we'll start first install something, then we'll set up a project, all right? So let's go through the installation process here, okay? So we'll go do a curl, which is our first step. And that's just gonna grab the GPG. I think we already have it because we did it for probably the CLI for Terraform there, but we'll just do it again there, it doesn't hurt. I'll add the repository again. I think we already did this when we installed the CLI in the beginning of this course. But we'll let it go again there. I remember this takes a little bit of time, so we'll just wait here for a bit. All right, so now we need to run the last command, which is actually going to go ahead and install Vault here for us. We'll just go ahead and grab that line. And I'm going to go ahead and paste that on in. I'm not sure if I grabbed that properly. We'll try that one more time. I got my console's unresponsive. There we go. Okay. This happens when I stop and start recording. It just, for some reason, times out like that. So we'll go ahead and hit enter there, and that will go ahead and install our vault. And then after that, we're going to have to start getting it running. There is, again, a tutorial to inject secrets. I'm not going to stick one-to-one with it because it does come with a repository, but I find that it is a little bit more work than we want to do here. We just want to kind of get a basic example working, and I just want to make our lives a little bit easier. So I'm just going to modify it as we go here. But yeah, we'll just wait for that to install. I'll see you back here in a moment, okay? All right, so after a short little wait here, I believe that Vault is installed. Let's find out if it works. So we'll type in Vault. Once I get the responsiveness back from my console here, just giving it a moment. Great. Nope. There we go, Vault. And so Vault is there. And so what we can do is start it up in a developer mode. And I remember from here, they actually had some pretty good instructions on the starting of that. So like the way they do this project, and I have the repo here, is that they provision Vault with a bunch of different things. So I think they're using like S3 here. And that would probably be a really common use case for this, but I really want to simplify, and I don't want to have to provision that with Terraform and cross-reference the stuff. So we're just going to simplify that. So I'm just looking for the command to start Vault, because I saw a good one here that was like Vault, here it is right there. So Vault server -dev, that starts in the developer mode, dev root token ID. There's something about like sealing or unsealing stuff. I don't know what that means, but I assume that's a way of securing the vault. But we're going to go ahead and just type that in. So we're going to go Vault server -dev root token ID. And obviously you wouldn't want to do this for your production. They call theirs education. I'm just going to stick with that to make our lives a bit easier. And so what that's going to do is start up a Vault server. It is running on this port here, so I suppose we should export that or keep this, because we'll probably have to reference it somehow. Notice we have this like unseal key. So the unseal key and root token are displayed below in case you want to seal or re-authenticate. Development should not be used in production. So what I'm going to do is I'm just going to create a README file in our Vault here. So we'll just say new file, README, because I just want to dump this stuff. Of course, you know, you should not share these with anybody, but I just don't want to forget these while we're working through this. So I can go ahead and copy that. And we will go ahead and save that. And so what I want to do now, oops, did we lose our terminal? Did I close it? Okay, I must have closed it. So which one were we working in? Second, third one, which is it? Fourth. Okay, it's the third one. So don't be like me, close out your old ones. So I'm just gonna close out these old ones so I'm less confused. There we go. And so it says that it started on this address here. So I'm going to go copy that address. And we're going to open this up. You can do everything via the CLI. I just want to copy that there. But they have a nice UI, which is nice. And so this is where we're going to put that token, education. I'm going to drop that down. So there are some other options, or there's a lot of options for authenticating, but token is obviously the easiest, probably not the most secure, especially the way we wrote it. And notice that we have a couple things pre-installed. So we have Cubbyhole, which is a per token private secret storage. And then we have key value secret storage. Again, I don't know much about these because this isn't a course on Vault. It's just kind of us showing basic integration and more focused on the Terraform side. But here is where we can create our secrets. We can, of course, use the CLI to do that. And I think they showed in the getting started here. And we don't have to do it this way. I'd rather do it through UI, but you do like Vault key v put, and then you put the name of your secret. So here's secret /hello, and then the key and the value. That's where it would store. I assume that this would go to the, well, this would specify what we're using here. So what we'll do is we'll go over here and we'll create ourselves a new secret because we're going to want to store something here. So we want the path for this secret. This is pretty common with, if you've ever used parameter store, you have a path. I don't know if it starts with a /. It may not end in a /, probably can begin with it. So I'm going to say AWS key, because we'll do the key and the secret, right? So here, oh, okay, cool. So we can do /AWS, and then down below, I would just add another one. Maybe I got to add each one at a time. So we'll say key, and I'll actually go grab our proper ones. Oh, I shouldn't have stopped that. I'm going to have to start that up again. Okay. And we'll add a plus there because everything lives in memory when you're in the dev one. So you really don't want to shut that down or you'll have to redo all this from scratch. So what I'm going to do is just go back here. I'm going to drag this down a little bit more. Okay. And I'm just going to go see if I have to relog in because I might have messed this all up. Yes, I do. So we'll type in education. So we really don't want to stop running that server during the duration of this follow along. Okay. And so we'll go back into secret here, create a secret, /AWS. Would we want it as a JSON? No, I don't think it matters. If we can add 2 keys, that's all that matters to me. And so what I'm going to do is cat out my credentials. Of course, this is not the secure way of doing it. So, you know, again, don't show people these things. And so I want this, and I probably should match the name. I'm going to like type in the whole darn thing. And we'll grab this. Oops. Want to see that value is correct. Good. We're going to add another one here. This is going to be our access secret or secret access key. I really don't like how those have been named. And we'll go ahead and grab on this. And I mean, we don't really need to really store the region here, but why not? Because we're doing all the rest of here. We might as well just throw them all in here for fun. And here it says maximum number of versions. I don't need anything beyond 1 because we're not going to be updating these. Require check and set. So writes will only be allowed if the key's current version matches the version specified in the CAS parameter. Not sure what that means. Maybe just like you're passing something along when you are doing something. But I think this is all good. You know what? I'm just going to leave that back to 10 just in case I've made a mistake and we have to go debug that. I'm going to go hit save. And so there are our secrets. And so what we want to do is be able to access them. And so maybe this is our opportunity to learn the CLI here a bit. So I have it pulled up on the left-hand side. And so what I'm going to do is type in vault key v get, and we'll do AWS. I don't know if we can start with a / there. I'm going to hit enter. And the server gave an HTTP response to an HTTPS client. So I'm not sure why that's a problem because, like, I mean, I understand that it started up in HTTP, but I mean, I'm in development, so, you know, what else am I going to really do here? Let's see if I can just scroll up here and if there's anything else. And I could have swore that it installed a private key as we were doing this, because I remember seeing that there. So it was like a private key. Could have swore there was one, something about private key. So I'm not sure what the problem is here. I'll be back in a moment and I will resolve it, okay? So the suggestion I'm getting is that we need to export a couple of environment variables. So see here where it writes this. So we say you need to set the following. So maybe we will go through and set those. So I'll go grab that there. But here's the thing is, like, how do I run that? Because these are, I think these are like not the same. So, I mean, I can't run it over here, can I? I don't think so. Well, I guess if we're doing key vault value there, maybe we can. Still no good. What if we export the vault token? I think we said it was education here. Let's do vault status. So yeah, I'm not sure how we're going to do it that way. I mean, it's not a really big deal because I don't think that we have to access it that way. But notice here, like, as I was reading here, you know, they're just saying down below, oh, we had to set this and that. So I'm not really sure what I would do here. So the output is like this. Run these commands and it should do it. Again, the error message can be similar to different problems. So that, or maybe I'm just specifying the key incorrectly and that's why it doesn't like it. So let's just type in vault and see what we have here. So vault key v. Maybe if we do like a list, can we get a list? List the secrets. AWS. AWS. Clear. I'm not sure what parameter it wants there. Let's go look it up. So we'll say like or was it vault key v list option. Seems to want another parameter here. Going to scroll on down. So secret / my app. Folders are suffixed with the /. The input must be a folder. List of a file will not return. Do I have to put secret in front of it? Secret. AWS? No. So I don't know what the issue is there. It just would have been nice to use it via the CLI, but the thing is that, again, we don't need to use it that way. We just need to, set it and get it, but I thought it would be fun to kind of use the CLI there. So now that we have those set, the way we're going to extract out these values is by using a data source. And so what I want to do is just create a new local project. And I think we like to always pull from our account repo here. So I'm going to go all the way up to here, and I'm going to go grab the main, and I'm just going to copy the contents there. We're going to go all the way down to the ground, and we're going to make a new main TF file here. We're going to go paste that on in. And we just want my server. We don't need an output. It's fine. This is all fine. This is all fine. But the one thing is we don't want to use our particular provider there. So what I'm going to do is I'm going to just open up our credentials file there. And I'm just going to change this to something else like other so that it doesn't load that profile there. Okay, I'm going to just take these out of here. I think we can leave that alone. And I think that's everything. So what I want to do now, we don't need that count. We'll get rid of that count. We'll go check out the documentation or the code base here, because it gives us a bit of an idea how we need to implement this. We'll go over to the operator. We'll go over to the main. And so they're setting some variables here, like name, region, path, things like that. But again, we want to grab it from the source. They're actually cross-referencing it like this other, they provision the admin and grabbing it that way. I don't want to do it that way. I wanted to use just the data source like this. So I'm not sure how that's going to work. So let's go look that up. Okay, so here it says read AWS credentials from an AWS secret backend. And I'm not trying to do that. I'm just trying to read them from the key vaults. Okay, so we probably want vaults. Generic secret. Would this be from key vault? This resource is primarily intended to be used with the generic secret backend, but it is also compatible with any vault endpoint that is provided. But is that the key value one? That's not clear to me. So I think it is. So let's see if we can figure that out here. So I'm just going to move that off screen here. And we're going to add ourselves the data source. So I guess we're really not following that other tutorial at all, because we literally have to use a different key value there, eh? So we'll say secret, and this is going to be like AWS credentials maybe. Or maybe it's creds. I don't have to worry about spelling mistakes. And we need to specify a path. Notice it always starts with like secret. I don't know if we always have to start it with secret. So I will just say AWS here. And there might be some additional options. I'm just scrolling through to here. So you have path. So this is the full logical path from which to request the data. To read data from generic secret backend mountain vault by default, this should be prefixed with secret /. So we do have to do that. Reading from other backends as data source is possible. Consult each backend documentation to see which endpoint supports the get. Version of the secret to read. We only have a single version, so we don't have to specify that. So technically that should be correct. So what we will want to do now in our provider is specify all those options. So again, I'm just going back to the source code. This is off screen, but we need to set the region, the access key, and the secret key here. And so this is going to be data, and it's going to be vault generic secret, and I guess it would be AWS. And then we're accessing those things like region. And so I'm going to go ahead and just copy that really quickly. And we will go over back to our vault here because the names are over here. So go grab that, paste that in there. We'll go grab that, paste that in there. And I'm just going to double check to make sure if I've made any mistakes. This one, it's showing it from the admin, so it goes admin outputs, but we're not outputting from anything. We're just grabbing it from the vault there. So maybe what we need to do is just kind of review how this generic vault works. So this does data, vault generic, and then it does data and then square braces. So I wonder if we always have to do data. So for the example, the vault, there is a key named auth token. The value is a token that we need to keep secret. But yeah, I don't understand. Is this a JSON object or just a way of referencing it? Because it doesn't specify that. So we'll just give it a try. Nothing hurts with trying, right? So we'll say data. And this might not be the right way. I don't know if it's single or doubles there. It's doubles. So I could just wonder if that was like the one case where it's doubles. Okay, and we will do this. And so I think that should maybe work. Don't know. What I'm wondering is if I led with a /, would it have considered that? Or is it now double? But I don't think so, because look here, it looks like it stripped it out because it just says AWS here. So we go to secrets and it's just AWS. Almost looks like there's a space in the front of it, eh? But it's not there, so maybe there's not. It's just kind of like a little glitch. So we need to go and cd into this directory here. And we just need to do a Terraform init. That's kind of interesting because like we haven't set up the provider. I guess it's not going to happen until we actually use the provider, so maybe it's not an issue just yet. I'm curious to see if it pulls any kind of modules in for the vault generic secret. So we'll just give it a moment there to initialize. Okay, so after there, we can see that it did actually add vault in, so it must be ready to take it from there. I'm going to do a Terraform plan here. And you know what? I'm going to just change this to like my server with vault. Now remember, it's not going to be able to pull from the from our local credentials because we're not setting a profile and we overrode the default just in case. So here it's saying a data resource, vault generic secret, AWS has not been declared in the root module. It hasn't. I mean, it looks like I did. No, maybe I typed it wrong. So we'll go here. I don't think it matters, but I'll just put it above. Okay. And I'm just going to double check to make sure. Nope, it matches. Oh, because it's AWS creds. That's fair. You didn't use the option out. That's fine. So my question will be, will this correctly provision? Because we will not know until we use this right here. I suppose if we try to use a data source for AWS, that would probably also indicate whether it's working or not. So maybe we should try doing that. We could do like data, AWS VPC, and then we could just do like ID equals here, because that would have to use the credentials, right? And so we'll just go, well, that's actually, it's not specifying any of the VPC here. So maybe we won't do that because it's just too much work. So what I'll do here is I'm going to do a Terraform apply, auto approve, and let's cross our fingers and hope this works. And while that is running, what I'm going to do is just pull up my AWS environment here. And apparently I'm not logged in, so that'll give me a bit of time here to kind of catch up here while this is provisioning there. And so it looks like it actually provisioned the server, and if that's the case, that means that our secrets are being pulled correctly, right? So if we go over to EC2 here, and we go and check out this instance, it is running, so it worked. If we just want to do a sanity check to make sure it absolutely is working, we can just introduce a bug into this. So maybe we go here and we just say, I guess we'd have to make a new version, create a new version. And what I'm going to do is purposely introduce a mistake. So we're just going to put like an @ sign here on the end. We're going to save that. And I'm going to make a minor change like nano. And so what I'm expecting is for this to fail. Let's see if it fails on the plan. I don't think it will. I think it would fail on the apply. And it does. Okay, so the plan would tell us whether it didn't work or not. So that clearly means it absolutely is pulling from it, especially when we're doing the plan. So I want to go back to our file there. I just kind of lost the folder. I'm just looking for it. I got too many Chrome windows open here. There it is. Okay, so we'll go back here and I wonder if we can just revert back to the previous version. See, I don't know if I went delete there. I don't want to jinx it. So I'm just going to go here and take out that @ sign. We're going to go ahead and save that. And so that should be updated. We're going to do Terraform plan. Great. And so what I want to do is just tear this down. So we'll say Terraform apply, auto approve, and destroy. Okay. And while that is destroying, I'm pretty confident that's going to work. I'm going to stop my vault server. Oh, wait. Is that going to still work? Did I get the credentials in time? Oh, no. I made a big boo-boo. Okay. So I killed my vault server before I was supposed to. That's really embarrassing. Anyway, that's not a big deal because I kind of wanted to stop the server anyway. But I want to go back into our AWS credentials there and turn that back to defaults. And I wanted to go back up here and just flip that back so that we can get rid of the server, right? So I don't want to kind of lose these for the tutorial. So I'm just going to go here and just comment those out for a second. Profile, default. Oops. Region US East 1. And we'll do that again. That's embarrassing. Okay, and I'm just going to preemptively, I'm not going to save this file, but I'm just going to do this for now. It's still trying to connect. Oh boy. So just put these back in here. Because it's set to the vault, can I do a Terraform refresh? Probably not. No, probably not. What if I do a Terraform init? Because I did change, like I was using vault, so maybe I just have to do that to fix that problem. And let's try destroy again. That was a big boo-boo on my part, eh? Nope. Okay, so let's go back over here and start it up again. And I'm pretty sure there's like a way to back up your vaults. Like there's probably like some kind of like snapshot or something. Again, I'm not that deep into it, so I cannot tell you if that's the case. So I guess we'll just go back here and remake our secrets. Because it shouldn't have persisted, right? If it did, I'd be so happy. Nope. Okay. AWS, we'll leave 10 in there, and then we'll just have to copy all the stuff over again because of my bonehead mistake there. So we have region, which is US East 1. US East 1 here. And go over here. Well, at least you know what to do if that happens to you, okay? I don't need the equal sign there. Go ahead and add this one. Okay, and what we're going to do is go ahead and save that. And we'll just quit out of that. We'll do a Terraform plan, since we know that that will pick it up, right? Great. And we'll do Terraform apply, auto approve, destroy. Okay, so again, this only applies to development, but yeah, don't kill your vault server before you're done destroying, okay? So I'll see you back here in a moment. All right, so that infrastructure is destroyed. We can go back to here, and then we can stop our server. And for your benefit, I'm just going to bring back these in here, so you don't have to worry about that. And yeah, we accomplished Vault for injections. Now, you might say, well, how would you do this with Terraform Cloud? Well, the thing is that Terraform Cloud already uses Vault under the hood when you store your environment variables there. And the idea is that I suppose you don't need to pull them in from all those sources. But I think that was one of my questions I had when I was talking to one of the DAs, which was like, okay, it's great that Terraform Cloud has, you know, uses Vault behind the scenes, but what if I want that to live somewhere else? But maybe that's not really necessary because I don't know. But yeah, that's it. So we're all done with Vault. Hey, this is Andrew Brown from ExamPro, and we are taking a look at Atlantis, which is an open source developer tool to automate Terraform pull requests, which you can find at runatlantis.io. So the idea is once this is installed on your GitHub and you merge a pull request, then it's going to go ahead and do a Terraform apply. So this would be a way for you to do GitOps or to automate your infrastructure as code. And the interesting thing is that HashiCorp actually maintains this project. They didn't originally build it. It was built by two people from another company. And it wasn't that they did not want to use Terraform Cloud, which can do this. But at the time, I think they had a hard time at the company getting procurement because it was a very large company. And so they had to build something. So they built out this thing. Anyway, these two people end up getting hired by HashiCorp, and HashiCorp maintains this project, which is really nice because it is an alternative for Terraform Cloud. Yeah, that's all. Let's take a look at CDK for Terraform. And so to understand this, we need to first understand what is CDK. So AWS Cloud Development Kit is an imperative infrastructure as code tool with SDKs for your favorite language. So the idea is that you can use something like TypeScript, Python, Java, C#, Go, and Ruby. Ruby's definitely there. That's the language I like to use. And AWS CDK is intended only for AWS Cloud resources because CDK generates out CloudFormation, so CFN templates. This is known as synthesizing and uses that for IaC. But CDK for Terraform is a standalone project by HashiCorp that allows you to use CDK, but instead of CFN templates it generates out, it's going to generate out Terraform templates. And so basically anything Terraform can do, you can do it through CDK. And that allows you to do interesting things like use CDK to provision Azure resources. So that is very interesting and a great development that I think that they're doing. Hey, this is Andrew Brown from ExamPro, and we are taking a look at Gruntwork, which is a software company that builds DevOps tools that extends or leverages Terraform. The reason we're talking about them is that they produce a couple of very popular open source tools that work with Terraform, and you're going to see their name because you know, the co-founders there are very active in the community. Jim has written a really good book on Terraform, so you know, it's no surprise that they are present, but it's worth giving them a mention so you know who they are. The first thing I want to mention is the infrastructure as a code library. So these are a bunch of reusable, battle-tested, production-ready infrastructure code for AWS, GCP, Azure. And so they have some free ones there and some paid ones there. Then there's TerraGrunt, so a thin wrapper that provides extra tools for keeping your configurations dry. We have TerraTest, a testing framework for infrastructure provisioned with Terraform. We have Gruntwork landing zones for AWS. This is a multi-account security on AWS. We have Gruntwork pipelines, and then there's the Gruntwork reference architecture. And so where we're going to focus our attention here is just on TerraGrunt and TerraTest, because those are things I think are essential to know if you are using Terraform, because you'll run into those use cases where you might want to use them. Okay. All right, let's take a look here at TerraGrunt. So this is a thin wrapper for Terraform that provides extra tools for keeping your configuration dry, working with multiple Terraform modules, managing remote state, and this is accessible at the terragrunt.gruntwork.io. So the idea here is the concept of don't repeat yourself. So it's a programming methodology to abstract repeated code into functions and modules or libraries, and often in isolate files to reduce code complexity, efforts, and errors. So the way that works is that you'll see these HCL files, which are the TerraGrunt code, and they're actually named terragrunt.hcl. And that's what's going to be used to abstract away or dry up your Terraform files. So here is an example of TerraGrunt. Now, TerraGrunt does a lot of different things, and you're going to find its use when you actually use Terraform in practice and you run into these limitations in Terraform and you go, man, I wish there was a way around it. And TerraGrunt almost always solves that. And so one example is being able to generate dynamic providers. And I don't mean like dynamic values here in the sense that there's that dynamic value feature of Terraform, but I just mean the fact that at the time of this, it's very hard to inject or to write out providers. So they have this generate function that allows you to get around that. Another really interesting thing is that TerraGrunt supports better granularity for modules by reducing lots of boilerplate. The way they do this is that you are referencing your Terraform files via the source here. Okay, so you're not including your modules within your code, you're just referencing them, and then you pass along their inputs. And this is going to be very important when we look at wanting to write unit tests for your infrastructure, because when you learn about how you test IaC, you have to really break things down into smaller parts. And if you have a lot of friction there, it's going to make your team not want to adopt that, or it's going to make that process really slow. But again, this is more like at scale or when you hit these kind of requirements, okay? All right, let's take a look here at testing in Terraform. And so what we have here on the left-hand side is our usual pyramid that tells us the layers of testing. And so I kind of want to walk through the layers there and talk about a bit of the tools that are available to the Terraform community, and the reason why we'd want to move up the pyramid here to get better tests. And then we'll take a look at TerraTest. So at the bottom we have static analysis, and this is where you test your code without deploying. And you've been doing it all along. When you do Terraform Validate, Terraform Plan, or you're using Sentinel, you're doing static analysis. And that just means that we're testing, like the composition or the shape of our code, or like its outputs to what it says it should be doing. Okay, but you can't catch all your problems there, and that's where you move on to unit testing. And unit testing, traditionally means, like in programming, to test like a particular function, its inputs and its outputs. It's a little bit harder for infrastructure because, you have to have it connected to other things. So the definition is a little bit warped, but the idea here, and specifically with Terraform, is you're just testing a single module. And that really says like, okay, well, you need to really pare down that module to be of the small scope. And that's where you end up dividing your modules into very small units of work. And so for tooling here, we got TerraTest, Kitchen, Terraform, and Inspec. And so, that's where that motivation came with, TerraGrunt, the last thing, saying, okay, let's split them up into smaller stuff. We have integration testing. This is pretty much just using multiple modules together. So you say, okay, well, I know that this Lambda function is working, but do I know it works in conjunction with this SQSQ or something like that? Then you have end-to-end testing, and this is where you're testing basically like business use cases. So it's not just saying, okay, from a technical perspective, but from a business use case, or the customer use case, do we meet the requirements here? And this is very hard because what you have to actually do is set up a persistent test network environment. But once you have one, you're going to be in really good shape. One example of a test environment, and it is paid, but Gruntwork has their own called the Gruntwork Reference Architecture. But if you had to do it without that, you'd have to just roll your own kind of environment. So, if you do want a good breakdown of all these different kinds, Jim from Gruntwork has a complete talk on automated testing for infrastructure as code. I strongly recommend it because it really gives you a better scope than what I can cover here. But let's just go take a quick look at TerraTest. So TerraTest allows you to perform unit tests and integration tests on your infrastructure. It tests your infrastructure by temporarily deploying it, validating the results, then tearing down the test environment. And so here's an example of what a test function would look like in TerraTest. It is written in Golang. I know Golang can be very hard to use, but you don't need to know much about it. If you pretty much copy and paste it and then just kind of tweak the values to get the result you want. So, hopefully that helps to tell you how you would test in Terraform and you know a bit about TerraTest, okay?